Phishing email messages are very common. There are so many ways that malicious users can attempt to trick people into clicking on buttons or downloading and opening file attachments. Here we've got an example that appears to have come from Home Depot. But one of the first things we want to watch out for is the email address. This email address does not have anywhere in it anything that looks close to a Home Depot email address. Looks very suspicious. And so that is a red flag immediately. So this is about somehow claiming a reward. Well, everyone likes free stuff. However, down below, you have been selected for a reward from Home Depot. Claim now. I hover my mouse over that Claim Now button. In the bottom left, I can see the URL that it's pointing to, drivewebs.com, and then all kind of other text. Now, for all we know, that could be an obfuscated type of URL that actually points to a malicious user website. So certainly, I'm not going to be clicking that button. The other thing is that if I scroll all the way down to the bottom of the email message, there's an awful lot of weird-looking stuff. That doesn't look normal. So why don't we go back up, and what I want to do here is I'm going to right-click on the Claim Now button, not left-click, because I want to copy the link. We're going to test it out using an online tool to see if the online tool thinks it's malicious or not. Now, there are many of these types of online scanners that are out there, so make sure you use a reputable one. And this one happens to be one that I'm going to be using in this example. So I'm going to paste in that URL I've just copied, and I'm going to press Enter. And so now it's begun an analysis of that URL. Let's see what it comes up with. Okay, so the URL itself looks safe. However, there might be suspicious activity or reputational issues with that URL. I have the IP address information. It hasn't detected any specific malware, but attackers are pretty clever. There are easy ways to obfuscate code so that it doesn't get detected by malware scanners. However, we do have a risk score of 70, where 0 is 100% clean and 100 is high risk. Is there anything else about that one? Nothing specifically. Now, we don't want to necessarily put all of our eggs in one basket and trust exactly what this type of a URL analysis report will tell us, but it's a safe bet that we shouldn't be clicking on that button. Okay, what do we have next? Well, we have an email message about something called pCloud. pCloud is a personal cloud storage facility similar to what you would get with Google Drive, Microsoft OneDrive, or Dropbox, that kind of thing. If I scroll down, apparently I've got a user, and it looks like it's a Russian email address, has sent me a shared link, and it's for a PDF, and see photos Cindy. Okay, so this sounds bad already because the grammar is incorrect. And why would someone randomly send me a link to pictures of themselves? It just doesn't seem to add up. So I've got a button here to open the link. If I hover over that button in the bottom left, indeed, it looks like it is a link to e.pcloud.com, but there's no way I'm going to click that. I didn't ask for this message, and even if I did, it's pretty suspicious, and I'm better off ignoring it. Now I'm going to do what we did previously. I'm going to paste that URL into some kind of a checking tool where it can go ahead and analyze that URL. And down below, looks like suspicious activity. Okay, let's see as we scroll down. Currently parked domain, and the domain was recently used for spam. That's bad news. This should not be trusted. But really, we shouldn't have to rely on this. If we're getting those kinds of suspicious email messages and we didn't ask for them, that enough should be a trigger. Oh yeah, here's another good one. This apparently is from the Canada Revenue Agency. I am a Canadian citizen, so any messages from CRA are always going to be of interest, presumably. This is about receiving my $318.12 Canadian. However, immediately, the email address does not make me think this is really from the CRA, and a lot of agencies like the Canadian Revenue Agency, CRA, they will not communicate with you this way. You might get a notification that says if you sign into your tax account online, we've got a message for you, but they're not going to directly do this type of thing. Anyway, this is going to be appealing to a lot of people because in order to claim what apparently is a tax refund, they've got a link that they can click on. So if I hover over that link down at the bottom, again, if I look in the bottom left here, that does not look anything like a CRA type of link. It's pointing to something on a site, specifically a file, an index.php file. There's no way I'm going to be clicking on that. So there's another type of phishing email message. Here's one of those extortion type of email messages that says it knows what my password is, that the computer was infected with a remote administration tool, so malware, and that the camera was on in this machine. And if you don't want the video sent out to everyone in your contact list, then go ahead and pay $900 in Bitcoin. So this is what we have to deal with when it comes to phishing email messages. People need to be made aware in organizations and at an individual personal level that this stuff happens all the time and not to fall for it. In this demonstration, I'll be deploying a Windows Server 2019 virtual machine on VMware Workstation 16 Pro. Now remember that VMware Workstation is a Type 2 hypervisor, and so what that means is it is not the operating system. Instead, it relies upon an underlying operating system. And in this case, it's just running on Windows 10. Now, while that might not be suitable for mission-critical enterprise workloads, it certainly works just fine for testing or software development. Now, the thing to bear in mind is that VMware Workstation in this context depends on the underlying operating system security configuration. So we have to have hardened our Windows 10 machine, applied patches, disabled unnecessary components, enabled the Windows Defender firewall, and so on to limit access to this host. So to get started with creating the virtual machine, I'm going to click Create a Virtual Machine. It's going to be typical, so I'll choose Next. And I'm going to tell it for now that I will install the operating system later. I do have the ISO disk image file, but I'm not going to specify it here initially. So I'll click Next. It's going to be the Microsoft Windows guest operating system. Windows Server 2019 is the version from the list. I'll choose Next. I have to give this a name. Windows Server 2019 is just fine, but then I have to specify where I want that stored. So from here, I could specify a location. So maybe here I'll choose drive D data, and I'll make a new VMs folder. And I will just select that VMs folder. There it is, DVMs, and I'll click Next. It's going to make a 60 gig disk, virtual hard disk. I can modify that configuration later and add more disks. So I'm just going to leave the defaults and click Next. I could choose Customize Hardware, or I could change this after the fact. So it's going to allocate 2 gigabytes of memory, although we could drag the slider up or down depending on whether we need more or less RAM. With the vCPUs, the virtual CPUs, I will leave it on 2. It's going to automatically add a CD or DVD device and a network adapter, which is currently set to be configured through NAT to share the host's IP address to communicate on the network. We could choose bridged so that it communicates on the network as a regular host would. And so, for instance, if we have DHCP handing out IP configs, it will also hand out an IP config to this virtual network interface. Or it could be a host-only configuration so that this virtual machine cannot receive or transmit packets outside of this Type 2 hypervisor host. So we could do all that, but I'm going to leave it, let's say in this case, on host only, a private network shared with the host. The reason I might do that is because I don't want it communicating on the real network. Maybe I'm using this as a sandbox testing environment. So I'm okay with the hardware. I'm just going to click Close, and I'll click Finish. So it's establishing the folder structure on drive D for our Windows Server 2019 virtual machine. If I were to choose Edit Virtual Machine Settings, this of course is where we would have a lot of the same hardware we just looked at the summary screen of the wizard. We could click Add and add additional items, like perhaps I'll add a second hard disk and I'll just accept all the defaults. And so now we have 2 60 gigabyte disks. Now I'm going to click on my CD DVD device, and on the right I'm going to choose Use ISO Image File, and I'm going to browse for the Windows Server 2019 ISO that I would have already downloaded. And then I'll just go ahead and click OK. And then I'll click power on this virtual machine, and I'll click inside the window and press any key, as it says, to boot from CD or DVD. So at this point, it's really no different than if I were installing the operating system on a physical server. It just happens to be a virtual machine in VMware Workstation. So I'm going to go ahead and accept the defaults for things like the language and the keyboard layout, and I'll click Next, and I'll just choose Install Now. The next thing I'll do is select Windows Server 2019 Data Center Evaluation as opposed to Standard Edition. So I want the data center, so I'll click Next. I'll then turn on the check mark to accept the license terms. I'll click Next again. And I'm going to choose the custom option to install Windows only. I'm going to put it on the first drive. So drive 060 gig, that's our first virtual hard disk. And now it's begun the process of getting the files ready and then actually copying them to that boot disk. Now remember that we are installing this Windows Server manually from the original source media. That means it's going to be way out of date. And so part of hardening is to make sure all of the software updates are applied. So that's going to be the first thing that we need to do after we get this up and running. Now that's why sometimes if you're deploying from an image that you've created previously and kept up to date, it can quickly launch your virtual machine, and once it's up and running, it's already up to date. But here, we're going to have to do that ourselves. So in order for us to be able to reach out to Windows Update on the internet, we're going to have to go back and modify our virtual network configuration. We can do that now. I can go to VM Settings, and currently our network adapter is host only, but I'm going to choose Bridged, so it actually participates as any other device on the LAN, which will allow me out to the internet to complete the Windows Update. Now, after I've done that, then I can switch back to host only if that's how I want this virtual machine's communication to be configured. Okay, so the administrator account will be created. I'm going to go ahead and specify a password, after which I'll have to confirm that password to make sure they are the same so I know how to get into my own virtual machine. And once we've done that, I'll just press Enter to continue moving on in the installation. And we're ready to go. We're ready to sign in. So it says press Control-Alt-Delete to unlock. So I can just go to the VM menu, send Control-Alt-Delete. We know we're signing in as administrator. I'll just put in the password that I've just configured for this VM, and then we'll be inside the OS. So we're within the virtual machine guest. So the Server Manager tool launches automatically on a new, fresh Windows Server 2019 installation. I'm going to go to the Manage menu and Server Manager Properties and tell it not to start automatically. And then I'll go ahead and close that out. So the screen res here doesn't quite match everything that I'm running this on. So if I go to View Full Screen, we still don't quite have a perfect match here. So what I could do then to fix this is I could tell it I want the virtual machine to stretch. So I could open up my workstation menu at the top, go to View, and choose Stretch Guest, and keep aspect ratio stretch, which I want to do because I want to go into PowerShell. And within PowerShell here, I'm just going to enlarge it so we can see what we're working with. So I'll go to the Font tab, maybe choose 24, and I'm going to type ipconfig. So we've got an IP address in the range that would apply to our network. So what I'm going to do now is just exit out of PowerShell with exit, and we're just going to go to the Windows Update option here. So for my Start menu, I'll just search for the word Update, and I'll choose Check for Updates. And then I'll click on the Check for Updates button. So as you might imagine, there are plenty of updates that are missing on this newly installed Server 2019 virtual machine, and so it's going to go ahead and bring those updates down. And at this point, once those are all brought down, we would harden this virtual machine operating system just as we would if it were running on a physical host. Meaning, for instance, I might go to my Start menu, maybe I'll type in Defender, and I would open up the Windows Defender Firewall and configure it accordingly to either allow or deny traffic into and out of this virtual machine host. So we would do all of our standard hardening, like going and disabling unnecessary services in the Services Control Panel, which I can search for here in my Start menu, find items that perhaps we know that we don't need, and then go into the properties of it, and we could choose to stop that service and make sure that the startup type, for example, is set to manual or disabled if we don't want it to be started by another process. In this demonstration, I'm going to be configuring a Linux virtual machine on premises. Specifically, I'm going to use the latest free Kali Linux ISO to run a live version of Kali Linux on premises. So I can use that for things like vulnerability scanning, network reconnaissance, and basically testing the security of my environment. So to get started here in VMware Workstation, which is a Type 2 hypervisor, my underlying Windows OS is already hardened. I'm going to click Create New Virtual Machine. I'll choose Next. I'll choose I will install the operating system later, and it's going to be Linux. Now from here, I can select the appropriate type of Linux kernel. Now, Ubuntu Linux is based on the Debian distribution, so I could choose Debian 10.x 64-bit, and next, I'm going to call this Kali Linux, and I'm going to browse for where to create this. I'm going to go down to drive D, where I've already got a folder called VMs. I'll make a new folder called Kali. It's selected, and I'll choose OK, and then I will choose Next. It's going to make a 20 gig drive. Now, if you're going to install Kali Linux, then you'll need some space, but otherwise, if you're just going to run it live off of the DVD ISO image, then you might only need minimal storage space, depending on if you want somewhere to store files and so on that will persist between reboots. So I'm going to leave the default 20 gig drive. Next, it's going to use NAT by default. I'm going to choose Customize Hardware here, and I'm going to change my network adapter to be bridged. And actually, while I'm here, I could have done this earlier, but I'm going to go to the DVD and choose Use ISO Image File. And I'm going to specify the path of the latest Kali Linux ISO image, which is free to download. Okay, so I'm happy with that. I'm going to close that and choose Finish to essentially create the shell of my virtual machine for Kali Linux. And then I'm going to choose Power on this virtual machine. So at this point, it's going to go ahead and give me the option as to whether I want to run live Kali Linux. Notice I do have options here where I could do a graphical install or just a regular install. So depending on what you're going to be doing will determine if you just want to run it off the ISO or not. If, for example, you're going to want to install customized packages and make sure they're all up to date and have that retained, well then you could choose to install it. However, in this case, I'm just going to run it live, AMD 64, and I'll press Enter to continue booting into that mode. Now here in VMware Workstation, I'll press Ctrl-Alt to release the mouse. And down below, it just says here that when you're installing this, you should install it as you would on a physical computer. And then when you're done and the operating system starts up, click I finished installing. So I'm just going to click the X. We don't need to see that there. And at this point, Kali Linux is loading. We're running the live version of it. So once it fires up, we're just going to verify that we are on the network. Okay, so looking good. We've got the default Kali Linux screen that we've signed into on the desktop. That happened automatically. So I'm going to go ahead and just click the terminal window icon up at the top so we can go ahead and take a peek to see what we've got going here. So first thing I'm interested in doing is typing ifconfig. When I do that for the ETH0 interface, I've got an IP address in the 192.168.4 range, which is what I happen to be using on my local area network. Now remember we added that 20 gig virtual hard disk to this virtual machine, even though we're running Kali Linux off of the live boot ISO. So we could store things like packet captures or password dumps or whatever we wanted to there, but we have to make it usable before that's possible. So I'm going to run sudo fdisk/dev/sda. Actually, let's remove the sudo because if I don't include that prefix, I get a permission denied message because if I type who am I, I'm logged in as user Kali. I'm not logged in with the root account. Okay, so let's do that again, meaning I'm going to use the up arrow key to go back to the fdisk command, except I'm going to prefix it with sudo to run it with elevated privileges. That puts me in the fdisk interactive menu. I'm going to press N for a new primary partition, so P for primary, and I'll accept the default of primary 1, and I'll just keep pressing enter for the first and last sector. I want to use the whole disk. Then I'm going to type in the letter W for write, and that's it. So now if I were to do sudo fdisk, let's say -L, what we're going to notice is that we've got our /dev/sda device, but we do also have our partition on that device, which is labeled as /dev/sda partition 1. So from here, I can then use commands like sudo makefs for make file system -type, let's say ext3 if that's the file system I want to use for /dev/sda. 1. So basically, I'm formatting the file system so that I can use it. Once that's done, I'm going to run sudo make dir, and on the root, I'm going to put here, let's say, HD for hard drive. And what I could then do is run sudo mount. And what I want to do is mount /dev/sda1, the partition we just created, /HD. Now when I go into the /HD folder, of course, there's nothing in there if I type ls, but if I were to say touch file1.txt, of course, we'll have to do sudo touch file1.txt. After we clear the screen and do an ls, the file has been written here. So we've just made some permanent storage where we can store things like packet captures, password dumps, maybe dictionary lists for password cracking, and so on. In this demonstration, I'm going to talk about how to encrypt a virtual machine. Now, encryption for virtual machines is done differently depending on the virtualization solution that you're using. In this particular case, I'm going to be encrypting using VMware Workstation Pro, a Type 2 hypervisor. Because another way you could interpret virtual machine encryption is to encrypt the virtual hard disks within the operating system. So using things like Windows BitLocker, let's say. However, here I'm going to do it at the hypervisor level. So I've already got a Kali Linux virtual machine here, and it's up and running in VMware Workstation. Now, the fact that it's up and running is important in our example because with it up and running and selected, if I were to go to the VM menu and then choose settings for this VM, now encryption options for this will be found under the Options tab. And when I click Access Control Not Encrypted, that's the current state. Over on the right, it says it's not encrypted, but you can't do anything about it because it's powered on. Oh yes, okay, so cancel. And from my power menu up here, I'm just going to choose to shut down the virtual machine guest. All right, so Kali Linux is no longer running. Let's try this again, except this time I'll just click Edit Virtual Machine Settings over on the left. And once again, I will go to the Options tab at the top. I'll click Access Control, and now on the right, the Encrypt button is available because the VM is no longer powered on. So I'm going to click Encrypt. This is where it's going to require me to enter a passphrase, which I will enter, and of course, I need to confirm it to make sure I know what I typed in. Last thing you want to do is not know what you typed in and be unable to decrypt a production virtual machine. So now that I've done that, I will click the Encrypt button. Now, depending on how much is going on in that virtual machine, how many disks there are, how full they are, and so on, will determine how long that would take. Now, there's not much going on with that virtual machine at all because it's Kali Linux and I'm really running it live from the ISO device. So if I go to the hardware tab and go to the DVD, I'm just pointing to the ISO image. I'm just running it live off of that. Mind you, I do have a 20 gig hard disk that I've partitioned and formatted, but the OS isn't on it. So there's not really much there. The current size of that is only 21 megabytes. So we can see why it was encrypted so quickly. So let's see how this behaves. I'm going to click OK. Now, if I try to power on the virtual machine, it will let me power it on because I'm already in VMware Workstation. But I wonder what would happen. Let me just shut down that guest. I wonder what would happen if I were to exit VMware Workstation and come back in. Okay, so I've come back into VMware Workstation, and the first thing I notice is that my Linux Virtual Machine tab has a little padlock on it. And so it says the virtual machine is encrypted. I must enter the password to continue. So if I do not know the password, then I can't authenticate. I can't do anything. I can't even see the configuration. So I'm going to go ahead and enter in the correct passphrase, after which, when I do that, I'm then back to normal. I don't have the padlock icon anymore because the virtual machine is no longer locked. It's not encrypted at this point. And over on the left, I have what I normally would expect to see. I have the settings. I can click Edit Virtual Machine Settings and get to that and make changes. And also, I can, of course, power on that virtual machine. When you want to run application containers on premises, you're going to need a host that supports running containers. In this case, I want to be able to run Docker containers. And so I've gone out to the internet to hub.docker.com because I want to download and install Docker Desktop for Windows. Now, when you work with application containers, remember that the application container does not contain the OS, just the files to run whatever the app is supposed to do. Now, the other thing to bear in mind is that if that app is based on Linux stuff, you're going to need to make sure your underlying host supports Linux. Now, I'm running Windows 10, so running Windows-based containers is not a problem, but to run Linux containers, it might prompt me to install the Windows Subsystem for Linux, or WSL, and then I will have my support to run Linux-based containers. So at any rate, to get started with this, I'm going to click the Get Docker button. Now then it wants me to save this, so I'm just going to go ahead and save that in my local downloads folder. And once that's done, I'll click Open File to open my download to start the installation. So here, it's going to install the required Windows components for the Windows Subsystem for Linux version 2, so WSL 2, and add a Docker shortcut to my desktop. Sure, let's do it. I'm going to click OK to get the installation going. And once the installation is completed, which won't take very long, I'm going to choose Close and Restart. So I've rebooted and I've launched the Docker icon on my desktop, and it starts with this little message about getting started with Docker and going through a tutorial. Essentially, it's showing me how to go to a command prompt here in PowerShell, but a regular Windows command prompt would work to start using Docker commands. So let's go ahead and open up a command prompt to see if the installation successfully installed the Docker CLI, the Docker command line interface. So I've started a command prompt with administrative privileges here on that same machine. If I simply type in Docker and just press Enter, it should at least recognize that Docker is a valid command, and it does, because what it is now showing me are the next level commands. For example, what I want to do, I'm just going to clear the screen, is I want to run a container. So what I could do is I could first run docker pull, and I want to pull down a container image called caddy. Now, how does it know where to pull it from? It's automatically going to check Docker Hub. There are public and private repositories on the internet with Docker images. This one is a public one, and it has a very small, lightweight HTTP web server. So I'm going to go ahead and pull that down. It assumes I want to pull down the latest version, so it's pulling it down over the internet. Now we can verify that it's here. That was very quick because it was very small, by typing Docker images. When I do that, the caddy latest version of that container image is now available on this host. So I could go ahead and use Docker run. Now I want this, let's say, to run in interactive mode with the terminal, so -IT. And also I want to do a port mapping, basically -P. I want to map port 80 on my host to port 80 in the container because I know it's got a web server in it. And of course, the container image, which we see from the previous command, is called caddy. So I'm going to go ahead and press Enter to fire that up. Okay, so we have some messages here telling me that it's listening on the HTTP port. Now this is interesting because imagine that you're running a vulnerability scan on your network to see if there are any web servers that are running that shouldn't be. And periodically on the same host, sometimes the web server's running, other times it's not. And so you inspect that host and there's no web server installed. What's happening? Maybe it's being spawned when a container image is started. So I'm going to go ahead and looks like we are good to go here. Looks like it's up and running. So let's see what happens when we hit port 80 on this host in a web browser. So when I connect to localhost, and I could specify :80 for port 80, but it's implied in my web browser, we know it's working because we have the caddy web page, the default web page in that container that is actually popping up. Now to exit the running container and actually stop it at the same time, I can go back to my Docker screen where I ran that and press Control-C. And now it's no longer running. Now we can verify this by typing Docker PS. For any running containers, we would have a listing here. Of course, if I run Docker images, we still have the image available locally. It's just not running right now. So what I'm going to do is use Docker run, but we're going to run it in the background this time with -D. I still want to do my port mapping because I know it is an HTTP-based app within the container. And I'll tell it we want to run caddy. And so after a moment, we get an ID returned back, and that's it. Is it running? Is it not? Well, we can verify this with Docker PS. Now what happens is it will give it a generated name here. And that generated name we can use if we want to start managing that container. First, let's make sure it's still running. So I've exited my web browser just to be safe and restarted it and connected to localhost. And sure enough, the CAD container is up and running. Back here at the Docker CLI, I could enter Docker stop if I want to stop that containerized app from running. And I can put in the generated name to bring it down. Now we can verify this in a couple of ways, one of which, of course, is Docker PS. It's no longer listed. Of course, let's go back to the web browser and see what we get if we try to refresh the web page. So I'm going to refresh the browser, and as you might guess, it's basically going to time out and it can't reach that page because the container is no longer running. So really, it's just a web app. What's different here is how it is launched and where it is stored. It's all containerized. And as a cybersecurity specialist, you will need to know this because when you run vulnerability scans, or when you want to bring down web servers, or if you want to harden an environment and reduce the attack surface, you have to be aware that this is yet another way that a web app can be launched and up and running. In this demonstration, I'm going to be creating a container registry. Now, this is for container images for application containers. We can do this on premises if we're using an on-premises solution like a Docker server, but in this case, I'm going to do it in a cloud computing environment. I happen to be using Microsoft Azure, but there are other cloud providers that will support the same thing. Having a container registry, which is a centralized repository in the cloud. So here in the Azure portal, I've already signed in with my account. I'm going to click Create a Resource in the upper left, and I'm going to search for Registry. And from the list, I'm going to choose Container Registry. The reason I would do this is because I want a centralized place to store customized container images. Maybe we want to do this because we want an easy way to have customized application containers that might be used by admins with tools for re-imaging stations or recovering deleted files or running security scans, or for software developers where we've got pre-configured container images with all the software development tools and stuff that they would need, maybe even a small web server stack. So this way we could have this collection of container images hosted entirely under our control. That's why I would do this. So Container Registry, I'll click Create. Now I'm going to have to deploy this into what's called a resource group. I'm going to choose Create New. This is going to be called Testing. In the Microsoft Azure Cloud, a resource group is just a way to organize cloud resources together that are related, such as those for testing, or for a project, or for a department. In this case, testing. So I'll click OK. I want to call this Container Registry YHZ. What it's going to do is verify that that is a unique name, and it's going to append the .azure.cr for Azure Container Registry .io DNS suffix. I then decide where I want this hosted geographically. So in this case, I'll choose Canada East because that's where I am and where the people that will be using these container images reside. And I could change the SKU to premium if I want it to be more scalable, but I'm going to leave it as it is because I'm only going to be working with a few container images. Next, for networking, because I'm not using the premium SKU, I can't limit from which networks connectivity will be allowed to this container registry. I'm okay with that. Same with encryption. Can't do it. Not going to add tag metadata, and so I'll just click Create to create this container registry. It won't take long before here in the cloud the deployment is complete. I could either click the Go to Resource button to go right to the container registry, but in the future, for example, if I click Home here, I can go into the All Resources view. Now, if I don't have that there, I can open it up over in the left-hand navigator. So what we're going to see is the only resource we have here in the Azure cloud is our container registry. So I can click to open it up. Now, what's interesting is that if I scroll down the Properties navigation bar for the container registry, on Services over on the left, if I click Repositories, we don't have anything here. Well, of course, we've just created this registry. We've not yet pushed any types of container images here yet. So we're going to see how to do that. But first, if I click Access Keys, here I have the name of the registry, including the fully qualified DNS name. And I can also enable the admin user, where the username is going to be the name of the registry, and then I've got these 2 generated passwords. I can use either one. You have 2 because if you want to keep one for a while, you can periodically regenerate the other for security purposes, and then you could do the same thing in reverse. So what I want to do then is I want to make sure that I can authenticate to this container registry, and then I want to make sure I can populate it with customized container images. Now, I'm not the only one that wants to do that. So do malicious users. If a malicious user can authenticate, if they get this information somehow, perhaps through social engineering, think of what they could do. They could push up tainted container images that might have backdoors or malware built into it. And if our software developers, as an example, use these to build new app components, we're in trouble. So we want to make sure that we safeguard these credentials. Now, to get the instructions on that, I could click Quick Start over here on the left, where it says, hey, what you could do is run Docker login. So you're going to need the Docker CLI, the command line interface. Because I've already installed Docker Hub on my Windows station, I've already got that, so I'm good to go. So Docker login, and then the fully qualified DNS name of my container registry. The next thing I'm going to do, if I want to push something to the registry, is I'm going to use the Docker tag command to tag a container image. Let's say we have a container image called Hello World, and I have to rename it or tag it so that the first part of the name, the prefix, is the name of the registry where I'm going to ultimately push it. So my container registry with the slash, followed by whatever I want to call that container image. And I could also put a colon after that and put a version number or version string. And then I can use Docker push to actually push that container image, now that it's been renamed, to the container image. I don't have to tell it the name of that repository because it's already part of the name. We can also then, in the future, when we actually want to start using these containers, pull them down from the registry using Docker pull. So let's go ahead and switch over to the command line on this machine where I've already installed Docker Hub, and let's run some of these commands. Okay, so in the command prompt, I'm going to run Docker login and then the fully qualified name of my container registry, and I'll press enter. It wants the username. Now remember that the username is actually the name of the registry. So in this case, container registry, YHZ. Then I'm going to enter in one of those 2 passwords. I'll just copy it and paste it in here. And once I've done that and pressed enter, I get a message return that says login succeeded. So I'm in. Now, if I run Docker images, I've already got an image that I've pulled down with the Docker pull command. So what I had issued originally was Docker pull caddy, and I didn't specify any repositories. So it automatically assumed I wanted to pull that down from Docker Hub on the internet, which it did. And that's why I have it. So let's say I want that caddy container image, which is essentially just a small HTTP web server image. I want that to be in my container repository. So what I will do is tag it. So I'm going to use Docker tag. It's currently called caddy. What I want to do is I want to tag it so that the name prefix, I'll just copy the name of my registry up here. That's part of the prefix slash, and I'll call it caddy, let's say colon version 1. Now I can use Docker push and tell it that I want to push that specific version of that container image up to my Azure container registry. So let's go ahead and do that. And so it's doing it. It's basically uploading it or pushing it to Microsoft Azure. We'll check that in a moment to make sure that it's been pushed up there successfully. Now, at the same time, we still have that container image available locally. So if I were to say Docker images, it is now showing here. Of course, we've got version 1. That's the one that we tagged. It's still available locally for me to work with. Now, the great thing about this too is, let's say I pull down a new container image from Docker Hub. So Docker pull, let's say Alpine Linux, just a very small, lightweight Linux container image. Okay, so now I want to run Docker run -it for interactive, and I want to open a terminal session with it, and it's called Alpine. So I'm going to go ahead and specify that. So in this case, because I told it I want to run in interactive mode, I'm given what appears to be a Linux bash shell command prompt where I could type ls Here's the file system within that container. Now remember, the Linux OS is not in the container. The only reason this is working is because I've got the Windows subsystem for Linux installed here on my Windows host, which was installed when I installed Docker Hub, which is also why I have the Docker CLI available in the first place. So at this point, I would make changes to the file system, put files in there, make config changes, whatever it is I want to do. And once again, if I want that to be in my Azure Container Registry, I would run docker tag. Maybe what I'll do is just use the up arrow key to go back up to my previous command. It'll save me some time. And the local container image is called Alpine. And so I'm just going to push that, let's say, up here. Let's assume we had customized it. So I'm going to push that up, call it version 1, and then I'm going to use docker push to push that up into our container registry. So the way we do that is we run docker push, and we give it the new name of our container image. So once again, we see it's pushing. So we should have 2 container images in our cloud-based repository now. So why don't we go check our work back in the Microsoft Azure Web Portal GUI. So back here in Azure, I'm going to scroll down and I'm going to click repositories on the left. And sure enough, there's Alpine, there's Caddy. And if I click on any one of them to open it up, we've got our version of that specific container image. In order to run an application container, you need somewhere to run it. You need, for example, the Docker engine that might be running on an on-premises host, or perhaps you will do that in the cloud. But you also need to have a container image. A container is a running instance of a container image. So every container is based on an image, and that image might be designed to run for Windows-based applications or Linux-based. It may or may not have listening ports like port 80 for a web server. But at the end of the day, we need to have somewhere to run it. And in this case, I'm going to run it in the Azure cloud as a container instance. But before I do that, I'm going to go to the All Resources view here in the Azure Web GUI in the portal, because I've already deployed a container registry. This is a centralized collection or repository of my own customized container images. And so in the property bar of that container registry on the left, if I scroll down on the left until I get to repositories, I've got a couple here. One's called Alpine, one's called Caddy. Caddy is for a web app. So if I were to click Caddy, then I've got one version of it called V1, version 1. Okay, so that's fine. That's what I want to deploy. This container image called Caddy, specifically V1, which is the only version I have. I want to deploy this in the Azure cloud. So I'm going to go to the home link here in the portal, and I'm going to click Create a Resource in the upper left. And one way I could do this is search for what I want, or I could just choose containers over here down on the left and on the right, maybe container instances. When you want to launch a single container, that's what you would do, a container instance. I already have a resource group to group related items here in the cloud called testing. And this container I'm going to call Caddy. Down below, I'll specify that I want this to run in a specific region. Canada Central is fine for this. Now, the cool thing here is for the image selection, the container image, I can use quick start images supplied by Microsoft. So Hello World applications such as those that are Linux-based or Windows-based. Or we could go to Docker Hub or some other registry on the internet and specify the URL or the name of the item, the name of the container image. We could go to our Azure Container Registry, which we just looked at. So let's say I want to select our Caddy image and specifically V1. I just select it from the drop-down list. Couldn't be easier. Now that's all I'm going to do here. It's going to be using an underlying virtual machine, so there is some sizing information here, although I can't directly manage that virtual machine. It's going to be one virtual CPU, 1.5 gig of RAM. So I could change the size, but that's going to be fine for this workload. I'm just going to choose Review and Create, and I'm going to choose Create. Once this container instance or underlying virtual machine, which can run my containerized apps, is deployed, we can choose Go to Resource. In the future, we could just go to the All Resources view, and we'll have our container instance. In this case, it's going to be called Caddy. Now, when I open that up and click Containers in the navigation bar, I'll notice that I have my container, which is currently listed as being up and running. Now, if I go back to the overview page, a public IP address has been assigned to this container instance. Why don't we pop that into a web browser tab to see if it opens up our caddy mini HTTP web page. And sure enough, if I enter in that public IP address, our container is up and running, except it's being hosted in the cloud. This is called a managed service in the cloud. And what that means is I don't have to manage or provision the underlying virtual machine and get Docker installed on it to support containers and all that stuff. It's done for me. All I did was say, do it, and here's a container image. And so from a security perspective, this is just another web app that needs to be protected. For instance, in the address bar of the browser, it's not secure. In other words, we are using just a raw HTTP connection over port 80, not HTTPS. And so that would be something that would have to be enabled within the configuration of the web service stack within the caddy container. And so it's going to be very important then to think about hardening containerized applications the same way you might harden other applications or configurations of web server stacks and so on. A service level agreement, or an SLA, is a contract between a provider of a service and a consumer of that said service. In this case, the provider is Microsoft Azure in the public cloud, and we are the cloud consumers. Now, service level agreements are important because they guarantee uptime for a service. Now, what does that have to do with security? Plenty, because one big aspect of security is availability, making sure that services and data are available when they are needed. So, as a security expert, it's important to take a look at SLAs related to cloud computing services that your organization. So I used a web browser search engine to search for Microsoft Azure SLA, and that takes me here to this service level agreement page for the Azure cloud. Now, as I scroll down below, the first thing I notice is that there is an SLA for each and every service offering available in the Azure cloud. And there's so many service offerings that they are categorized on the left. So for example, if I click on media, then on the right, I have a couple of listings, media services, content delivery network, where I could view the SLA for each of those items. If I were to click databases on the right, I have a number of different database service offerings, again, each of which has its own SLA. If I click containers, we get things like Azure Kubernetes service for container clusters and so on. If I click compute, we get all kinds of other services, each having their own SLA. So now that we're looking at compute, why don't we take a quick peek at the virtual machines service level agreement. So I'm going to go ahead and click to open that up. An important aspect of an SLA, especially in the cloud, is that you read through it carefully because some of the guaranteed uptime statements might depend on a specific configuration of that service. So in the first example, it's talking about virtual machines where you have two or more virtual machine instances deployed across two or more availability zones, then you get an uptime guarantee of 99.99%. But that's only if you have that type of configuration. Then there are listings here for single instance virtual machines using premium SSD disks and so on, and their guaranteed uptime statements. So it's important to take note of these to see how it fits with your use of those cloud services. And now I can open up the introduction section of this service level agreement, under which I then get a list of general terms. So think of this as a definition of the terms used throughout this document. Things like downtime, error code, external connectivity, incident, and so on. So it's a standard legal document in that sense. And then down below, we have information about how to submit a claim for service uptime that was not met, and about service credits and how they will apply. So we have a lot of these details that list here. There's also, of course, limitations where the service level agreement would not cover you in terms of missed uptime that was guaranteed and the acquisition of service credits. It wouldn't apply if there was something that was out of the control of the cloud service provider. Things like natural disasters, war, acts of terrorism, riots, government action, and so on. So those items would not count to getting service credits. Now that's an example of a virtual machine service level agreement. Why don't we go back in our browser and take a look at something related, for instance, to storage. So maybe I'll click storage on the left, and over on the right, maybe I'm interested in a storage account SLA. So I'll click on a storage account, and we'll wait for that to pop up. So we have the same type of document layout where we have some configurations specific to that service, such as read access geo-redundant storage versus local storage that is not replicated to other regions, and the uptime guarantees related to those. As I scroll further down, I then get, as we did before with the virtual machine SLA, an introduction. Under that, I then have a definition of terms, otherwise labeled here as general terms for this particular SLA, and notice the terms will vary from one SLA to another because they refer to different cloud services. And then we have information about how claims are made and the service credits that would apply, and then of course any limitations, that type of thing. At the bottom of each SLA, you will have a revision history. So you'll see the versions of the SLAs at different points in time. They're hyperlinked, and you'll see the date stamps with them. The use of cloud computing implies the level of trust from the perspective of the cloud customer. They trust that the cloud service provider has done their due diligence in hiring personnel to man their data centers, and that the underlying equipment is configured securely in accordance with industry security standards and perhaps data privacy regulations. But hoping isn't enough. How do we verify that that is true for a given cloud provider? Well, the first way that we can answer that is by looking at the Cloud Controls Matrix, or the CCM. This is available on the cloudsecurityalliance.org website. Cloud Security Alliance you'll often see abbreviated just as CSA. So I've navigated to the Cloud Controls Matrix on the CSA site, and I'm going to go ahead and click the Download the CCM button. That's going to take you to another page that talks about the Cloud Controls Matrix. In this case, happens to be version 4. So down below, I have to specify a few details like the job that I currently work in and so on. So I'm just going to go ahead and get through that. And then I'll click Download. It's an Excel spreadsheet, so I'm just going to go ahead and click Open down in the bottom left in my browser. So here in this Excel spreadsheet, we now have a number of different control domains over on the left, like audit and assurance. And as I go down through this spreadsheet, we've got business continuity management. And this is all related to the cloud, change control and configuration management. And interestingly, we can also search. So for example, let's say I search for the word encryption, and I'll go ahead and press enter. And already it's found that section here in the Cloud Controls Matrix, the section on cryptography, encryption, and key management. So what's interesting is as I scroll over to the right in the spreadsheet, I have a responsibility and ownership item here for infrastructure as a service, platform as a service, and software as a service. Shared means that the cloud provider and the cloud tenant both have some responsibility. And as we go further to the right through here, we'll get some information as to whether it relates to HR, supply chain management, if there are legal and privacy implications, operations, software development, and so on. So, of course, cryptography is wide-reaching in its scope, so it shows up for all of those items. Down at the bottom, I can also go to the Scope, Applicability, or Mappings worksheet. And from here, I'll see the same type of information, but as I go over to the right, I will start to see the control mapping. And a lot of these are referring to things like ISO standards and so on. So ISO/IEC 27001 really deals a lot with information security management. So we can start reading about this and download the publication so that we can learn more about the individual security controls that are referenced in the Cloud Controls Matrix. Now, I'm still on the cloudsecurityalliance.org site, but I'm looking at the Security, Trust, Assurance, and Risk, or STAR, registry. Now, this is a way that cloud providers can be audited, either self-audited, third-party audited, so that they can acquire certifications and be registered here so that customers or even potential customers can verify which security standards cloud providers are compliant with. So as I scroll down here, I can read about the STAR program, where STAR Level 1 would be a continuous self-assessment, but if we take a look at STAR Level 2, it's a third-party certification that the cloud provider is compliant with certain security standards. Now, the great thing about this is I can search the STAR registry. So if I click the registry link on that page, we'll then get an alphabetical listing of cloud providers that have registered with the star registry. So from here, I could search or I could manually scroll through. So for example, let's say I search for Amazon. So I've typed in Amazon as my search term, and I'll just go ahead and press enter. Then I'll scroll down and there's Amazon. So I'm going to go ahead and click on the link for Amazon so that we can read about their star registry certification. So I have a sense here of what happened and when it happened, such as an assessment that was provided in this case on August 5th, 2020, and also more recently, November 7th, 2020. So star certification V1, and this is the Consensus Assessment Initiative questionnaire. I could download and read that. So let's go ahead and start with that. I'm going to click on the download link. So when I go through this PDF document, it talks about how Amazon Web Services or AWS is compliant in terms of how they run their cloud services. Now, I'm not going to read all of that detail. However, let's go back and let's download the star certification document. So I'm going to click download to open that item. And then I'm going to go to that location and I'm just going to make sure that I extract it. Now, what we want to do here is open up the PDF. When I open that PDF, it is a star certificate registry entry, in this case specifically for Amazon Web Services, Inc. There's a little description about them, the scope to which this applies, the number of sites they have, the cloud controls matrix or CCM version used, in this case 3.01. We just looked at version 4, so it's a newer update compared to that. Let's close that out and let's download the supporting asset for star certification. And again, this is going to be another zip file that I'm going to download and I'm going to extract. And when I open that PDF, after having extracted it, I have the CSA Star Certification Certificate that was awarded to Amazon Web Services. I have the issue date for the certificate and when it expires. And down below, we have a listing for the scope of what it applies to. And further down in this document, we see the locations where they have data centers that this applies to. Now, what we're really looking at here is that this complies with CSA, or Cloud Security Alliance, Star CCM version 3.01, Cloud Controls Matrix. So that's what this specific certificate that was awarded to Amazon describes. In the cloud, a VNet is a virtual network, and you need to take the same care in setting it up and securing it that you would with a regular network on premises. That means, first of all, defining the purpose of the network. Why do you need it? And are you going to have one or more subnets? And what are the IP addresses going to be that you're going to assign to those subnets? And do you want to limit traffic into or out of those subnets? All of that same type of stuff, all those same considerations apply in the cloud as they do on premises. So here in Microsoft Azure, I'm going to create a virtual network. So to get started with that, I'm going to click Create a Resource in the upper left. And then I'll type in Virtual Network in the field, the search field. And then I'll choose Virtual Network from the resultant list. And then finally, I'll choose Create. So we would have done our pre-planning ahead of this, so we'll know how to fill in all of these fields. So I have to tie this virtual network to one of my Microsoft Azure subscriptions, so that's fine. I can then either create a new resource group or select one from the list, which I'll do. A resource group, like the name implies, is a way for you to organize related cloud resources like virtual machines, storage accounts, web apps, virtual networks, for any relationship at all. So if maybe you need a number of those items to support a single app, you might organize them all into a resource group so they can be managed as a unit. So I'm going to call this one VNet1. I can determine the geographical region where that will be created. In this case, I'll leave it on Canada East, and I'll click Next IP addresses at the bottom. Now, it has suggested the 10.0.0.0/16 network range, so 16 bits in the subnet mask. So really, the network here is 10.0. I could either remove that by clicking the trash can over on the right, or I could keep it, and I could even add additional network ranges. I'm going to go ahead and stick with the default range that it has assigned. I'm okay with that. I could also add an IPv6 address space if I need to support that. I don't. Down below, it's created a default subnet that's using the 10.0.0.0/24 subnet. So in other words, the first 3 octets, in other words, 24 bits, identify the network. However, I can accept that or I can change it. I can remove the subnet. If I were to select it, I could choose to remove it, which I will. And I can click Add Subnet, so I have a little bit more control of how it's added. I want this to be called Subnet 1. And maybe what I want to do is I want to use the 10.0. Now that's my VNet prefix, 16 bits. I can't change that. But then I'm going to use .1.0/24. That's what I'm going to use for my IP address range. And I'll click Add. I'll click Next Security at the bottom. Here I can enable some security mechanisms, and this is important. For example, a Bastion host is a jump box. I can enable this so that in order to come in from the internet to manage virtual machines in this VNet, normally they would need a public IP address, which is a security risk. Instead, they would only have private IPs, and I could use the Bastion host configuration to connect to them to remotely manage them, whether they're Linux or Windows based. So that means we don't need a public IP for those internal hosts. So we can enable that at this point or at any time thereafter. We can also enable DDoS protection, distributed denial of service. And we can also enable Azure Firewall. Again, all of these can be configured after the fact. So I'm going to leave them disabled for now, and I'm going to click Next. We can add tags. Tags are metadata. They're additional properties or attributes. For example, I might want to tie this to a project. So maybe I'll create a tag name called project with the value of ABC. So I could tag resources that way, and I could search for them later and group them together, or even view costs associated with project ABC. I'm going to go ahead and click Next, Review and Create. And once it's run the final validation based on my selections, I can go ahead and click Create in the bottom left to actually create our VNet, VNet 1. And before you know it, it's done. So it says your deployment is complete. So I'm going to click Go to Resource to open it up. That takes me into the properties of my VNet, where I have an extensive navigation bar on the left that I can scroll up and down through. We're currently looking at the overview page. So on the right, my address space is shown based on our selection. And if I click Subnets on the left, then on the right, it'll show me Subnet 1 that we created with the configured IPv4 address range. Now I could go back to address space on the left. This will show me the address space for the VNet, what we started off with, but I could add additional IP address ranges. I could also add additional subnets. For example, if I go back into subnets on the left, on the right, I'm going to click the Add Subnet button. I'm going to call this Subnet 2. You could use better, more meaningful names than this, but I'm going to use the 10.0.2.0/24 network range. That tells me the first 3 octets, in this case 10.0.2, identify the network, where for subnet 1, 10.0.1 identifies that. And again, we have the option to add an IPv6 address space. We can use a NAT gateway to get out to the internet. A network security group, we'll be doing some of these things later, which can allow or deny traffic. It's like a packet filtering firewall. We could also associate this subnet with a route table if we want to control routing in a particular way, maybe to send outbound traffic to the internet first through a firewall appliance for inspection. So I'm just going to go ahead and click Save. So we will have created now 2 subnets within this VNet. On the left, if I were to click Connected Devices, we're not going to see anything yet, but once we start deploying things like virtual machines and so on, this screen of connected devices for this VNet will begin to become populated. So now in Azure, I can open up my navigation bar in the very upper left, and from here, I could go to my virtual networks view to view all of my virtual networks in one place. And sure enough, this is where we'll see VNet 1. In this demonstration, I'm going to create a network security group. In Microsoft Azure, a network security group is like a packet filtering firewall configuration where we can create multiple rules to allow or deny traffic based on what appears in packet headers, things like IP addresses for source and destination, port numbers for source and destination, protocol type, that type of thing. So to get started, I'm going in the portal here to click Create a Resource in the upper left, and I'm going to type in Network Security Group. Of course, I could click on the categories down below to select it from there, but I'm going to go ahead and just type it in. It's quicker for me. And then I'll go ahead and click on Create. So I'm going to tie this to my pay-as-you-go subscription. I'm going to put this in an existing resource group called testing, and I'm going to call this Windows Standard. This is going to be for Windows traffic. Essentially, I want to make sure I allow things like RDP, Remote Desktop Protocol, and HTTPS into the subnet. So that's going to be in the Canada East region. I'll click Next for tags, and if this is related, let's say, to a project, I could specify the project I want to associate it with. Now, project ABC shows up in these fields because I've already tagged a resource with those items. Otherwise, it wouldn't have popped up. So I'm going to click Next, Review, and Create, and it's going to check my selections before it gives me the validation I need to proceed. So I'm going to go ahead and click Create in the bottom left to create this network security group. And before you know it, it's complete. So I'm going to go ahead and click Go to Resource to open up our Windows Standard Network Security Group. That takes us into the properties of it, where on the left, we're in the Overview blade. So on the right, I don't have any inbound or outbound rules. If I click Inbound Rules over on the left, I've got the default rules within this security group, and I can hide the default rules. They're still going to be in effect, but I can just remove them from the screen by clicking that. I can click the Show Default Rules button to get them back. So the first thing is to allow traffic inbound from any other VNets. So that action is set to allow. The next rule is to allow traffic from an Azure load balancer. That again has an action of allow. And finally, everything else is denied. We're denying all other inbound traffic. It's set to deny. So this means if we had virtual machines that we needed to get to that were running Windows and we want to RDP them, we wouldn't be able to get through this network security group to RDP them. So what I'm going to do is add a rule. I'm going to click Add up at the top, and this is going to be for Remote Desktop Protocol. So the source can be from any location or an IP address or a certain tag value or an application security group. I want to allow from anywhere. The source port range I'll leave as an asterisk, so any port number, but the destination, this is where I can specify an IP address. If I know that I've got a fixed IP address for a virtual machine, then I can go ahead and plug that in. For the service, I'm going to go through the list here and choose RDP, which uses port 3389 over TCP. That's already selected and grayed out. And I can either allow or deny it. Well, I want to allow it. But the priority number here is important. Notice the priority numbers in the background are 65,000, 65,001, and 65,500. This means that rule 65,000 gets checked against incoming traffic because these are inbound rules. It gets checked before the other two rules because of its numeric value. So if I create my RDP rule with a priority of 100, it's going to be checked first. And if there's a match, then the traffic's either allowed or denied, and no further rule checking is done. So for the name, I'm going to call this Allow RDP. I'm going to go ahead and click Add to add that new rule. So I have a message in the upper right that it created the rule. I can click the refresh button to make sure I'm looking at the latest info. And here I've got my new rule with a priority of 100. I have a little alert symbol because we are allowing access from any when it comes to this. That's what the source is showing here under the source column. It's from any location, but I'm okay with that. Now, in the same way, we could also go to outbound security rules on the left. We have some default security rules to allow VNet traffic out. So by default, any traffic within a VNet is allowed out to the internet. Also, we're then denying all outbound if it doesn't match VNet or internet outbound. We can hide the default rules and show them just like with the inbound rules, but there's really no need to make a change here unless I had something I wanted to allow or deny in an outbound direction. Now, the other thing we have to do is associate this network security group with something, because right now it won't do anything anywhere. We can associate this with either a specific network interface for a virtual machine. We could associate them with a couple of them. So we would then be applying the rules in this network security group to specific virtual machines, or instead of that, what we could do is associate it with an entire subnet. So all of the virtual machines within the subnet would be affected by the rules in the network security group. So that's what I want to do. So I've clicked subnets. Over on the right, I'm going to click the associate button at the top so I can select the subnet I want to associate this with. Now, subnets exist within virtual networks. So I first have to choose a virtual network. I'll choose that from the list. And then after that, I can select the appropriate subnet within that VNet. and I can choose OK. Now this takes effect pretty much immediately once it's saved the subnet association. So at this point, we've now got subnet 1 that will allow inbound RDP traffic from anywhere to a specific IP address that we have designated for a virtual machine in our subnet. In this demonstration, I'll be deploying a Windows virtual machine into the Microsoft Azure cloud. Now remember, one of the great things about cloud computing is that we have self-provisioning. In other words, in this case, myself as the cloud customer, I get to provision virtual machines as I see fit. And I can do that programmatically or using command line tools. I could also do it using a GUI, which I'm going to do here. The Microsoft Azure GUI, the web page, is called the Azure portal, which is where I am now. So I'm going to create a new virtual machine. For that, in the portal, I'll click on Create a Resource in the upper left. Now over on the right, under Popular, I can select Windows Server 2016 Data Center. I'm going to go ahead and do that, but once I'm in the next screen, I can also make a change to the operating system image if I so choose. So I need to tie this virtual machine to an Azure subscription and put it in a resource group. I'm going to call this WinServe1. And down below, Canada East is the region where the virtual machine will be deployed. That's fine, since that's where most technicians that will be accessing it reside. We can also, down below, change the virtual machine size. This is the underlying horsepower. In this case, we've got one virtual CPU and 3.5 gigs of memory, but we could change this at any point and time. Now, I can also specify, as we've mentioned, a different version of the operating system. For example, Windows Server 2019. And then I'm going to specify a username and a password. So I want to make sure I use a difficult, complex password in accordance with organizational password policies. And then moving on down below, I can specify if I want any public inbound ports. By default, it's elected to open up RDP port 3389. So that's fine. We can do that. I'm going to go ahead and click Next for disks and specify whether we want to add additional data disks. I don't. So I'll click Next for networking. Next thing I have to do is deploy this into a network like I would on premises. So for here, I'm going to leave it on VNet 1. That's my virtual network. And subnet 1. I can choose the subnet from the subnet list. It wants to assign a public IP address. Now for testing purposes, assigning a public IP, so it's publicly visible for a VM, is okay, but only for testing. For production, this is never acceptable. It should only have a private IP address in the cloud, and you can get to it and manage it over the internet through a jump box, or in the case of Microsoft Azure, a Bastion host configuration. Because this is just for testing purposes, I will let it assign a public IP. And I'm going to click Next for management. I'm not going to make any changes actually on the next couple of pages, so I'm just going to go ahead and choose Review and Create. It's going to check my selections, after which I'll then be able to actually deploy this Windows virtual machine. So the validation has passed, therefore I will click the Create button in the bottom left. And before too long, the deployment is complete, so I'll just click Go to Resource so we can open up the property sheet for that deployed virtual machine. So in the overview page on the left, we see the details for that page on the right, such as the public IP address that was assigned and the virtual network and subnet affiliation for this particular virtual machine. If I click on networking down over on the left in the navigation bar, not only does this virtual machine have a public IP, which we said is acceptable only because this is a testing VM, but it also has a private IP that was assigned automatically based on the IP address range we associated with the subnet where this VM was deployed. Now we can also specify which network security group that we want to use for in and outbound rules. If I look at the inbound port rules that are applicable to this particular virtual machine, there's a rule with a priority of 100. It's called Allow RDP. Looks like the source is from anywhere, and the destination is to this particular IP, 10.0.1.10. Well, I'm going to go ahead and make a change here because I want to make sure RDP is allowed to any servers within this network. So to make that change, I have to go into my network security group, and I've got a link for it right here. It's called Windows Standard. That switches me to the property sheet for it, where I'll click Inbound Security Rules over on the left. there's the allow RDP rule. So I'm going to go ahead and click on the allow RDP rule to open it up so I can make changes. Instead of the destination being IP addresses, I'm going to choose any. Now you have to make sure that this is only used for testing purposes, the virtual machines in the subnet. They are, so that's okay. I'm going to go ahead and click save to save that rule. Okay, so if I were to go in the left-hand navigator in the upper left, I could open up the virtual machines view. This gives me one place where I can view only virtual machines. So we've got WinServe 1, and currently the status is such that it is running. So when we go into it, remember, in the overview blade, we'll have the public IP address available. So I'm going to go ahead and copy that. There's a little copy to clipboard button to the right of the IP, and I'm going to open up my local RDP client on my Windows station. I'm going to go ahead and paste the public IP address into the computer field in the remote desktop connection client, and I'll click connect. Then I'll specify the username and password that I configured when I deployed that virtual machine, and I'll click OK. Because it's the first time I've connected, it's going to ask me if I trust the certificate that's going to be used to secure the connection. So I'm going to tell it, don't ask me again, and yes, I trust it. And then after a moment, I'm in. I am remotely managing a cloud-based virtual machine over the internet. Now, there are a lot of brute force attacks that will sometimes succeed when you have public-facing RDP hosts. So I would never recommend this, other than perhaps for experimenting or testing. Now, the other interesting thing here is that if I were to go into a command prompt on my server, and if I were to type ipconfig to view the IP configuration, all I'm going to have here is the private IP. So the public IP address does not show up within the virtual machine OS. That's because the public IP address is a cloud configuration only. Now, from a security perspective, we also want to make sure we don't leave virtual machines running if they don't need to be running. All you're doing is increasing the attack surface, and that's very easy to do in the cloud. You can end up with what's called cloud VM sprawl, because it's so easy to deploy VMs. So, of course, we could manually shut down or stop the VM here by clicking the stop button, but also bear in mind that most cloud providers will have some kind of auto shutdown facility where you can schedule VMs to shut down if they aren't mission critical and don't need to be running 24/7. You can quickly and easily deploy virtual machines in the cloud, much like you would do on premises if you already have virtual machine templates, or if you're using operating system images that might be pre-hardened. In this case, we're going to deploy a Linux virtual machine in the Microsoft Azure public cloud. So to get started here in the Azure portal, in the upper left, I'm going to click Create a Resource. Now I can go through these categories on the left, or I can just select what I see under Popular on the right, such as Ubuntu Server 18.04 LTS. So I'm going to go ahead and click on that. Now, once I go into the wizard for deploying a virtual machine, I can then specify a different OS image if I choose. So I'm going to tie this to a subscription. I'm going to deploy it within an existing resource group, and I'm going to call this Ubuntu Serve 1. So make sure that you follow organizational naming conventions when it comes to naming these things. Because one part of securely managing an environment is to make sure that you can easily manage the items. And if you have a standard naming convention, it's easy to identify what type of servers we have, what they're used for, and so on. So I'll deploy this in the Canada East region, and this is where I can go to the image drop-down list, and I can select a different image. Now, I also have the option of using a custom image, which we'll get into in a minute. So for now, I'll just leave it on Ubuntu Server 18.04. The sizing controls the horsepower, so the CPUs and the amount of RAM. I'll leave that. And I can opt for either public key authentication or password authentication to Linux. Now, password authentication is just username and password. But with public key authentication, we have to have a username, and you must also possess a private key. Now, the public key is stored with the Linux server. You need the mathematically related private key. So that means we have to have something we know, which is the username, and something we have, which is the private key. So I'm going to leave it on SSH public key authentication. The username here will be Azure user. I could change that. And I can opt to generate a new public and private key pair or use an existing one. Now, I'm just going to generate a new one. And I'm going to leave that as it is. Scroll down. I'm going to leave the inbound port open for SSH, TCP port 22 for administration. Now, again, this is only a testing virtual machine, so making it publicly visible is okay, but for production, it never is. Instead, maybe we would require a VPN connection before allowing remote access to only the private IP of the Linux host, or maybe administration only through a Bastion host, a jump box. So for this, I'll leave it on allow selected ports. I could add tags, which I won't. I'll just go to review and create. It'll check the validation of my selections, and after that has passed, I'll be able to deploy the virtual machine. So when I create the virtual machine for generating the key pair, it prompts me to download the private key and then to continue creating the resource being the virtual machine. So I'm going to go ahead and click on the download button. In the bottom left of my web browser, I'm then prompted to save my key. So I'm going to go ahead and do that by clicking Save As, and I'll save it in my local downloads folder. So once the deployment is complete, I will click Go to Resource just so we can check out the property sheet for our newly deployed Linux virtual machine. So in the overview page over on the right, we have the sizing information for the VM. We have the public IP address, which I will copy. I know I'm going to need that. We see the network affiliation where this virtual machine was deployed, and so on. Up at the top, I also have a capture button. If we've deployed a virtual machine in the cloud and perhaps tweaked and configured the OS and hardened it and applied updates, maybe added software, we can then click the capture button to capture that as a custom image, from which we can then create other virtual machines in the cloud. Now, the benefit here, of course, is that it's customized and it can be hardened to your organization's security standards. However, I'm just going to click the X in the upper right. I don't want to capture that. So the next thing that I want to do is make a remote connection from my on-premises network into the Azure cloud using the PuTTY tool. PuTTY is normally used to make an SSH connection to hosts that have an SSH daemon running, like Linux. Now, I've launched the free PuTTY key generator tool, often just called PuTTYgen. You can download PuTTY and PuTTY keygen for free anywhere from the internet. Now, the reason I'm doing this is because the format that the private key file is in, as provided by Azure, is not consumable by the PuTTY remote management tool. And so I'm going to open it up in here and save it to a version that is consumable by PuTTY. So I don't want to generate a key pair or anything. I already have that done. I'm going to click the load button to load an existing private key file. So here I've opened up the private key file that was generated by Azure. Now what I want to do is put in a passphrase, because it is a private key file. I want to protect it. And then I'm going to go ahead and click the Save Private Key afterwards. And I'm going to save it as a file called Azure Ubuntu Linux, and I'll click Save. So there we go. We've now got our private key for public key authentication to Linux that's been saved in a format consumable by PuTTY. So let's fire up the PuTTY tool to make the SSH connection to the public IP of the Linux VM. So here in the PuTTY tool, I've pasted in the public IP and I've saved the settings here as Azure Ubuntu Linux. So in the future, I can just select it and load it up and everything's filled in. However, over on the left under Connection, SSH, and under Auth for authentication, I'm going to specify the private key file that we've just saved into the correct format. I'm going to specify that here. Now that is a PPK file. There it is, Azure Ubuntu Linux. So once we've done that, I'm just going to go back here and save that, of course, and we're going to click Open to actually open the connection to that host. So I'm going to be prompted as to whether I trust that remote host. I do, so I'm going to choose Yes to add the unique fingerprint for this host to the registry on this machine. After which I'm going to be prompted to log in. So the default username in our case is Azure User, but instead of asking for a password for that account, it's going to ask for the passphrase for the private key file that we have stored locally. So I'm going to go ahead and enter that and press Enter. After a moment, we are successfully logged in. So if I clear the screen with the clear command and issue commands such as who am I, it'll show me who I'm logged in as, which of course is going to be Azure User. If I type ifconfig, it'll show me some IP configuration information. And just like is the case with Windows, all we're going to see here is the private IP address, the public IP address does not show within the OS, although it is being used for it. It's just in Azure, the public IP address is a separate cloud resource external to the operating system. But because this is a testing virtual machine, having it publicly visible is okay, temporarily. But for production, it never is. So there you have it. That's how easy it is to get a Linux virtual machine deployed into the cloud and how to securely connect to it for remote management. In the cloud, after you've defined virtual networks, you can peer them together. Now, peering a VNet together, remember, provides the benefit of allowing virtual machines in one VNet to communicate directly with virtual machines in the peered VNet using public IP addresses. Because without peering, you need to communicate using public IPs, which goes over the internet. So this way, you use private IPs, and the traffic stays on the cloud provider backbone global network. So to get started here, in the Microsoft Azure portal, I'm going to open up in the upper left my navigation bar, and I want to go all the way down and click on Virtual Networks because I want to view virtual networks that I have. So I've got a virtual network for my Ubuntu Linux virtual machine, and I've also got one called VNet 1. I want to peer both of those VNets together. Now, before we go into that, let's go into our virtual machines view and check out what we've got. So when I go into my virtual machines, I'm going to have a Windows and a Linux VM. So if I open up the Ubuntu server Linux virtual machine, we see that the virtual network and subnet indeed is such that it is deployed into its own VNet. At the same time, if I go back to my virtual machines and open up the Windows virtual machine details, we'll see that it is deployed into VNet 1, subnet 1, so a different VNet and subnet. Now, why don't we fire up both of those VMs? I'm going to start the Windows VM by clicking the Start button here from the Overview page, and I'll do the exact same thing for Linux. Because what we're going to be doing before we peer those VNets together is we're going to test whether or not they can communicate with each other using their private IP addresses. Now, the expected result is that no, they cannot because they aren't peered together yet. After we peer the VNets together, they will be able to communicate using private IPs. But let's prove that. So we'll just wait a moment while the VMs fire up. Okay, so maybe what I'll do is I'll go to the Windows virtual machine and I'll take a look at its private IP address. So I can do that, for example, by going into the networking page over on the left, because I want to be able to ping this from the perspective of my Linux virtual machine. So the private IP here is 10.0.1.4. Now, if we go and take a look at the private IP address of the Ubuntu virtual machine, it's going to be different, of course. Now, it's going to be on a different subnet, we should say. So it's on a different subnet, and if we take a look at the networking section, its private IP is 10.1.1.4. Okay, let's test this out. I'm going to remote into the Ubuntu Linux virtual machine, and we're going to test pinging the Windows virtual machine private IP, and it should fail. Let's see if that's true. So I'm going to use PuTTY here on my on-premises station to connect to the public IP of the Azure Ubuntu Linux virtual machine. So let's just open up that connection. Okay, so here in Linux, if I do an ifconfig, let's check out our private IP, 10.1.1.4. So let's go ahead and let's try to ping 10.0.1.4, which is the private IP address of our Windows virtual machine. Now, of course, we're not going to get a response because how will it get a route to that other private subnet? It's not going to be able to connect to it. So the only way they would be able to communicate is over the internet using public IPs. And that can present a security risk. Anytime you're communicating over a public network, there is more implied risk than when you're communicating on a private controlled network. So we're proving here it's not connectable via its private IP. So I'll just press Control-C to stop that. Okay, so back here in the Azure portal, let's go back into our virtual networks view and let's finally set up the peering. You can set up the peering from either VNet's perspective. It really doesn't matter. So I'll click on VNet 1, and over on the left, I'll scroll down in the navigation bar and I'll select peerings. Now, any existing peered VNets will be shown here. There are none, so I'm going to click the Add button up at the top to add a peering connection. The first thing I'll have to do is give this a peering link name. How about I call it WinVNet to Linux VNet. And we have some options. Do we want to allow or block the traffic? Do we want to allow traffic that's forwarded from a remote virtual network that doesn't initiate from that network? And all of those types of options. However, I'm just going to go down and add a peering link name to create a peering connection in the opposite direction. So maybe Linux VNet to Windows VNet. So it's setting up both ends of the peering connection. I have to choose the target VNet. It already knows we're setting this up within VNet 1, so I'm going to choose the Ubuntu Serve 1 VNet, and I'll leave all of the options to allow the connectivity, and I will click Add. So notice I've got two little notifications up here because it's setting up the connection in both directions. And that's why I said it doesn't matter which VNet you do this from. So after a moment, we have the peered VNet status showing as connected. So let's go back to Ubuntu Linux and see whether or not it can now ping the private IP of the Windows VM in a different VNet through the peering connection. Okay, so back here in Ubuntu Linux, I'm just going to use my up arrow key to go back to the ping command, and I'll press enter. Notice now we get a response immediately because we have these two VNets peered together. And so as a result, the VMs are able to communicate using only private IP addresses. One of the great things about cloud computing and security is the ease with which we can deploy secure solutions like firewall appliances. I'm going to configure Azure Firewall. So here in the Azure portal, I'm going to start by clicking Create a Resource in the upper left, and then I'm going to search for the word Firewall. And then I'll click on Firewall. And then I'll click on Create. So I'm going to deploy this to my subscription and to an existing resource group, and I'm going to call this Azure FW East 1. And it's going to go in the Canada Central region, or in this case, perhaps Canada East, which is where I'm actually at. And down below, I can add a new firewall policy if I've got one. Now, I don't have any existing firewall policy, so I'm going to have to click Add New. I'm going to call this Policy 1, and again, I'll specify a region for the policy resource, Canada East, and I'll choose Yes. Now, we can either deploy the Azure Firewall solution into an existing VNet, or we can create a new one for it. So I'm going to create a new one, and I'm going to call this Azure FW for Firewall VNet. And it's got an address space that it will allocate, so I'm going to go ahead and specify, let's say something a little bit different, 12.0.0.0/16. It's going to create a subnet within that VNet called Azure Firewall Subnet. So if you are going to use an existing VNet, you have to create a subnet with that name, Azure Firewall Subnet, no spaces. So the subnet address space here, let's say we'll put in as 12.0.0.0/24. The Azure Firewall needs a public IP address, so if we have a public IP address resource, then we can select it, but we've got a couple that are already being consumed by virtual machines. So I'm going to have to click Add New, and I'm going to call this Azure FW Pub IP, and I'll click OK. All right, so there we go. I'm going to go ahead and click Next for tags. I'm not going to add any tagging information for the Azure Firewall. I'll click Next, Review and Create. It's going to go ahead and double check my settings to make sure they're valid, after which the validation will pass, and I can deploy the firewall by clicking Create in the bottom left. Okay, so before too long, the firewall will have been deployed. So I'll click the Go to Resource button so we can continue configuring the Azure Firewall. I'll click on Firewall Manager over on the left, and at the top I have a message, Visit Azure Firewall Manager to configure and manage this firewall. So I'm going to go ahead and click on that link. That takes me into the Azure Firewall Manager resource configuration, where on the left I can click Azure Firewall Policies. Now, when we created this, we specified a policy with the name of Policy 1, but we can go ahead and create additional firewall policies. Let's go into Policy 1. So I'll click directly on the name to open it up. On the left, I can configure DNAT rules. Now, DNAT rules allow me to configure connections, essentially public IP addresses and ports, kind of like a reverse proxy, so that we can allow client connections from the internet into services offered behind the Azure firewall while protecting the true private IP address configuration of those hosts. We can configure network rules, which are standard packet filtering rules based on things like source and destination IP addresses and port numbers, and application rules, where we can configure, for example, restrictions to block outbound access to certain DNS domain names. So I'm going to go ahead and click Add a Rule Collection, and I'm going to call this rule collection Block Social Media. So it's going to be an application rule collection type. The priority here, let's say, will be 100. So if I have a rule here with a priority of 100 versus another rule collection with a priority of 200, this rule set would be checked first because 100 has a higher priority than 200. And if there's a match, then no further rule processing will occur, similar to what you get in a network security group in the cloud. Okay, so I can either allow or deny. I'm going to choose deny. And down below, I'm going to call this block Facebook, and we'll create a configuration for that. So the source IP, let's say, is any IP. I'll use an asterisk as a wildcard. The protocol will be HTTPS:/443, so port 443. And the FQDN, or the fully qualified domain name, will be asterisk, again, that's a wildcard, .facebook.com. So anything in facebook.com we are going to block or deny in this particular case. So I'm going to click Add that rule collection. And so our block social media rule collection is shown with a rule called block Facebook. Notice the entire collection is to deny. So if I want to allow something, and in this case, let's say we're going to allow Twitter, then I'm going to have to add not a rule because the rule collection overall is set to deny, but rather a new rule collection. This one I'll call allowed social media, and it's going to be allow. Here I can specify that I want this to be in the default application rule collection group. Name, let's say for the specific rule, will be allow Twitter, and it's going to be from any IP. Protocol is going to be HTTPS. So we'll leave that in there. I could also specify port 443 after the colon, and the FQDN will be asterisk.twitter.com. That's how we're going to create this, kind of like how we created the one for Facebook, asterisk.twitter.com, and then I'll click Add, and then I'll add the priority value of 200 for this rule, and I will click Add. Now, both of our rule collections will be shown. The first one has a priority of 100, so it gets checked before the rule collection that has a priority of 200. But let's go back into our firewall manager, and we want to make sure under virtual networks that if it's not already been done, that we associate this with a VNet. So what I've done here is I have associated this with my VNets that are available in my Azure subscription, specifically VNet 1, because my virtual machine, my Windows VM, is deployed there, and I want it to use these firewall rule settings. Now we'll see how to configure routing and how to actually test all of this out a little bit later in a different demo. In this demonstration, we'll be configuring the required network settings in order to make the Azure firewall work. Let's just double check that the firewall was deployed. So here in the Azure portal, I'm going to go to the All Resources view. We've deployed a firewall called Azure FW for Firewall East 1. I'll click to open that up. Now, one of the first things I want to do is check to see, by clicking Firewall Manager on the right and then the Visit Firewall Manager link at the top, whether or not our firewall is associated with the appropriate VNets, so virtual networks in the cloud. So it looks like it is linked to a VNet called VNet 1, as well as Ubuntu Serve 1 VNet and the Azure Firewall VNet, which is where we deployed the firewall. However, it says no firewall deployed for the other two VNets. Let's think about this. I've got virtual machines deployed within VNet 1, and I want them to use our firewall config. But currently it says no firewall deployed, but we've deployed one in a different VNet. What this is telling me is we're going to need to link those VNets together via peering. Okay, that's going to be important. So let's do that first. I'm going to go back to my All Resources view, and I'm going to go down until I find my VNet, VNet 1. and I'm going to configure the peering from here. So in the left-hand navigator, I'm going to go down under peerings. I've already got a peering from my Windows VNet to my Linux VNet, but not to the firewall VNet where the firewall is deployed. So let's add a peering. This is going to be VNet1 to FW to firewall, and then down below, the reverse peer connection link name will be firewall to VNet1, and we want to link VNet1, which is what we're in the midst of configuring, with our Azure Firewall VNet. So I'm just going to go ahead and click Add to add that peering connection. Now remember that when you peer VNets together, that you can connect to resources like virtual machines using just private IP addresses, which is great because we're going to need to be able to do that in the end. Okay, we've got a peered connection that's set up. Let's go back to our Azure Firewall and remember how we checked the virtual network association, but it said there was no firewall deployed? Let's go back and check all that work now that we've set up the peering connection. So I'm going to go back to the same place we were into the Firewall Manager Virtual Networks. And this time for VNet1, it says peered to a virtual network with the firewall. Excellent. So that's a good first step. Now, the other thing we have to think about is that for virtual machines deployed within VNet1, when they are going out to the internet, by default, that is allowed. They'll go straight out directly to the internet. I want to first route outbound traffic to our firewall appliance. So in order to do that, I need to configure some routes, or a route, specifically just one. Let's think about how we're going to do this. Let's go back to our firewall, because in the overview page of the firewall, we will have access to the private IP address. That's going to be important, so 12.0.0.4, and also the firewall public IP. I can click on that to get to the actual IP address itself, which is shown here. Now, this is important because connections from the outside, from the internet that need to come in through the firewall, need to come in through the public IP of the firewall. However, in the opposite direction, which we're talking, our internal virtual machines in the cloud, to force them to be routed through the firewall, we're going to need to make a route that forces traffic to the internal private IP, 12.0.0.4. So I've just clicked to copy that. So what this means is I'm going to go home, I'm going to create a resource, I'm going to create a route table. Just like you might configure a routing table entry on a physical router on premises, the difference here is we're using a GUI and we're doing it in the cloud. So I'm going to go ahead and I'm going to give a name for this thing after we specify the subscription and the resource group. Let's call it route table or RT1. I'll click review and create, and then I'll click create. Okay, so now I'll click go to resource so that we can create a routing table entry. So I'll click routes over on the left, and then I'll click the add button up at the top, and I'm going to call this 2FW for to firewall, and 0.0.0.0/0, so that's the default route in IPv4. I want to take all traffic and I want to forward it first to a virtual appliance, and here I'll paste the private IP of our Azure firewall. Now that's great, but we need to associate this route table with a subnet. Specifically, I want to associate with the subnet where I have virtual machines that I want to adhere to these firewall rules. So I'll click subnets over on the left, I'll click associate at the top, and in the list, I'll choose VNet1, and then I'll go ahead and choose subnet1 and click OK. So now we've got a route table entry that will ensure outbound traffic from within subnet1 first goes through our firewall appliance via its private IP address, and we've also linked our VNet via VNet peering to our Azure Firewall VNet so that it knows to use the firewall as well. In this demonstration, we're going to connect to a Windows virtual machine in the cloud to test that it's using the Azure Firewall to block connections to Facebook.com. So you might wonder why Paint is on the screen. It's because I want to diagram some of our work first so that it all makes sense. So let me draw two of our VNets that we've got as circles. On the left, VNet1, and on the right, I'm just going to call this our Firewall VNet. Now, what we have to think about is the fact that we have a virtual machine that is running in VNet1 that we need to connect to. And that virtual machine has a private IP of 10.0.1.4. Okay, well, what's going to happen is we're going to be making a connection from on-premises to the public IP address of the firewall, which in turn then needs to be translated to the IP address, the private IP address of our virtual machine. To do that, in the Azure Firewall, what we're going to need to do is configure a DNAT rule to allow connections from the outside to come into a private IP. So let's go ahead and configure that. Here in the Azure portal, I've opened up my virtual network called VNet1, and I've already gone down to peerings. I've already got a connected VNet peer link between my VNet, VNet1, and my Azure Firewall VNet. That's important because remember, to contact virtual machines using private IPs in a different VNet, you need to have a VNet peering connection set up. So that's been done. So let's go to our All Resources view at the top here. Let's open up our Azure Firewall to configure the DNAT rule. Our Azure Firewall is called Azure FW Firewall East 1. It's also got its own network security group. And if I open that and take a quick peek, inbound security rules are showing me that port 3389 is allowed from anywhere to any IP address. So that's important because we're going to open an RDP connection to get into our Windows VM to test that Facebook is blocked or not. Okay, so a lot of little moving parts here, but that's the way it goes. A lot of things working together to arrive at some kind of a solution. Let's go back into our firewall because we want that DNAT rule to allow inbound connectivity. I'll go to Firewall Manager and we'll just follow the link there. And I'll go to Azure Firewall Policies. Now, when you want to block, let's say, outbound access to certain URLs, I'll open up the policy, that is called an application rule. We've already configured application rules to allow or deny access to certain fully qualified domain names. So if I were to click application rules over on the left, any of those application rules would be shown. However, if I go to DNAT rules, this is where I need to configure a rule to allow incoming connections. So I'm going to add a rule collection, and this is going to be allow inbound, and it's DNAT, the priority, let's say, is going to be 300. And what I want to do is specify that this is part of the default DNAT rule collection group. The name is allow RDP. And what we want to do is specify the source IP. So from any source IP, protocol is going to be TCP port 3389. That's what Remote Desktop Protocol uses. The destination here is going to be the public IP address of our Azure Firewall. So why don't we go ahead and take a look at where that is exactly. I'll open a new web browser tab and we'll navigate to where we need to be to find out that information. So in the overview page of our firewall, if I click on the link for the Azure Firewall public IP address, here's where I'll see the actual IP. That's what I'm going to copy. So connections are going to be made to the public IP of the firewall from the outside to port 3389, which I want redirected to 10.0.1.4, the private IP address of my Windows server, and that's still listening on port 3389, so I'll go ahead and add that, click the Add button, and our DNAT rule will be showing up in just a moment. Okay, so our allow inbound RDP rule is now ready. So again, the public IP address is what's being used here for connectivity. So I'm going to copy that and let's test an RDP connection from on-premises into the cloud through this firewall. So I've popped in that public IP address in my remote desktop connection client and I'll go ahead and click connect. Now it's going to be good news if it starts asking us questions about do we want to log in or trust certificates and so on. So this is great. It's asking me to authenticate. So I'm going to go ahead and specify the password for that Windows virtual machine deployed in the cloud. And after a moment, it should take us directly into the desktop. Okay, so now in my virtual machine in the cloud, if I try to go to facebook.com, it says it can't reach it over HTTPS, might be temporarily down, might be moved. Of course, it's just being blocked by our firewall. But in another browser window, if I tried to go to something else that wasn't explicitly denied, like google.com, it still says that the action is denied because there's no matching rule, and therefore proceeds with the default action, which is to deny all. Scalability is an important aspect of cloud computing. With auto-scaling, we can make a configuration such that when things get busy, such as requests to an application, we can start scaling out horizontally, adding virtual machines to handle the increased workload. And when things quiet down, we can configure scaling in or the removal of VMs. Why pay for virtual machines to be running when you don't need them? So we're going to configure a virtual machine scale set here in Microsoft Azure. So to get started here in the portal, I'm going to click Create a Resource in the upper left, and I'm going to search for Virtual Machine Scale Set. Now, the idea is that we want to have a collection of back-end virtual machines servicing an app. So on the Virtual Machine Scale Set page, I'm going to go ahead and click on Create. So the next thing I'll do is just click Create. Next, I'll specify the subscription and resource group for this virtual machine scale set, and I'm going to call it App1 Scale Set. And I'll define this as being running in the Canada East region. Then I'm going to go ahead down below and take a look at the image. Now, all of the virtual machines have to use the same virtual machine image, which presumably would have an app loaded within it. So normally we would refer to a private image here that we've customized or captured as opposed to a standard marketplace image. I'll choose a Windows virtual machine. We can choose the sizing and then specify the username and password. And then I'll click Next for disks. So from here, we can determine what the operating system disk and any potential data disks that might be added to each virtual machine would look like. So we could create and attach data disks, but I'm not going to do that. I'll go to Next, Networking. We have to define the virtual network where we want to deploy these, so we can use a new one or an existing one. I'll choose an existing virtual network. Then we configure the network interface information for each backend virtual machine in the scale set. That's already been configured, and it's going to be using subnet 2, which was already created in VNet 1. And we could also tell it to use a load balancer if we wanted to, but we won't do that here. I'll click Scaling. Now, in the scaling configuration, we're going to start off at 2 instances, but if I go to Custom, the minimum of 2 is great, but we have to specify what it can grow to. Let's say up to 6 virtual machine instances. What's going to trigger that is when the CPU percentage overall for all existing VMs, once it gets to above 75% for at least 10 minutes, we start increasing the number of virtual machines. We start to horizontally scale out by adding 1 VM at a time. When things quiet down, in this case means 25% CPU utilization. I'm going to keep those, and I'll click Next for management. I'm not going to change anything there. We could also specify some health settings. How do we know that a backend instance is healthy? We could enable health monitoring, such as pointing to port 80 to the root of each backend VM. So if port 80 is not reachable, for example, then the instance is deemed as being unhealthy and will not receive client requests. So I'm just going to continue through here. We're not going to add any additional settings here, so I'll just click Review and Create in the bottom left. And to create the virtual machine scale set after it has run the validation and the validation has passed, I'll just click the Create button in the bottom left. So after a few moments, if I go to the All Resources view, my scale set will show up. And if I click on the scale set to open up its properties, in here, I can change some of the configuration or check out the number of backend instances currently running. So if I click on Instances on the left, we've currently got 2 backend virtual machine instances running based on the image we configured, but notice that the health state of both of them is unhealthy. And that's only because we configured a health check for HTTP port 80, and of course, the image I selected does not have a web server listening at all, let alone on port 80. So therefore, they are quite rightly showing up as being unhealthy. But what's interesting about this is that we've got these 2 virtual machine instances running for the scale set, but if I were to take a look at my regular running virtual machines in Azure, the ones for the scale set do not show up here because the ones in the scale set were created only as a result of the scale set, not manually as infrastructure as a service. And so if I want to start managing those instances, then I have to do it at the virtual machine scale set level. When you're working with cloud computing, you might come to a point where you need a centralized and secured way of storing secrets. The secrets would include things like database connection strings, maybe that software developers will refer to in their code, or working with decryption keys and encryption keys for protecting data at rest, whether it's in a storage account in the cloud, virtual machine hard disks, and also working with PKI certificates. All of these items can be managed centrally in a Microsoft Azure Key Vault. So let's get to it. Let's create one. Here in the Azure portal in the upper left, I'll start by clicking Create a Resource, and I'm going to search for Key Vault. And then after that, I'll click on Key Vault, followed by clicking on Create. So as usual, when I build something in the Microsoft Azure cloud, I'll have to tie it to a subscription and also deploy it into a resource group. So I'll use an existing resource group. The key vault name, let's say, will be KV172 East. And I'm going to deploy this, let's say, in the Canada East region, only because that's where it will be accessed most frequently. And by default, it's set to retain deleted vaults for 90 days for safekeeping before it's permanently purged. That's fine, I can accept that. But the next consideration is who or what, in terms of software, will have access to the secrets in the vault. That's called an access policy. And so let's go down and click Next, Access Policy. So I can determine, for example, that disk encryption is enabled, which would allow virtual machines to be able to come in and find an encryption key I choose when I configure disk encryption for VMs. But the Vault Access Policy automatically includes who I'm currently logged in as, a user called ITDemo1. And for keys, these are decryption keys, we have all permissions. For secrets, which would include things like database connection strings, all permissions. Same goes for PKI certificate permissions. Now, of course, we could click Add Access Policy, and we could select other users or groups and determine which of those 3 sets of permissions are applicable. But I'm okay with what we have here for now. So having done that, I'll click Next for networking. So from which other networks should this key vault be accessible? The default is public, all networks, but we could choose selected networks where we can add an existing virtual network. So let's say, for example, I want to restrict it so that only virtual machines or software code that's running somewhere within VNet 1 is allowed to talk to this key vault. So I'll choose VNet 1, and from here I could even specify the subnet. So once I've done that, I would just click Enable. So I'm limiting or restricting access to this key vault from certain networks. So I'll click Next for tags. I'm not going to add any tagging information. So Next, Review, and Create. And once the validation has passed based on my selections, I'll create the key vault by clicking Create in the bottom left. Okay, so now I'll click Go to Resource. And what we're going to do here is, let's say, generate a key. So if I go to keys, any existing keys in the key vault will be listed. But of course, there will be none because we've just created this key vault. So I'll choose Generate Import up at the top. Now, I don't have any existing keys to import, so instead, I can choose to generate keys. I'm going to call this key 1. It's going to be an RSA key, let's say 2048. And the great thing about this too is I can set when the key becomes active and when it expires. So I'm not going to put those values in, so it's always valid. And I'll click Create. Now I get a message at the bottom that says, well, love to do this for you, except I can't because the firewall for the key vault is turned on and your client IP address is not authorized. Oh, okay, so what do I do to fix that? Not a problem. Let's close out of this. We'll have to come back and do this again, but it's not the end of the world. What I want to do is configure the security for this particular key vault. So I'm going to go ahead and click Networking over on the left. Now the firewall is shown down here below. However, what I want to do is make sure that our client IP is allowed to access this key vault. So I've pasted in my public IP as it's known from the network I'm working from. Now, the only reason that we're blocked out is because, remember, we restricted network access to VNet 1, subnet 1. But that's okay. We fixed this. So let's go ahead and click Save to save that firewall configuration. Then we're going to go ahead and we're going to try to create an encryption key again. So for that, let's go back to keys on the left and let's do what we did before. Generate import key 1, and we'll click Create. And this time it will accept this administrative activity because our client IP is added to the firewall. So key 1 now shows up. We could also create a secret. I could choose Generate Import. And normally this would be used, for instance, for a database connection string. So let's say DB1 string. And then we could enter in whatever the string value is. We could set an activation and expiration date. And we could choose Create. And then that will be stored here so it can be referred to instead of writing that kind of thing into code. And finally, we can also generate PKI certificates that we might want to use, let's say, for HTTPS website bindings. So I'll click Generate Import. Again, I'm not going to import, I'm just going to generate, and maybe this will be called Website 1. It's a self-signed certificate where the common name would be www.website1. Let's say com. Configure the DNS name for it, which is normally the same, www.website1.com. I'll just click OK, and I'll accept the default for the details down below, and I'll click Create. So we've created each of the 3 types of secrets that are available centrally in this cloud-based key vault. Encrypting data at rest is really these days required by most data privacy standards. So to enable this in the Azure cloud, I'm going to begin by creating a storage account. Then I'm going to use a custom encryption key to protect data at rest, to encrypt the contents of the storage account. So to get started here in the Azure portal, I'm going to click Create a Resource in the upper left. And what I want to create is a storage account in the cloud. So I'll search for Storage Account. And when it pops up in the list, I'll then select it. And then I'll click on Create. So I'm going to deploy this into a specific resource group. And I'm going to call this Store Account East 172 or 182 in this case. I'm going to specify the region where I want that deployed. And really, I'm just going to accept a lot of the defaults here, including allowing access from any networks, if that's the purpose of this, if we should allow anonymous access, or it could be selected endpoints. So I could select that and specify VNets and so on. However, here I'll leave it on public. Next, for data protection, we can turn on things like point-in-time restore, soft delete, so that we have items that were deleted that are available for a period of time before they're permanently removed. So for example, for 7 days. So I'm going to go ahead and continue on through this wizard. And basically, I'm going to go to Review and Create to the point where, after it passes the validation, we will click Create to create this storage account. So now that it's deployed, I'll click the Go to Resource button to open up the properties of our storage account. And over on the left, what I'm really interested in is going down to encryption. On the right, currently, Microsoft managed keys are being used to protect data at rest in this storage account. And that might be fine, but in some cases, maybe even for regulatory compliance, you might need to control encryption keys, in which case you could choose customer managed keys. And down below, I could select from a key vault. So I'll click the key vault link. And from here, I'm going to choose the key vault from a list. And within the key vault, of course, I could choose the encryption key. Now, I've already created a key vault and a key, so I'm just selecting what I've created previously. So I'll just go ahead and choose Select and Save. So in this way, we've got not only protection through data at rest, encryption, but we have complete control of the encryption key that was used to do that. Encrypting File System, or EFS, is a built-in Windows way to encrypt individual files or folders for the user that's logged in when encryption occurs. Now take note though, this is not available with every edition of Windows operating system. So, for example, if you're using Windows 10 Home Edition, EFS encryption is unavailable. So to get started here on my Windows server, let's take a look at the file system. So I'm going to open up Windows Explorer, and I've got a folder here with the sample file on drive C. The folder is called Projects, and the file is called project_a.txt. Now, nothing has been encrypted yet. What we will see when things are encrypted here in the GUI is a little gold padlock icon. It's kind of hard to see because it's very small, but we will see the padlock icon for folders or files that are encrypted. And before we embark on that, let's go into the Start menu and let's launch the Microsoft Management Console. And before we jump into that, let's go into a command prompt, CMD, and I'm going to go ahead and run MMC, Microsoft Management Console, where I'm going to go to the File menu and Add Remove Snap-in. The idea here is I want to take a look at any existing certificates I have at the user level on this host. So therefore, I want the certificate snap-in. I'll click Add. It's going to be for my user account, who I'm currently logged in as. And so I'm going to drill down on the left under Certificates, Personal, and Certificates. So it looks like we've got an administrator type of file recovery certificate. Okay, let's leave this open and let's go ahead and go back to our Windows Explorer GUI. And I'm going to enable encryption for the Project A text file. Now, take note that that can only happen on NTFS file systems. So if I were to right-click on Drive C and go into Properties, well, I can see from here that the file system type indeed is set to NTFS. Okay, that's great. Let's right-click on the file we want to encrypt, and let's go down to Properties, click on the Advanced button. You can choose to either compress or encrypt the file, but you can't do both at once. So I want to encrypt this, of course. Notice that the Details button is grayed out. So I'm going to click OK and OK. I'm going to tell it I only want to encrypt the file. And after a moment, it's done. Now, it's hard to see, but there's a tiny little gold padlock icon that is now listed on the file, which indicates visually that this is an encrypted file that's been encrypted with EFS, Encrypting File System. As an end user logged in with the account that encrypted that file, everything's transparent. If I double-click to open it up, it just opens it up and I can see what's in the file. If I were to right-click on that file again and go into Properties and into Advanced, the Details button is now available. So we can add users that we want to have access to this file. It's not limited only to the user that was logged in when it was encrypted. So what happens is we have to be able to select users and their certificates to add them to this file. Down below, we have the recovery account. That's the administrator account for the Active Directory domain by default that can decrypt any files from any domain-joined computers. Again, that could be modified too. However, if we wanted to turn off encryption, we would simply remove the check mark, basically reverse our action, and it's done. It's no longer encrypted. We could also encrypt the entire folder. So if I right-click on the Projects folder and choose Properties, go into Advanced, really the same thing I would do for an individual file. And if I were to choose Encrypt Contents to Secure Data, and then click OK and OK, I'm asked if I want to apply it to the folder only or the folder and everything in it. Well, if I choose Apply to this folder only, when I go into that folder, the Project A file is not encrypted. We know that because it doesn't have the little gold padlock icon. Okay, well, that's interesting. However, if I create a new file in there, so let's create a brand new file. We're going to call it project_b.txt. We can already see in the icon that it's encrypted with EFS because it's got the gold padlock. So when you enable EFS encryption for a folder, it will affect new files, at least the way that we have configured it. Now let's go into the command prompt, because you can also manipulate encrypting file system using the cipher.exe command line tool. So if I run cipher /?, it gives me some help screens about how to use this command. So I'm going to change directory here, let's say to C:\projects, clear screen. If I do a dir, there's the two project files. But if I simply run the cipher command with no parameters, it simply lists the items in here, the two files, and Project A is a file that is unencrypted, that's the U, where Project B is encrypted, that's the E. So if I were to issue the command cipher /decrypt or /d for everything in here that is a txt file, now if we clear the screen with CLS and if we run cipher, both files are now unencrypted. In the same way, if I were to run, let's say, cipher /e for encrypt, let's say just for everything with every file extension, then it looks like two files were encrypted. And once again, if I clear the screen with CLS, not clear, that's Linux, then I could use the cipher command, and now they're showing as being encrypted. Now, remember how we had the MMC, the Microsoft Management Console, open viewing certificates for the user on this host? Well, if I go back to that and just make sure I'm refreshed, looks like it's refreshed, notice I've got a second certificate here that wasn't there previously, and specifically, it's an encrypting file system or EFS certificate. So this certificate is used in the EFS encryption process, and if we don't have a certificate, it is issued automatically as evidenced by what we're seeing here. Now, users that log in and attempt to access that encrypted file will get an access denied type of error message because the file was not encrypted for them and they weren't added to have access to that file. Unlike encrypting file system in Windows, BitLocker allows you to protect data at rest at the disk level It's tied to the machine, normally through TPM. You don't have to use the TPM chip to store decryption keys. However, BitLocker is a disk volume encryption solution. EFS is for files and folders. So to get started here, Windows Server 2019, if I go to the Start menu and type in Bit, I have the Manage BitLocker option from the control panel. Now, when I click on that to launch it, I get nothing. The reason is because that component has not been installed. It's possible, it's just not there. So I'm going to go into my server manager here in Windows Server 2019, not because this is the only way to add that component, but I do want to add that component, and I can do it here in the GUI. So in the server manager, I can click Add Roles and Features, and I'm going to go through and accept all the defaults for the current host. And I'm interested not in roles, but rather in features. And you'll see that BitLocker Drive Encryption is listed here. So I'm going to click Add Features for the admin tools required to administer that as well. That's all I need. I'm going to go ahead and click Next and install that Windows Server 2019 feature. And I'm then told that a restart is pending on this host. So I'm going to go ahead and close out, and I'm going to go ahead and restart it now. Okay, so now that I've rebooted, BitLocker is available, at least as an option. And so if I were to go, let's say, into a command prompt and start issuing commands like manage-bde BitLocker Drive Encryption -status, we'll get just that, status of what's going on. So it says disk volumes that can be protected with BitLocker Drive Encryption, Drive D. So that's interesting. We've got a second disk drive here that isn't yet encrypted, but we can enable BitLocker on it. So I'm going to go to my Start menu, and I'm going to type in Bit, and notice that the Manage BitLocker icon now is not grayed out, but rather available because the component is installed. So we can see that for Drive C, BitLocker is currently off. We can turn it on. And the same thing is true here for Drive D. I can click on the link to expand it, and I have the option of turning on BitLocker for Drive D. It then asks me, how would you like to unlock this drive? Use a password or a smart card? Now, I'm going to use a password, so I'm going to go ahead and enter and re-enter the password, and then I'll go ahead and click Next. Now, it says, how do you want to back up your recovery key? Now, this is going to be important if the password is forgotten. We can print it or save it to a file. So I'm going to go ahead and choose Save to a File. We're just going to store this on Drive C for now, but of course, that's useless if the whole machine is encrypted or there's a problem accessing the contents of the drives. So it really should be backed up somewhere safe. Now it says you can't save in the root directory of a non-removable drive. So it's got a built-in checker to make sure that we are saving this in the proper location. So in this case, I'm going to choose Print the Recovery Key. We'll print to PDF. I'll store this, let's say, on Drive D. I'll call it Key. So I'll go ahead and click Save. And now we can go ahead and click Next. So at this point, it says, how much of your drive do you want to encrypt? Use disk space only or the entire drive? Well, technically, there's nothing that's on that drive yet. It's a brand new disk phone that's been added to this host. So I'm going to use the Encrypt Use Disk Space Only, as it recommends that it's faster and best for new PCs and new drives. Fine, no problem. Next. I'm going to leave it in compatibility mode for the encryption mode to use. And I'm going to choose Start Encrypting. Now, depending on how big the drive is and what's on it, how much data, and which option we've elected to use for encryption will determine how long it takes. But we can see that it looks like it's happened already. We no longer have the option to turn on BitLocker to protect data at rest on Drive D, but instead we have options such as backing up the recovery key, changing the password, adding a smart card, or even turning off BitLocker. So if we were to go back to the command prompt, let's do that again, CMD, and let's issue the command we were issuing in here previously, which was manage-bde-status. We can now see that the conversion status says that used space only is encrypted, and that we're using AES 128-bit encryption. Protection is now on. But of course, when the machine is up and running, the encryption is not enabled. In other words, it's unlocked. So if you had a malware infection on this host, BitLocker doesn't really help with anything, because once the machine is up and running and that volume is unlocked, it's as if it's not even encrypted. So the protection here is at the disk or volume level. So if someone were to steal the disk out of the machine that had no power and try to put it on their machine, they wouldn't be able to access it. IPsec or IP security is a suite of network security protocols. It can allow for the encryption of IP traffic or for the authentication of it to make sure the message came from the device it says it came from. So we can use IPsec then on an individual machine or in a Microsoft Active Directory environment. We can do it centrally through group policy. So here on Windows Server 2019, I'm going to go into the Start menu and I'm going to type in Firewall. That will let me pop up Windows Defender Firewall with Advanced Security. Now, of course, Windows Defender Firewall can be used to define inbound and outbound rules to allow or deny traffic as it might be. But it's also got connection security rules. Here, we could right-click and build a connection security rule to determine how IPsec should behave. Now, by doing that on this host, we are only configuring IPsec on this host. However, we can also do it centrally through group policy, which would potentially affect multiple computers joined to the Active Directory domain. So from the Start menu, let's open up the Group Policy Management tool. So I'm going to go down under Windows Administrative Tools, and in the G's, sure enough, there's Group Policy Management. Every Active Directory domain has a default domain policy. That's a group policy object or GPO that could potentially contain thousands of settings. Now, it's linked or associated with the domain, so by default, it flows down to all organizational units. Unless we've got an organizational unit or OU, as we do here, that's got block inheritance turned on. That's what that little blue symbol is. So if I right-click, block inheritance means what it says. Do not allow GPO settings from above to be inherited into this OU. And in this case, it's for admins. So let's go ahead and right-click on the default domain policy and choose Edit so we can talk about where to go to configure IPsec connection security rules. That's going to be under Computer Configuration. You have to expand Policies and go to Windows Settings. And under there, you'd then go into Security Settings. This is where the vast majority of Windows security settings are configured in group policy. It's at the computer level as opposed to the user level. So the computer that is joined to the Active Directory domain. So I'm going to go down under Windows Defender Firewall with Advanced Security. Just keep drilling down under there so we can see we can specify inbound and outbound rules, just like we could on an individual host, but we can also configure connection security rules. So the difference here is, well, at least by default, these rules will apply to all computers in the domain, of course, except where block inheritance has been turned on for OUs. So I'm going to go ahead and right-click on Connection Security Rules and choose New Rule. Depending on your requirements, will determine which type of connection you select here. For example, here I'm going to choose Server to Server. I want to authenticate connections between specified computers. So I'll select that. I'll click Next. It asks if I want to specify IP addresses on each end of the connection. So we can specify specific IPs that would have this affected. So they would get these settings, in other words. I'm going to leave that to any IP address. Then we have the option. How do we want IPsec to be negotiated? Do we want to request it for inbound and outbound connections or require it for inbound connections, but request authentication for outbound, or require for inbound and outbound? By requiring for both inbound and outbound connections, that means that the hosts affected by this group policy object and these connection security rules, they will only talk to other machines configured similarly. Now, in a highly secured environment, that might make sense. But if the machine, for example, needs to connect to an internet host, that could be a problem if that internet host is not configured with the same IPsec connection security rules. So I'm going to choose Request for inbound and outbound. So if a machine that is communicating with a server affected by this doesn't support IPsec, communication will still take place after checking to see if IPsec could be used. So I'm going to go ahead and click Next. We can use a computer certificate to authenticate machines to one another, but I could also click Advanced and choose Customize. And I've got two authentication methods I could select from, where if the first one fails, the second one kicks in. So if I click Add, it can be Computer Kerberos V5. Now that's the Active Directory Authentication Protocol. So for domain-joined computers, that's a good choice. There already is an implied level of trust by virtue of those hosts being joined to Active Directory. You could choose the older NTLM LAN Manager v2 protocol, PKI certificate, or you could use the least secure option, a pre-shared key, where you would put in the same item on both ends of a connection to allow them to communicate. But because in this case, I only want this applicable to domain-joined computers, it just makes sense to use Computer Kerberos v5. So I'm going to click OK and OK, and I'm just going to continue specifying which network location profile that this applies to. I'm going to leave it selected for all, so whether we're joined to an Active Directory domain network, if we're on a private network or public. And in the case of a server, servers don't get carried around and moved, at least ideally they wouldn't be. So that probably isn't an issue when it comes to private and public networks. So I'm going to click Next. This is going to be called Request IPsec. And then I'll click Finish. Now at this point, we've got that configured. Let's just switch back to that detailed screen. We've now got Request IPsec, which is now enabled in group policy. Now remember that group policy has to refresh before we can expect to see that on machines joined to the domain. So if I were to go back into Windows Defender Firewall and look at connection security rules, I don't see it there. But if I were to refresh group policy, so let's go to a command prompt, let's run gp update /force to force a group policy update manually just to test it. You wouldn't want to run to every computer on the network and do this, nor would you want to remote into them. It'll just happen automatically. Normally, the refresh interval is approximately between 60 and 90 minutes. Now that group policy has refreshed, if we check Windows Defender Firewall on this individual host, we'll see the request IPsec connection security rule. And when a session has actually been established between two hosts that support IPsec, you would see it under monitoring. Now, if you were to capture IPsec traffic, which I have done using the free Wireshark tool, and then let's say we filter the traffic for ESP encapsulating security payload, I have a number of ESP packet transmissions shown in the capture. Now, if I select one of them and go down into the packet headers, so I've got my standard Ethernet header with the source and destination MAC addresses. I've also got the IP header, which has my standard IP address information, among other items, so source and destination IP. But after that, in the IP header, depending on the traffic, I might expect to see maybe a TCP or a UDP header, but I don't even know what type of traffic this is, because what follows is encapsulating security payload. So I've got encapsulation done here where an entire original packet has been encapsulated and new headers have been added. So in this way, the traffic is protected. For all I know, this could be FTP traffic, but due to ESP, encapsulating security payload mode, I don't know what it is. And so the traffic then is secured. In this demonstration, I will be deploying a private certificate authority, or CA, first in Windows Server on premises, and then in the Amazon Web Services cloud. So let's start with Windows Server first. And I'm going to open my Start menu because I want to go into PowerShell to get started to see what's installed. And here I could, for example, get-Windows feature, and I could ask it, let's say with wildcards around it, for ADCS, Active Directory Certificate Services. And I can see that all of the components that are available for Active Directory Certificate Services are shown here, but there's no X in the box. It's not installed. So I could use either the add or install-Windows feature commandlet, doesn't matter which one, and specify the names of the components that I wish to install here in PowerShell and whether I want to include the management tools. But I can also do this through the Server Manager GUI. So from the Start menu, I'll click on Server Manager. Basically, I can add the ADCS, Active Directory Certificate Services role, and then configure it accordingly after it's there. So I'm going to click Add Roles and Features. Just going to go through the first couple of screens in the wizard, accepting defaults until I get to Roles, and I'll turn on Active Directory Certificate Services. And it says, well, what about the remote server admin tools? Yeah, I want those too. So I'll click Add Features and Next. And I'm just going to keep going through the wizard. All I really want is the certification authority. I do have some other options like certification authority, web enrollment, and so on. but I don't want those, just the certification authority piece. And then I'll just go ahead and choose install. And we can see that the installation has now begun. Okay, before you know it, the feature is installed. So I'm going to go ahead and click close. Now this is great because we can establish our own PKI hierarchy to issue digital security certificates to help harden our environment if we're not already doing this. Certificates might be issued to users or devices to authenticate to a VPN, to encrypt files, to secure connectivity to web apps, you name it. So now that we've got that installed, if I go to the Tools menu, we then now have a certificate or certification rather authority option. You can also launch that from your Start menu. Now, of course, we get this message initially says, well, I can't manage Active Directory certificate services. File not found. Okay, no problem. So it still opens up the console. Now, we don't have it configured, so there's nothing to show here in the console, which is why it spawned that error message. So we need to deploy a new CA. That's what this little icon is up here in the notifications area in Server Manager, up by the flag. So if I click there, it says, oh, there's a post-deployment configuration. You need to configure Active Directory certificate services. Of course we do. We can't launch the tool until there's a CA. So I'm going to go ahead and click on that. And it looks like we've got the default admin credentials for this host filled in there. That's good. Going to go next. I'm going to select certification authority so we can proceed to configure that. Now, we can't have an enterprise CA because the server needs to be a member of an Active Directory domain. We don't have an Active Directory domain, so it's going to need to be a standalone CA. That's fine. I'll click next. Can't have a subordinate CA until you've got a root. So we're going to start off with root here. That's all we're going to use. I'll click next. I want to create a new private key. Now remember, the CA's private key is what gets used with a hashing algorithm like SHA-256 to digitally sign the certificates that it issues. Fine. Having said that, let's click next. SHA-256, all good. That's normal. Now we have to give a name to this CA. So I'm going to call this CA1. And then I'm going to click next. The validity period for the CA certificate will be 5 years. So within that 5-year period, I need to renew it. Depending on your organization's policy on how PKI should be configured will determine whether you leave that at 5 years or increase it to 10 years or reduce it, whatever the case might be. I'm going to accept the default of 5 years, and I'll click next. Same on the database locations, next again, and we've got the summary screen. Okay, let's click configure to get the CA up and running. And just like that, it says the configuration succeeded. Close. Okay, now let's go back to the Tools menu, but this time it's going to work. We're going to choose Certification Authority. It's not going to squawk about file not found because we have a CA. There it is listed on the left, CA1. Now from here, we would see any issued certificates or anything like that, but we don't have that yet because all we've done at this point is deployed a private CA using Active Directory certificate services. So now let's take a look at how to deploy a private CA in a cloud computing environment, specifically in Amazon Web Services. So to get started here in the AWS Management Console, I've signed in with my AWS account. I'm going to search for ACM. That's the Certificate Manager. I'm going to click on it to open it up. And what I want to do is I want to deploy a new certificate authority. So I'm going to go under Private Certificate Authority. Now this means that the certificates that will be generated are from my own certificate authority, and that means by default, devices will not trust the validity of those certificates. Devices have lists of public certification authorities whose certificates they would trust. Now that list can be modified on devices, but that's just the default behavior. So Private Certificate Authority, I'm going to go ahead and click Get Started. Now I'm going to create a root certificate authority. That's the top of the PKI hierarchy. Now, if we already had a root CA, we could create a subordinate CA for a different business unit that controls its own certificates, or maybe for a different part of the world, different region, different country. But here I'm going to leave it on root CA, and I'm going to click Next. Then I have to fill in some values, such as the name of the organization, an organizational unit, country name, state or province, and so on. So I'm going to go ahead and fill that out. So now that I've filled in all the details, including the common name for the CA, I'm calling it Private CA1. I'm going to go ahead and click Next. I'll accept the default key algorithm, RSA 2048-bit, and I'll click Next. I'm not going to configure a certificate revocation list, or CRL, a curl, otherwise it's called. I'll click Next, and I could add a tag, so metadata. I'm going to add name, and I'm going to call it private CA1, so it shows up that way when I view it here in the Amazon Web Services interface. So I'm going to authorize this to renew certificates. Certificates have an expiration date, so I want to be able to renew them with the CA. I'll click Next. And on the summary screen, I'm happy with this, so I'm just going to click here to confirm that I might be charged a monthly fee, and I'll choose Confirm and Create. And it's on its way to creating our private CA. It says, your CA was created successfully. Okay, well, I can click Get Started, and here I can see the CA certificate parameters, so the validity is going to be for 10 years. Okay, I can see the signature algorithm here is SHA-256 with RSA for digitally signing certificates that are issued from this CA. I'm okay with both of these, so I'm just going to continue on to click Next and confirm and install to make sure that my private root CA is ready to go, and it is. We can now see private CA1 has a status of active. PKI certificates are used for security purposes, whether it's authenticating to a VPN or securing the communications to and from a secured website that's been enabled for HTTPS. It can be used for encrypting files on a device, and so on and so on. So what we're going to do here is we're going to see how we can customize certificate templates that are used to issue certificates. There are times you might want to customize details like when certificates expire, or how the name of the subject in the certificate is created, and so on. Now, to do this in Windows, I'm first going to launch the Server Manager GUI tool because I want to install the Certificate Services feature. Okay, and now I'm going to click Add Roles and Features, and I'll click Next. Just going to go through and accept the defaults because I want to install on this server, and I want to install the Active Directory Certificate Services role. So I'll turn on the check mark. It'll ask me if I want to install the additional tools. I'll click Add Features, and then I'll click Next, and then I'll click Next. I don't want any features installed. I'm going to continue on. I want the Certification Authority installed. I don't want the other components shown here. So I'm just going to continue by clicking Install. And before you know it, the installation is complete, but we're not done. I'm going to click Close because I have to click my notification icon in the upper right and do some post-deployment configuration for Active Directory Certificate Services. Because what I'm going to be doing here is creating a certification authority, and then we'll get to the point where we can manage custom certificate templates. So I'll click Next. I'm going to turn on the check mark for configuring certification authority. I'll click Next. We're going to have an enterprise root CA. Create a new private key. I'm going to call this Cert1, and I'll click Next. 5 years for the validity period of the certificate, and we'll continue on to the point where I click the Configure button. Okay, once that's done, we can then launch either from the Start menu or here in Server Manager in the upper right under the Tools menu, we can go in and take a look at our certification authority now that it's been configured. And what's interesting is if I expand that on the left, and if I click Certificate Templates, I have a number of default certificate templates from which certificates can be issued. But let's say I have a very specific need for a custom web server certificate that has different settings than the current web server template. So what I'm going to do is right-click on Certificate Templates and choose Manage, which opens up a new window where I have an alphabetical list of all available certificates. What I want to do is copy the web server certificate template that's here, and essentially I want to modify it or customize it. So I'm going to right-click on it, duplicate template, and I'm going to call it Custom Web Server. Let's say the first thing we want to do here is reduce the validity period from 2 down to 1 year. So the certificate needs to be reissued every single year. You can also choose here, let's say, to publish the certificate to be stored in Active Directory. For the subject name, we can have it supplied in the request manually, or we can have it built from information stored in Active Directory, like a DNS name assigned to a computer. So it's a little more automated that way. And if I go under issuance requirements, we can require manual approval from a certificate authority certificate manager before the certificate is issued from this template. All right, well, that's an interesting option. If I go to the security tab, this is where I can determine who is allowed to enroll using this template, meaning acquire a certificate that is minted from this template. So what I'm going to do is make sure authenticated users is selected, and under allow, I'm going to put a check mark next to enroll, and I'm going to choose OK. So at that point, I've got my custom web server template shown in the list. However, back here, even if I refresh in the certification authority tool, the custom web server certificate is not shown. And that's because I've not issued it to be used yet. And so I'm going to right-click on certificate templates on the left. I'm going to choose new certificate template to issue. And this is where I'm going to choose my custom web server template. I'll choose OK. Now it shows up. So for example, if I were to go into a command prompt, now I'm doing it on the same host where I've configured all of that. It could be a different host joined to the domain. But if I run MMC, and let's say I go to File, Add, Remove, Snap in, it's going to be certificates for the computer, in this case, or web server. And I'll continue through that. Over on the left, under Personal Certificates, any existing certificates that are issued will show up. Now, because we've just set up our own certificate authority, that certificate shows here. What happened to issue a certificate from that template is when we get a request like this, right-click on Certificates, All Tasks, Request New Certificate, we'll be able to select the custom web server template. Now, from here, if no information is required from us, the requester, we'll be able to choose Enroll, at which point the enrollment will be pending. Now, you might remember in our template, we required CA manager approval. So if we go back to the pending requests view, here it is. So the administrator then could look at this, decide that it's valid, and choose to issue the certificate. So now that certificate is issued, and it shows up under the Issued Certificates view here in the Certification Authority tool. PKI certificates can be issued manually, which might involve the creation of a certificate signing request, or it can be completely automated. For instance, in an Active Directory domain environment, you might configure a policy with certificate auto-enrollment. However, in this particular example, I'm going to request a PKI certificate using the Windows environment. And so to get started, I'm going to go to a command prompt. I'm going to make sure I run that as an administrator so that it's an elevated command prompt. From there, I'm going to run mmc.exe, Microsoft Management Console, from which I'll then go to File, Add, Remove, Snap-in. Snap-ins, of which there are many, allow you to manage some aspect of a Windows environment, including certificates. So I'm going to choose Certificates. I'll click Add. I'm interested in computer certificates in this case. I'll click Next. It's going to be for the local computer, so I'll go through that, click OK. And now Certificates Local Computer shows up here in the left-hand navigator. So I can go down under Personal Certificates. All I see here is CA1, because the computer on which I am doing this is actually the server where the authority, the CA, was configured. But I don't have a computer certificate. So I'm going to request one. I'm going to right-click on Certificates, choose All Tasks, Request New Certificate, Next, Active Directory Enrollment Policy, Next. Now from here, I can see all of the templates that are available. And if I have any custom templates that I've created, they may not show up here if the appropriate permissions were not set. For example, I have a custom template called Custom Web Server, but it's not showing up. Even if I choose Show All Templates, I'm not going to see it. Okay, what's the problem? Well, let's cancel out of here, and let's fire up under Windows Administrative Tools from the Start menu, the Certification Authority tool. And then in there, I can see CA1. I'm going to right-click on Certificate Templates, Manage. And I'm going to take a look at the Custom Web Server certificate here, because in the Security section, we need to make sure that we've got the ability for enrolling. So authenticated users here, notice here, has read but not enroll. Now, we're not talking about auto-enrollment through group policy, just manual enrollment. So I'm going to turn on enroll for authenticated users, because that also includes servers that are authenticated to Active Directory. And in this case, I'll click OK. Now let's flip back into what we were doing. We were in the midst of right-clicking here in our MMC add-on for certificates, all tasks, request new certificate, next, and next. There's custom web server because the enroll permission is now enabled. Perfect. Okay, that's what I want. I'm going to choose that, check mark, and click enroll. And it says succeeded. That was easy. Well, it's supposed to be. So we can see here that we've got a certificate issued to this server's name. That's the fully qualified DNS name of this host, issued by a CA called CA1. So now, if I were to double-click, let's say, to take a look here, what's the purpose of the certificate? Ensures the identity of a remote computer. We can also see the validity here is only up to 1 year, and that would come from the template that defines settings such as that. So at this point, we have successfully issued an on-premises PKI certificate, and in this case, it's from a private CA with a custom template. Now, the next thing I'd like to do is request a PKI certificate from a private CA that I've already deployed in Amazon Web Services in the cloud. So to get started, let's take a look at our existing private CA. So here in the AWS Management Console, I'm going to search for ACM, and in the search results, I'll click Certificate Manager. On the left, if I go to private CAs, indeed, there's private CA1 for the Quick 24x7 organization, and its status is listed as active. It's a root CA, so it's at the very top of the PKI hierarchy. If I go to Certificate Manager over on the left, I can click Get Started, and I can request either a public certificate issued by Amazon. I don't want that. I want to request a private certificate issued by my CA. Now understand that when you request a private certificate for security purposes, let's say for a website, that certificate isn't going to be trusted by anyone visiting that website. And that's because it will have been issued from a private certificate authority, which anyone can do. So where's the security? However, that's fine. We can configure devices to trust certificates issued from a private CA if we so choose. So request a private certificate. I'm going to click Request a Certificate. Then I choose the CA from the list. There's private CA1. I'm going to go ahead and click Next. Now for the domain name here, let's say I want to secure a site, www.fakesite1.com, and then I'll click Next. And I can add some metadata here, some tags, so the name will be fake site1. And then I'll click Review and Request and Confirm and Request. Now at this point, in the Certificate Manager view on the left, we can now see we've got a certificate issued for our site. The status is that it's been issued. So we can go ahead and select that by putting a check mark in the box on the left, and under Actions, we can export the private certificate part of that and protect it with a passphrase if we so choose. But if we're going to be using that certificate within Amazon Web Services, then we really don't have to do anything. We don't have to export anything because we'll be able to select it from a list. There are quite a few ways that PKI certificates can be generated. You can have an on-premises private certificate authority or a cloud-based certificate authority that you have PKI certificates issued from, or you might get certificates issued from a public trusted certification authority. What we're going to do here in the Microsoft Azure cloud is we're going to create a key vault. A key vault is a centralized repository for secret items like PKI certificates. Now, in the key vault here in Azure, we can either import existing PKI certificates we have, or we can generate new ones to be used in the cloud environment. Or even you can export the certificate information and use it outside of the cloud. So let's get started with this. Here in the portal in the upper left, I'm going to start by clicking Create a Resource because I want to start by creating a key vault. So I'm going to type in Key Vault. I could browse through the categories, but I'll just select it this way to get started. Then I'll click Create. I have to associate this key vault with an existing subscription for billing purposes, so I've done that. I'm going to deploy this into a resource group, which is used to organize cloud resources that are related together in one unit. So I'm going to call this KV172Y8Z. So in the cloud, I want to make sure I'm following organizational naming conventions. So as we build more and more resources, the nomenclature makes sense. The region here, I'm going to select as Canada East. Now the pricing tier is currently set at standard, but if I were to choose premium, it would allow me to use HSM-backed keys. HSM, that's a hardware security module. That is a physical device in an Azure data center. It's a tamper-resistant cryptographic appliance. Now that can be used to handle cryptographic operations like generating certificates, storing encryption keys. It can even offload crypto operations from servers like encryption and decryption so they can use their processing cycles to do other things. However, for my purposes, I don't need HSM-backed keys, but sometimes for regulatory compliance, you might. So it's very important then to know the options and how they apply. So I'm going to leave it on standard. Down below for recovery options, when key vaults are deleted in the Azure cloud, we can determine that the vault will be retained for up to 90 days, which is what I have here. So that's fine. Next is the access policy. Who or what should be allowed into the key vault? Maybe I want to enable Azure disk encryption for virtual machines to be able to come in and get decryption keys. Down below, my current login account is listed here with all key permissions, that's encryption keys, secrets, things like database connection strings, and what we're here for, certificates. So getting certificates, listing certificates, updating them, creating them, importing them, deleting them. So I'm not going to change any of those settings. I'll click Next for networking. I'm going to leave this as a public endpoint, which means allow access from any network to the key vault. And I'm not going to add any tags, so I'll just go to Review and Create. And once the validation has succeeded, I'm going to go ahead and create this key vault by clicking Create in the bottom left. So now that the vault deployment is complete, I could click Go to Resource to open up its properties and work with PKI certificates. I could also click my little bell notification icon in the upper right to go to the resource that way. And after the fact, when I don't have any notifications anymore, I could always go to the All Resources view, where I could either type in part of the name to filter by it in the filter field here, or I could click Type and filter it by resource type here in the cloud. So I could say I only want to see key vaults by turning on that check mark, clicking Apply, and the list, of course, would then be filtered. Now, this is very helpful when you have hundreds or even thousands of cloud resources deployed. So I'm going to click to open up the key vault. What I want to do is I want to look at the options for importing and generating PKI certificates. So I'm just going to go ahead and close this navigator on the left. So I'm in the properties of my key vault. On the left, I'm going to scroll down to Certificates. Now, it's from here I have the option of importing or generating. Now, I can only import if I already have certificates. So I'm going to click the Generate Import button. Now, when I go ahead and click on that, from here, from the drop-down list, I can choose to generate or import. Now, I want to generate a certificate, so I'm going to call this Website 1. Maybe this is a certificate to enable HTTPS on a website. Now, it can be a self-signed certificate, or I could choose an integrated or a non-integrated CA, which I configure outside of here. So the common name, or the CN, will equal www, let's say, .website1.com. So we have to have registered that DNS name already with the DNS registrar. Normally, we'll specify the same DNS name, so www.website1.com, and I'll click OK. So then we specify the validity period. We know that PKI certificates have a limited lifetime, so they expire after a period. So we could specify that here in months. The default here is 12 months or 1 year. We could specify the certificate type. I'm going to leave that as it is. And essentially what I'm going to do now is go down and click Create. It's going to generate this self-signed PKI certificate. Now, because it's self-signed, that means that it will not be trusted by devices that have a trusted root certification store of public CAs. Notice at the top here, I can also click the Certificate Authorities button here, where I can add certificate authorities that I want to be used here to issue certificates. I can choose from the provider drop-down list, which includes DigiCert and global sign. But in this case, we've just got our own self-certified issued certificate. And there it is, website 1. We could click to open up that certificate to get some of the details like the thumbprint, the activation date, and the expiration date. I could then click directly on the certificate and also view the properties or choose to download it, a certificate format, or a PFX type of file format, which would include the private key. So if I'm not going to download it and use it outside of the cloud, in the Azure cloud environment, if I have a website and I want to enable HTTPS, I could select this certificate from within this vault. File hashing is used to determine if a change has occurred in a file. So we can generate a hash based on the current file contents, and that's a unique value. In the future, when we generate the hash of that same file again, if the file has been modified, the hash will be different. And then that way, we know the file has been modified. So let's take a look at how this happens. Here in my Windows Server 2019 environment, I'm going to fire up PowerShell, and I'm going to go to drive D, where I know I've got a budgets folder, and I know I've got a couple of files here. Now, the first thing I'm going to do here is generate a file hash, a unique hash for each of these files. So I can do that with get-file hash. I could specify a specific file name, but here I'll put star.star, every file with every extension in the current directory. When I do that, I can see the unique hash values. They're SHA-256 by default, and I can see that they are tied, of course, to the individual file names. Now, we're going to make a change, let's say, to the file budget1.txt. Now, we can see it's got a specific hash value, and we'll just keep that on screen. Now, if you're really going to be using this, you're going to want to perhaps redirect the output of the get-file hash command to a storage file somewhere, so you have a record of this, maybe using the output redirection symbol, the greater than sign. At any rate, here what I'm going to do is use Notepad, and I'm going to open up the budget1.txt file, and I'm going to make a change. There you go. And I'm going to close and save the file, of course. So now what I want to do is I actually want to run get-file hash, but only against, let's say, that single file. I only want to check the hash on budget1. So I'm going to go ahead and do that. Now, immediately we can see the previous hash of budget1 listed above is not the same as the current hash taken listed down below. And of course, that's because we changed the contents of the file. We know that a change has occurred. Now, to track details about changes, where the change was made from, who did it, and so on, we should enable file system auditing. But at this level, get-file hash in PowerShell will at least alert us to the fact that a change has occurred. Now, we can do the exact same type of thing here in the Linux environment. We might want to generate hashes of files or entire disk volumes or partitions. This might even be part of digital forensics to generate a hash for admissibility of evidence. We would only analyze a copy of the data. We would never make a change to the original data that might have been acquired as evidence at a scene. So there are many reasons why we would generate hashes. Let's see how we actually do this in the Linux environment. I'm going to do it for SHA-256. SHA stands for Secure Hashing Algorithm, SHA. So to get started here, let's go ahead and create a file. I'm going to call this testfile.txt. And what I want to do is immediately generate a hash of that file, even though there's nothing in it. The touch command simply creates a 0-byte file. So to do this, I'm going to run SHA-256sum, that's a built-in Linux command, and I'm going to run it against testfile.txt. Now here we see on the screen the unique hash value. Of course, you could write that out to a file, which I'm going to do. I'm going to use the up arrow key to bring up that previous command, and I'm going to use the append output redirection symbol, 2 greater than signs. And let's say we're going to create a file here called hashes.txt. Now, once that's done, I can use the cat command to view the contents of hashes.txt, and now it's stored in a file. We're not reliant on what's on the screen. So what I'm going to do now is make a change to testfile.txt. I'm going to echo hello world to the file. So I'll use the echo command, put my text in quotes, single greater than sign, output redirection, and I want that going into testfile.txt. We're going to cat testfile.txt. Now contains hello world. So the file's been changed. So let's use the up arrow key And let's go back to our SHA-256 sum command, where we are looking at generating a hash for testfile.txt. We're going to append the result to hashes.txt. Let's look at hashes.txt. Same file, different hashes, because the file has changed. And therein lies the purpose of generating hashes in file system objects. So we've seen how we can manually generate file system hashes in Windows as well as in Linux. There are also file integrity monitoring, or FIM, F-I-M, tools at the enterprise level where you can have it automatically configured to alert you or notify you when a change has been made to a sensitive file. So then you wouldn't have to manually go in and run these periodic hashes of files to see if anything has changed. Software RAID allows you to enhance the performance or the fault tolerance, the resiliency of a disk subsystem using software instead of a hardware RAID controller. So we can have multiple disks working together as one logical disk as it's seen by the operating system. So what we're going to do here is I'm going to configure software RAID in Windows Server, and what I want to do is take two disks and mirror them. That's RAID Level 1 disk mirroring. So this is a virtual machine running in VMware Workstation. So I'm going to go into my VM menu into the settings because currently I only have one hard disk. It's 60 gig. It's the one that Windows is running from. But I want to add two small hard disks that we'll use in a storage pool, which ultimately we will enable disk mirroring on. So I'm going to go ahead and click Add, and hard disk is selected. Okay, so I'll click Next. I'll accept the defaults until I get to the size. Maybe we'll just make a very small disk here just to expedite our example. So 5 gig, Next, and I'll continue with Finish. Let's do that again because we want to have 2 extra disks available here for disk mirroring RAID Level 1. Okay, so it looks good. Let's click OK. So we've got those disks added here to the virtual machine. So I'm going to go to the View menu here and choose Exclusive Mode so that we're really just working only within the Windows operating system. I'm going to go to the Start menu and right-click on Windows PowerShell and run it as administrator. Now, I don't have to use PowerShell to set up this disk subsystem stuff, but I want to. So I'm going to create a variable called $disks. Now, in PowerShell, variables need to be prefixed with the $. The goal here is I want to get a list of disks that are eligible to be added to a storage pool and have them stored in this variable. Now, a storage pool is the component, if you will, on which or upon which I will then create my mirrored disk configuration. So $disks equals, and in parentheses, get dash physical disk. Now, we know that these are VMware virtual machine hard disks that we've added. They're not real disks, but from the perspective of this OS, they're real, they're physical. And I'm going to pass it the can pool parameter with the value of true, close parentheses. So what I want to do is get a list of physical disks that can be pooled, and I want to store those in the $disks variable. And we can even check that out. I could just type $disks, and it returns that we've got 2 disks that were added. And indeed, that's true. Those are the 2 disks that we've just added those 5 gigs to VMware. Now I want to take that $disks variable, and basically I want to create a storage pool in Windows from those disks. So to do that, in PowerShell, I'll use the new -storage pool PowerShell commandlet with -friendly name, that's the parameter. And what I'm going to use for the friendly name, how about we call this pool SW RAID, software RAID. Then next parameter, -storage subsystem, friendly name. That's a long parameter name, but you spell it correctly. And in quotes, double quotes, I'm going to put in Windows storage asterisk. Now that's what we're referring to be used as the underlying storage subsystem for this. And then finally, -physical disks. We're going to pass it our $disks variable. So it should have created a storage pool based on those 2 disks. And so far, it looks good. Now, why don't we check our work here in Server Manager? So from the Start menu, I'm going to go ahead and click the Server Manager GUI to get that started. Once it initializes, over on the left, I'm going to have File and Storage Services, which is what I want to click on. And I'm interested in going to storage pools because I should see SW RAID, software RAID. Now, what I need to do is right-click on that software RAID pool, and I need to choose New Virtual Disk. Now, this isn't a virtual disk in the sense of a virtual machine. It's actually a logical disk within the operating system. Okay, that's fine. So I'm going to go ahead and create that. And I'll choose Next. And I'll call this vdisk1. Next. And I'll continue next again to the point where I get to the Select the Storage Layout screen. Now from here, if I were to choose Simple, what happens is data will be striped across the physical disks. So it's a RAID 0 striped array. So that can improve performance because you have multiple disks dealing with disk I/O, but there's no safety net in case a single disk or more than one disk fails. We could enable disk mirroring. We could enable parity. Parity is kind of like RAID 5, where you have at least 3 disks, and the data is striped across the disks, and you have distributed parity across the disks. It can tolerate one disk failure. If you've got 3 disks, protect against 2 disk failures, as it says here, use at least 7. Back to mirroring. I want to use mirroring because I basically want to make sure that we have a secondary copy, a hot online copy of any data that's written to the first underlying disk. So mirror it is. Next step, we'll use fixed provisioning type. It says the free space in this storage pool is 3 gig. So why don't we use that space up, 3 gig. And we'll go to next, and I'll click create. So there's a bit of overhead, which is why we don't have the entire 5 gig available. Now 5 gig because even though we have 2 disks totaling 10, if you're mirroring, you only have 50% of that available, 5 gig. So I'm going to go ahead and click close, and it starts this new disk volume wizard automatically. So I'll click next, and it's on my server, and it's vdisk1. That's great. I'm going to accept all of that, and I'm going to continue on to drive letter. It wants to use drive letter E. That's okay. It's going to format it as NTFS. Let's call this mirrored volume, at least at the volume label level, so that we know what we're looking at if we're in the file system. And I'll just continue with create. Okay, so before too long, it's going to be finished, so I'll click close. So what's interesting about this is if I go to disks over here towards the upper left, there's vdisk1, and if I select it, it's drive letter E, but interestingly, it's using the software RAID or SW RAID storage pool. All right, well, that's fine. Let's go take a look at it at the operating system level here in Windows Explorer. If I go into Windows Explorer, we've now got a mirrored volume, drive letter E, on which we could create or copy data. Make a sample file here called sample file. Let's say there it is. And unbeknownst to us, we have 2 copies of that stored on each of the 2 underlying disks, although it only shows up here once in the operating system, which is exactly what it's supposed to do. The idea is that if we have a single disk failure, we're okay because it's mirrored. We still have another disk that has the same information on it. Now, this is software RAID. So if there's a software corruption problem of some kind related to this configuration, that could prove problematic. Whereas hardware RAID does this at basically the hardware circuit board level. You would configure it at that level to do the same type of thing, and it's more resilient and robust than doing it within the operating system as software. In this demonstration, I'm going to be enabling software RAID in Ubuntu Linux. Now remember that software RAID is not preferred as hardware RAID is because hardware RAID uses a circuit board designed to do that, to work with multiple disks and have them work together. So it's considered more resilient and more stable and robust than software RAID. However, software RAID would be the next best thing to use to increase disk performance or data availability on disks in the absence of a hardware RAID controller. So the first thing I'll do here in Ubuntu Linux is I'm going to run the sudo. Now I'm using the sudo prefix because I am not logged in as root. If I type who am I, it reports I'm simply logged in as a user called U1. So a lot of the commands I'll be issuing require elevated privileges. So sudo LSBLK, I want to list block devices, specifically SCSI block devices. So the first time I run sudo, it'll ask for my password, the password for user 1. So as a result, I have SDA, SDB, and SDC. SDA is where the Ubuntu Linux OS is installed and running from, but disks B and C I will be using for software RAID. And so what I want to do then is I want to partition them accordingly. I want to set up disk mirroring. So RAID level 1. So what I'm going to do is run sudo fdisk, and I'll start with /dev/sdb, and I'll press enter. I will press the letter N for new. This means new partition. And I'm going to press enter to accept the default of a primary partition, partition number, and the first sector, last sector. I'm just pressing enter to accept all of those defaults. Now, what I need to do, though, is I need to change the partition type, and I'll do that by pressing the letter T, and it wants me to enter the hex code for the type. I could press a capital or type in a capital letter L and press enter to get all of the codes for the partition types. Well, what I want to do is I'm going to specify FD, which sets it to a Linux RAID auto detect type. Okay, that's perfect. So now I'm going to press W to write that out to disk. Now I'm going to do the exact same thing again, but on the third disk that we saw listed there. So let's just clear the screen just to make this nice and neat. Okay, so I'm going to run sudo fdisk once again, except this time /dev/sdc. The first time we did this against SDB. So I'll press enter. It's going to be a new partition, and I'll accept all of the defaults. Except remember, what we did last time is we pressed T to change the type to FD, which is the Linux RAID auto detect. And recall, we pressed the letter W to write the changes to disk. Okay, so now that we've done that for those two disks, let's just check our work. I'm going to run sudo fdisk, and I'm going to specify -l/dev/sdb/dev/sdc. I want to list my partition information on both of those disk devices. So what I'm looking for here is I want to look underneath the type heading here to make sure that Linux RAID auto detect is set. So we've got a partition which is numbered as 1, so SDB1, partition 1 on device SDB. And we have the same type of thing down here for our third disk, SDC. We have a partition, and the type has been set to Linux RAID auto detect because that's what we told it to do. So now that we've got that done, and it looks good so far, let's create a RAID 1 mirror array, a configuration. To do that, I'm going to run sudo, and I'm going to use the mdadm command, --create /dev/md1. I'm creating a mirror device, so md1 --level, so RAID level is equal to 1, because RAID 1, remember, is disk mirroring. Then I have to specify --raid-devices, and there are 2 of them. I'm using 2 of my disks. And specifically, I'll point to /dev/sdb1. And remember, the second one was /dev/sdc1. We just reviewed that with the fdisk-l or list command. So I'm going to press enter, and it says, should we continue creating this array? Well, of course, we do want to do that, so I'll type in the letter Y, and I'll press enter. So we can check our work. I'll just clear the screen with the clear command. We can check our work with the sudo mdadm command, --detail, and we're going to ask for detail on our /dev/md1 mirror device. So at this point, it looks like it's in the midst of resyncing, so it's 22% complete. And down at the bottom right, we have the 2 devices that are being mirrored together. /dev/sdb1, that partition is being mirrored with the SDC partition on the SDC device. So the next thing we would do is create a usable file system on the mirrored disk array. And I can do that with sudo makefs or mkfs for make file system, -t for type, let's say ext4 is the file system type, and then I'll tell it on /dev/md1. So we've just created a file system. We formatted essentially our mirrored partition. Next thing we would normally do in Linux is make a mount point. So it's kind of like making a drive letter in Windows that points to a disk. So in this case, we're making a mount point. So I'm going to run make dir, and on the root, maybe we'll call it customer transactions, cust_trans. And now what I'll do is mount the file system into that mount point cust trans. So sudo mount /dev/md1 is how we refer to our mirrored device /cust_trans. So now when we change directory to the root and go into the cust trans folder, what we're really doing is working within that mirrored disk device. And so we would copy files, create files, do whatever it is that we need to do in this mount point directory. And it's really being written to our mirrored disk array. Now we can verify that this is mounted correctly by running the mount command and piping it to the grep line filter command and saying show me lines that have /dev/md1. And indeed, it returns back that is available on /cust_trans. Okay, so we know that DNS is a name resolution service that's normally used for forward lookups. So we have a fully qualified domain name like www.google.com, and we need that to be resolved to an IP address for that site in order for us to connect. But we can secure DNS in a number of ways, one of which is using DNS over HTTPS, otherwise called DOH. So instead of clients sending DNS requests to DNS servers in clear text, instead it would encrypt it and send it over HTTPS using the standard HTTPS port 443. However, we can also enable DNSSEC or DNS security. So here in Windows Server, what I'm going to do is digitally sign a DNS zone and configure group policy so clients partake in DNSSEC for that DNS zone. So to get started, why don't we go to the Start menu here in Windows Server, and why don't we take a look at DNS? So under the Windows Administrative Tools, I've already installed DNS because this server happens to be an Active Directory domain controller, which by default means it's also a DNS server. So I'm going to click DNS to open up the DNS tool. Next thing is I'll make sure I've drilled down under my DNS server in the left-hand navigator, and I'm going to drill down now under forward lookup zones, and I'm going to choose my DNS zone, which maps to the same name as my Active Directory domain. It's called domain1.local. And currently what we have over on the right are the standard Microsoft DNS domain items, like _TCP for discovery of things like domain controllers, for authentication using Kerberos. And also I have a couple of records like the Start of Authority record, which defines some details about this DNS zone, the name server record, and in this case, a couple of host A records, which map to the IPv4 address. But what I want to do is digitally sign everything in this DNS zone. So I'm going to right-click on domain1.local on the left, and I'm going to choose DNSSEC, and I'll choose Sign the Zone. I'll choose Next again, and we could use default settings for the zone, but I'm going to leave it on Customize Zone Signing Parameters. That's the default, so we can see the options available. Then I'll click Next. The current server that we are at, server 1, is going to be the key master. This is the host that can generate keys that are used for digitally signing DNS zones. So I'll click Next, and from here I need to configure a key signing key or a KSK. So I'll click Add. I could generate new keys or import existing ones. I want to generate new keys. And here I can specify things such as the signing algorithm that will be used to create digital signatures. Here it's set to RSA SHA-256. I'll leave it on that. I'm not going to make any other changes, so I'll just go ahead and click OK and click Next again and Next yet again. Then I need the zone signing key, so I'll click Add for it. And here, once again, I can choose the hashing algorithm that will be used. In this case, I'll just, once again, leave it on SHA-256. And then I'll click OK. I'll click Next again. And I'll leave the default for Next Secure version 3, DNS resource records. I'll click Next again. I'll leave the default for enabling automatic update when we roll over keys. And then we get to the signing and polling parameters part of the wizard. Again, I'm going to accept all of the defaults for that, not going to change anything. And I'll continue with signing the zone. Then once I click finish, and I'll have to click refresh since I was already looking at the zone, notice that what happens is I get a lot of these RR signature, resource record signature, DNS records, some DNS key records. So there's a lot of stuff that gets added to the zone. Of course, we have our standard DNS zone resource records that we began with as well. So the next thing I want to do then is make sure that I configure group policy for machines joined to this domain so that machines know to use DNSSEC when they query anything in the domain1.local DNS zone. So I'm going to open up my start menu once again. I'm going to go to Windows Administrative Tools. And this time, what I want to start down under the G's is the Group Policy Management tool. I'm going to right-click on my default domain policy and choose Edit. Over on the left, under Computer Configuration, I'll expand Policies and then Windows Settings, and I'm going to click Name Resolution Policy. The first thing I have to do is specify to which part of the DNS namespace this rule will apply. I would like it to apply to anything that has a suffix of domain1.local when it comes to client DNS queries. Down below, I want to enable DNSSEC. I want to require DNS clients to check that the returned DNS response has been validated using a public key, since signatures are created using a private key. I can even enable IPsec to be used when communicating on the LAN between the DNS client and the DNS server. And I can choose some type of encryption algorithms like triple DES, but I'm going to go up and choose the highest AES 192,256, the Advanced Encryption Standard. After which I'll click Create. So what that will have done, if I scroll down, is it's added my name resolution policy down here. And I can add multiple policies, perhaps with different settings for different DNS domain suffixes, that type of thing. And then I can close out of that group policy editor. And at this point, it's just a matter of waiting for group policy to update throughout the entire Active Directory domain before DNSSEC is used for domain1.local. There are many different types of firewall implementations, and they're all important in restricting the flow of traffic to where it should be going. So here in Microsoft Azure, I'm going to be configuring the Azure Firewall. Now, we've already seen an example of working with this to control outbound traffic, for example, to social media sites. But in this case, I just want to use it as a standard packet filtering type of firewall. So the first thing that we have to do is take a look at our existing virtual network configuration in our cloud environment. So I'm going to go to the upper left and open up my navigator and scroll all the way down to virtual networks. So in my cloud environment, I have one virtual network. I'll just click refresh here to make sure it's up to date. It's called VNet 1. And if I click and open up that VNet, it's got a single subnet within it. The subnet's called Subnet 1. So we would have resources like virtual machines deployed into Subnet 1. And what we want to make sure is that we are protecting those resources like virtual machines and only allowing the appropriate traffic in, such as perhaps HTTPS, if we're hosting a web server on one of those VMs, maybe allow inbound SSH for remote Linux management, inbound RDP for remote Windows management, whatever the case is. Okay, so now that we know what we're working with, let's go back home here and let's choose Create a Resource, and I'm going to type in Firewall. And then from the list, I'll click Firewall, and then I'll click Create. The Azure Firewall lets us work with standard packet filtering rules. They're called network rules. Things like we want to base traffic allowance or denials based on source or destination IPs, or protocol like TCP, UDP, port numbers, that type of thing. Of course, the Azure Firewall can also allow inbound network address translation if you want to configure that kind of mapping, and it also allows you to control outbound traffic destined for certain DNS domain names. So here, I'm going to deploy this Azure Firewall into an existing resource group, and I'm going to call it FW1 East, Firewall 1 East. And of course, I'm going to deploy that in a region such as Canada East. And as we scroll further down below, I can either select an existing firewall policy if I have any, or I can choose to add a new one. So I'm going to go ahead and add a new one since this is the first time I'm creating a firewall configuration in the Azure environment. I'm going to call this Policy 1, and it's going to be created in the Canada East region. That's just the policy object. So the next thing is we can either tie this to an existing virtual network where we would have had to create a subnet to accommodate our firewall. However, I'm going to tell it to create a new virtual network that will house only the firewall, and I'm going to call it FW VNet for Firewall VNet. For the address space, maybe I'll use 11.0.0.0/16, and it's going to create a subnet called Azure Firewall Subnet, all one word. If I was using an existing VNet, I would have to make sure I had a subnet of that name created. So the subnet address space, how about I use 11.0.1.0/24? And we're going to need to either select an existing public IP address resource that we might have previously created that's unused. We don't have any, or we'll have to add a new one. I'm going to call this Firewall 1 East and then pub IP, and I'll click OK. So your Azure Firewall needs a public IP address because it's public facing out to the internet, but it will also automatically be allocated a private IP address for the IP address range for the subnet it is being deployed into. So in our case, it's going to have an IP that starts with 11.0.1. Okay, so I'm going to go ahead and click Review and Create. It'll check that my settings make sense and that they're valid. The validation has passed, so I'm going to click Create to deploy the Azure Firewall. Okay, so after a moment, the deployment is complete. I'll just click Go to Resource. That's going to take us into the properties of our firewall, which is called FW1 East, and in the overview page, I have a private IP address of 11.0.1.4. So that's good. It picked it up from our firewall subnet as per our configuration. And if I go to the public IP configuration, we'll be able to get the details related to the public IP for that interface on our firewall appliance. Now, we've deployed the firewall, but it's not configured and it's not associated with anything, so it's not effective for anyone. So I'm going to go ahead and click Firewall Manager over on the left, and I'll click the link at the top to manage the Firewall Manager. And the first thing I should do here is associate it with a virtual network. Now, what I have here is a list of all my VNets or all my virtual networks in the cloud here in Azure. And I've got my Firewall VNet with Policy 1 as we created. However, VNet 1 is shown here all by itself and it says no firewall deployed. Well, what we're going to do is either deploy a firewall into VNet 1, so we have to have the Azure Firewall subnet in it. I don't want to do that though. I already have a specific subnet just for the firewall. So instead, what I can do is peer those two VNets together. That sounds like a good idea. Why don't I duplicate this current web browser tab? I want to keep my position there, but I want to open up another window here so I can go and peer those VNets together. So for that, I'm going to open up my navigator on the left and go all the way down to virtual networks. Remember that when you peer VNets together, you have a direct link between them so that you can communicate using private IP addresses, even with resources in the target destination peered VNet. So what I'm going to do is select one of my VNets, doesn't matter which one, and in the properties bar on the left, I'm going to scroll down to peerings because I want to create the peer link, I guess we could say. So I'll click Add, and it wants the peering link name. So this is VNet 1, so VNet 1 to FW to Firewall. And I'll accept all the defaults, and it wants a peering link name in the opposite direction. It's going to create two peering link connections. So I'm going to call this FW to VNet 1. And again, I'll accept the defaults, and I will just choose the target VNet I want to link VNet 1 with. I want to link it with my Firewall VNet. Okay, let's add the peering connection. Okay, so our peering status shows us connected. We're good in that department. So back in our Firewall Manager screen, I'm going to click the refresh button at the top. Now, previously, VNet 1 had no firewall deployed, but now it says peered to a virtual network with the firewall. That's right, that's what we've just done. So that part is good. Next thing I have to do is go to Azure Firewall Policies. When I think of a firewall, I think about allowing or denying something, but we haven't done anything like that yet. Well, that's where we go into our policy. So we created policy 1 initially. Click on that link. We can create DNAT rules. So that allows us to map a public IP address of the firewall and a port number to a private IP address and port number for an internal host, maybe to allow remote management. Network rules, which we're going to look at, which is like packet filtering rules to allow or deny certain types of traffic. And of course, application rules to control outbound traffic flow to specific DNS names, either allowed or denied. So I'm going to go to Network Rules, and I'm going to click Add a Rule Collection. I'm going to call this Call 1 for Collection 1. It's a network rule collection, and I can give this collection a numeric priority value. So a rule collection with a priority of 100 gets checked before a rule with a priority of 101. I can either allow or deny, so I want to allow. And in this case, I'll start, let's say, with RDP. So I can specify a source IP address, for example. I could specify any IP. The protocol here would be TCP, let's say. The destination port would be 3389. And I could specify if I want to allow that to a particular backend host, but I'll just put in an asterisk for now, so any host. We could do the same type of thing to allow SSH. So I can basically repeat what I've done above, other than changing the port number to 22, which is used by Secure Shell or SSH. So the point is that we configure the firewall rules within the collection accordingly. Now, once I've done that, I can go ahead and click Add. So I've added the rule collection. Now, all of the rules that are added to that collection are going to be either allowed or denied. We can see that if we scroll all over to the right. So if I wanted to, I could select my rule collection and choose Edit. And from here, we would have the option of making a change to some of those existing items. Or, of course, we could also click Add a Rule. But when you add it to a rule collection group, so a rule collection like Call 1, notice that you don't get the chance to say whether it's allowed or denied, because in this case, it's set to allow. So if you need to create a rule that was denied, you'd have to add a new rule collection and then a rule within it. Now, we've got that part done. Next thing I want to do is go back to our firewalls overview page because I want to copy the private IP address, because we need to create a route so that, for instance, virtual machines and certain subnets know that they have a route to get to the firewall. So to do that, I'm going to go home, I'm going to create a resource, and it's going to be a route table type of resource. So I'll go ahead and click on that, and then I'll click on Create, and I'll deploy this route table object into my existing resource group. I'll put this, say, in Canada East, and I will call this RT1 for route table 1. I'll click Review and Create, and then I'll click Create. Once that's done, I'll click Go to Resource because we have to create a routing table entry within the route table. So I'm going to click Routes on the left. I'll click the Add button to add a route. This is going to be called to Firewall, and it's going to be the default route, so 0.0.0/0. And I want that to be redirected to our virtual firewall appliance private IP, which I will paste in that field, and I'll click OK. Last thing I'll do here is go to subnets to associate this route table with the appropriate subnets that should partake in using this firewall. So that's going to mean I'm going to go and select VNet 1, within which I will then choose subnet 1, and then I'll choose OK. So that's how we can deploy the Azure firewall and have it applied to a particular subnet. While it's important to employ perimeter firewalls, it's equally as important to make sure that we have firewalls running on each individual host and that they're configured accordingly. Ideally, everything's blocked except for exceptions that we've added to allow traffic into or out of the host. So here on my Windows server, I'm going to configure firewall settings using Windows Defender. So to get started, I'm going to go ahead and open my Start menu, and I'm going to go into the Control panel. There are a bunch of ways that we can start Defender, but this is one of them, and I can go into System and Security and Windows Defender Firewall. Currently, this machine is not joined to an Active Directory domain, so we don't have the third category or network type of domain, but we do have private networks, and we have guest or public networks, which we are configured as being connected to. When we build firewall rules, we can determine if they are effective or active for private networks, public networks, or domain networks. So the green here indicates that the firewall is on for those networks. Of course, that's also implied by the green shield with the check mark in it, the white check mark. So if I click Change Notification Settings, I can block all incoming connections, regardless of what might be listed as being allowed. And again, we can do that per network location. I'm just going to go back here, and I'm going to click on the Advanced Settings over on the left. Now, what this is going to let me do is go into the detailed inbound and outbound firewall rules for this host. So if I click Inbound Rules on the left, I have a list of inbound rules. The ones that have a green circle with a white check mark are enabled. And also under the enabled column, it reflects that by saying yes versus no. You can right-click on any of these firewall rules and, for example, temporarily disable it, perhaps for testing purposes, that type of thing. So we have inbound rules. We've got outbound rules for traffic leaving this machine. We've got connectivity security rules. This is really where we would configure IPsec. We can manage inbound rules, outbound rules, connection security rules for this machine here, but if any have been configured, let's say centrally through group policy and pushed down to this machine, the configurations will also show up in the same respective place, inbound rule, outbound rule, or connection security rule. Over on the far right, I can filter, for example, by state, maybe only filtering by enabled. I don't want to see disabled rules. I'm going to open up the command prompt on this server and type ipconfig, where we have a listing for our current IP address, which is 192.168.4.117. I'm going to switch over to another station on the network to see if I can ping that IP address. Okay, so I'm going to go ahead and ping 192.168.4.117, and currently we're not getting a reply. So what we're going to do is go back to our server, and in the Windows Defender Firewall, we're going to configure a rule that allows inbound ICMP echo requests, so ping packets, specifically from this host. So what that means is I'll press Control-C to cancel the ping, and I'm going to type ipconfig because we're going to need to know the IP address of this host to do that. So to allow traffic for ping purposes only from this machine, I've got to make sure I configure my firewall rule to allow only that type of request from 192.168.4.24. Okay, so let's go back to the server. Let's make this happen. Back here in Windows Defender Firewall with Advanced Security, I'm going to right-click Inbound Rules on the left and choose New Rule. This is going to be a custom rule, so I'm going to go ahead and choose Next. It applies to all programs. It could specify to just a specific program. And the protocol here is set to any. Well, we don't want that. I only want to allow ICMP, specifically ICMP version 4 for IP version 4. Down below, I'm going to click the Customize button because all I really want to allow is echo requests. So that's what happens when we ping a host. We are sending an echo request, and it's sending back an echo reply. So I'm going to go ahead and click OK and Next. Down below where it says which remote IP addresses does this rule apply to, I'm going to click these IP addresses. I'll click Add, and I'll specify 192.168.4.24. That was the other station on the network where we want to allow pings from. So I'll click OK. Next, I want to allow the connection. Allowing the connection, if it's secure, can be used so that we have a secure connection via IPsec. But I don't require that for ping. And I can also choose to block the connection. Well, we don't want to block ping. We want to allow it. It's currently not working already. So I'm going to go ahead and click Next. It's going to apply to all 3 network locations. I'm going to call this Allow Inbound Ping from Admin Station. And then I'm going to go ahead and click Finish. So now in our inbound rules, we have an Allow Inbound Ping from Admin Station rule, and it's currently enabled. Why don't we go back to our station out on the network, try pinging this server again, and see if ping is working. Okay, so back here on my other station on the network, I'm going to ping the server IP again, and this time we're getting a reply because we have a specific rule applied to this machine's IP. Now, IP addresses are easily changed. However, it's still another level of security that we can add for some types of configurations, such as which stations to allow ping from, as we've done here. Now, if you're not using group policy, if this machine's not part of an Active Directory domain, Yet you want the same type of firewall rules applied to other hosts on the network. What you could do is right-click on Windows Defender Firewall with Advanced Security in the upper left. You could choose to export the policy from this machine, and then on other hosts that have the same types of firewall needs, you could import the policy. Now, we could also go to the Start menu, say, and jump into PowerShell, where we could use the netsh advanced firewall command set, so /?, so we can get the help screen. Now, this is not a PowerShell commandlet, it's just a regular standard Windows command. So knowing how to do this at the command line can be useful if you want to write scripts that you could run more than once. In the same way, if I were to run get-command, which is a PowerShell commandlet, I can use asterisks and tell it that I'm looking for net firewall type of commandlets, of which we have plenty, such as new-net firewall rule to build a new Windows Defender firewall rule. We could also use the get-help commandlet with the name of the commandlet we want to get help about and -detail. From here, I'm going to choose no, because I don't want to update the help system. And after a moment, it has provided us some details about some of the parameters that can be used with this particular commandlet, the new-net firewall rule PowerShell commandlet. In this demonstration, I'll be configuring VPN client connectivity to the Microsoft Azure cloud. Now in Azure, I've already configured the VPN appliance side of things via a virtual private gateway type of configuration. So here, we're going to make sure we can get the client connected through PKI certificate authentication. Now, one way to do that is to generate your own self-signed root certificate, which we're going to do through PowerShell. And then after you've done that, you can then issue a client certificate from your self-signed root certificate. So I'm choosing to do this in PowerShell. There are many other tools that you could use to do this. You don't have to use a self-signed certificate. You could use a public certificate from a public provider if you really wanted to. So let's take a look at a little bit of the PowerShell. In PowerShell, when you have a hashtag symbol or a pound sign, it means you have a commented line. And that shows up here on premises on my computer in the PowerShell ISE. That shows up as green text, any comments. So what I'm doing in line 3 is creating a $cert variable, and in PowerShell I'm using new-self-signed certificate to create a new self-signed root certificate. Now there are many different parameters such as the hashing algorithm. Here I'm specifying SHA-256, the key length, specifying 2048 bits, and the certificate store location in the PowerShell certificate drive. So that's fine, that'll take care of that. Now, in my script here, I have some commands where we could change directory to the cert drive, and we could view the certificate there by typing dir, but we'll just do that manually, so I'm going to delete that from the script. Now, starting in line 10, we are creating a client certificate using the new-self-signed certificate commandlet. That's the same commandlet that was used up above. What's different is how we are going to use it. So it is a custom certificate. The DNS name here is going to be client cert. And as we go further down, I'm going to specify the same hashing algorithm, so SHA-256, and we have the -signer parameter, and this is key because this is where I'm passing it, our $cert variable, from up above for our trusted root. So we are generating then our client certificate, and it's going to be called client cert. The root cert up above is going to have a common name or a CN of root cert. So let's go ahead and run this script. I'm going to go ahead and click the Run Script button up at the top, and it should happen very, very quickly. Now in PowerShell, notice that we can change directory to our cert drive, and I've gone into current user, my. This is one way to check your certificate store. Here I see the client and the root cert. Of course, we can also do it in the GUI through MMC, the Microsoft Management Console. I'm going to start up my Start menu, and I'm going to type MMC and press Enter. So here in MMC, I'm going to go to File, Add, Remove, Snap In. I'm interested in managing certificates, so I'll select that and click Add for my user account. So Finish and OK. And down in the left navigator, I want to drill down under Certificates, Personal Certificates, where we'll see we have both the client cert and the root cert. Now, if this is the same computer that you're going to use as the VPN client, you already have the client cert installed. Usually, this is your administrative workstation. And so what you'll do then normally is right-click on the client cert and go to All Tasks, Export, and you'll export this certificate with the private key, and you'll have to specify a password and confirm it. And then you're going to have to double-click on that file on a target station to import the client cert, but we already have it here. We also have the root cert as well, but what I want to do here is I want to actually right-click on it, go to All Tasks, Export, and I'm going to go through this. I don't want to export the private key here. I need the root certificate public key when I configure this further in the Azure portal once the virtual network gateway is deployed. So let's go through and specify a file name where we're going to store this. I'm going to put it on the root of drive D. It's going to be called root cert _ pub key, and then I'll just go ahead and accept the defaults to go through that to the point where it says the export was successful. Now I need to extract the root certificate public key so I can configure the virtual network gateway in Azure once it's been deployed. So I'm going to right-click on root cert, choose All Tasks, Export, and I want to make sure I export only the public key. I don't need to export the private key. And I'm going to make it a base64 encoded file, and I'm going to specify the file name where I want this stored. So I'll call it root cert pub key, and I'll just continue through the rest of the wizard. So if I open up that exported public key file with the text editor, here I've used WordPad, this is what I'm going to see. There's a begin certificate section and an end certificate section. So what I need to do is copy everything in between those two directives because I'm going to need it to configure the virtual network gateway in Azure shortly. Okay, so what I need to do here in the portal is get into the virtual network gateway. I'm going to go to All Resources, and I'm going to filter by name here for VPN. And here we've got our VPN Azure One virtual network gateway that I've deployed previously. I'm going to click on it to open it up. Now I want to configure a point-to-site VPN to allow an individual client device to establish a VPN tunnel. You're not limited to one, but in this example, we're only going to look at having one client connected. So I'm going to click Point-to-Site Configuration on the left, and I'll click Configure Now on the right. I need to assign an IP address pool or a range of IPs to assign to incoming VPN clients, and I have to make sure it doesn't overlap with any IP address ranges being used by any of my VNets. So I'll just put in 192.168.0.0/24, and for the tunnel type, I'm going to choose IKV2 and SSTP SSL, depending on what your requirements are. And for the name of the root certificate, I'll call it root cert, and we've copied the public key, which I'm going to paste in the public certificate data field. Then I'll click the Save button up at the top. Okay, after that's done, I can then download the VPN client, which is a zip file, and it's based on the current configuration of my virtual network gateway. So if I reconfigure it in some way, I should download the VPN client again and get that distributed on my individual client devices. So I'm going to go ahead and download that client. So once I've got the zip downloaded, I'm just going to go ahead and right-click and extract it. So I'm going to right-click on it, and I'm going to choose Run as Administrator, and then I'll choose Yes. And when I'm asked if I want to install the VPN client for my VNet, VNet 2, I'll choose Yes. So here in Windows 10, which is what I'm running as my VPN client station, if I go into my Windows settings, then I can go to Network and Internet, I can go to VPN on the left, and then we'll have VNet 2, so I can click on that, and I can make a connection by clicking Connect once again. So I'm going to go ahead and accept the defaults to make a connection to our VPN, and we now see that VNet 2 is connected. From a command prompt on that same machine, if I run ipconfig and then take a look at all my network interfaces and the assigned IPs, I'll have a point-to-point protocol or PPP adapter for VNet 2, and I will have been assigned an IP address in the range that we specified in our virtual network gateway. So we've successfully authenticated to our point-to-site VPN in Azure. When you deploy virtual machines into the cloud, ideally, you will not make them exposed publicly via a public IP address, only because there are known attacks, for instance, against RDP. And so instead, ideally, those virtual machines would have only private IP addresses, and we would go through a jump box host to then gain access to remotely manage those hosts with only private IPs. In Azure, that jump box solution is called Azure Bastion. So to get started here in the portal, I'm going to click Create a Resource, and I'm going to search for Bastion, and I'll select it from the list, and then I'll click Create. I will define the resource group into which I want this deployed. I'm going to call it Bastion 1, and I'm going to put this, let's say, in the Canada Central region, since that's where most of my resources are deployed already. Then I'm going to choose from the virtual network list. I'll choose VNet 1. Now it says if you want to associate a virtual network with Bastion, it must have a subnet named Azure Bastion subnet with the prefix of at least /27. Now I don't have that available already in the drop-down list for VNet 1, but I do have a link here labeled Manage Subnet Configuration, which I'm going to click. So it takes me directly into the subnets blade for VNet 1. So I'm going to go ahead and click the Add Subnet button up at the top, and I'm going to call it Azure Bastion Subnet. And I need to specify an address range CIDR block that uses /27 as the prefix for network addressing. So I'm just going to change the /24 to /27. I'm using 10.0.4.0. Now, we have the ability to view all of our existing subnet address ranges in the background to make sure we're not overlapping with it, which I'm not. So I'm going to go ahead and click OK at the bottom to define this Azure Bastion subnet, at which point we've got the prerequisite configured. So I'm going to go ahead and click the X to close out of this subnet screen. And when I go back to where we were in the midst of creating the Bastion host, I then have the subnet dropdown list already populated with what we've just created. How convenient. So down below, we need to have a public IP address for the Bastion host. Remember, it needs to allow that kind of connectivity, but by extension, each individual VM does not need a public IP address. I'm going to call this Bastion Pub IP. Perfect. Then I'm going to click Next Tags at the bottom. I'm not going to add any tags, so I'll click Next, Review, and Create. The validation has passed, so to deploy this, I will click Create in the bottom left. After a moment, the deployment will be complete, so I'm going to click Go to Resource just to check it out. So it is a separate Azure resource. It is an Azure Bastion host used to allow remote management without exposing individual VM public IP addresses to the internet. Now we can click on Sessions in the navigation bar to see if any sessions are active currently through the Azure Bastion host, but it's returned no results. The way that you use Bastion is you click on a virtual machine in the portal that you want to remotely manage. Then when you click Connect, either in the Overview blade at the top, there's a button, or when you go to the Connect blade in the left-hand navigator, either way, you can select Bastion. When you choose that, it's going to request information about the Bastion host that's available, and after it's confirmed that there is one available, all you have to do is specify, in this case, the Windows credentials because it's a Windows VM. Once I've done that, I just click the Connect button down at the bottom to initiate the connection. That's going to open a new web browser tab, and it's going to allow me to remotely manage that Windows VM. It could be Linux, but in this case, it's Windows, directly through my web browser interface. I've got an active start menu, and everything works nice and quick. Fooling victims into clicking links or downloading and running file attachments is one way that we can use social engineering to trick people into infecting their machines with malware. And one form of that type of malware might be to set up a reverse shell. A reverse shell allows a victim machine, perhaps that's been infected with malware, to make an outbound connection to the attacker station. So it defeats most firewalls in that sense, because often a firewall won't let connections initiated from the outside. That's why reverse shells are popular in the malicious user world. So to get started here in Kali Linux, I'm going to run the Netcat command line tool. That's NC. And I'm going to use the -LVP parameter set. Now, L means listening port, which I'll specify in a moment. V is verbose, and P, of course, is port. So I'm going to go ahead and specify a port number, let's say, of 81. What this means is I am listening on my attacker station. It says on any IP address, I didn't specify an interface, on port 81. What am I listening for? I am waiting for infected machines to come back and talk to me. So how would a machine be infected? Well, there are innumerable ways that that can happen. what we're going to do is switch over to a Windows 10 station. Here in Windows 10, I've gone to a website where I can download Netcat for Windows. Now, realistically, an attacker would find a way to trick a user into clicking on something that would install this on their machine. But here, we're going to willingly download and install Netcat on Windows 10. So I'm going through the steps manually. An attacker would automate this and have it run in the background, unknown to the victim. So here, I'm going to type a dir. I'm in the directory where I've installed Netcat, and I can see, for example, the nc.exe here in Windows 10, Netcat. So I'm going to clear the screen with CLS, and I'm going to type nc, and then the IP address of the Kali Linux station that is currently waiting for connections on port 81. So I'm going to put in a space, port 81, and what I want to execute -e is command.exe. Now, of course, I'm typing this in willingly and manually. Again, an attacker would normally do this in stealth mode. This would be automated in a script or embedded within an executable that the user is tricked into running. All right, I'm going to press enter, and now we're going to flip back to Kali Linux. Okay, so now we have a message saying the system can't execute the specified program. Usually that's because your antivirus is picking it up as malware and will not let it run. So let's deal with that situation. So here in my virus and threat protection options in Windows 10, I'm just going to go down and click Manage Settings under Virus and Threat Protection Settings, and I'm going to turn off real-time protection. And I'll choose yes. Now, of course, you would normally never do this, but for this demonstration, I am going to do that. Again, a malicious user could trick a user into doing something similar, but of course, Netcat is an old tool. Often developers will build newer tools, malicious developers, newer exploits that aren't so easily detected. Now, if I take a look at the threat history on this host, notice that we've got a quarantined threat. It's the Netcat hack tool. Okay. Well, I'm going to choose Restore because we are in testing mode. We know it's a malicious tool, at least normally it's used for malicious purposes, but we're going to restore it back so we can run the command again. Back here in the command prompt, if I run dir, I can see that nc.exe is back. So I'm going to use the up arrow key so that we can run our command once again. This time, it runs. Let's go back and check Linux now that we've gotten around the anti-malware real-time protection. And this is what I see in Kali Linux. I've got a command prompt session with that remote host. So I can do anything I want here. It looks like I'm in Windows. I'm not. I'm in Kali Linux. So I can start to take a look at the file system on that machine. So if I go to drive C and do a dir, I can see everything on drive C. If I go into a specific folder to get something or to look around, I can also see what's there. I have fully privileged command line access based on whoever is logged into that Windows host. That is, of course, I have their level of privilege. The point is, this is pretty darned easy to do. So it really does highlight the importance of having up-to-date anti-malware tools. Some people are of the opinion that you don't really need anti-malware solutions since a lot of the newer exploits won't even get detected anyways. Nothing could be further from the truth, as evidenced in this example. In Microsoft Azure, in the public cloud, we can configure conditional access. In other words, a number of conditions must be satisfied before allowing users to make a connection to Azure or cloud-based apps by authenticating through Azure. So conditional access then is known as rule-based access control. Now, there are a couple of things that we should consider here, the first of which is that we can also enable multi-factor authentication, or MFA. So here in the Azure portal, in the left, I'm going to open my navigator and drill all the way down to Azure Active Directory. To enable MFA for Azure AD users, we first have to go to the users view on the left. I've got an existing user that was created by clicking New User up at the top. That user is named User1. Now, to enable MFA for users, what we do is we click the multi-factor authentication button towards the upper right. That's going to open a new web browser window where I have a list of all my Azure Active Directory or AD users, and I have a column that shows me the status of MFA, which is currently showing disabled for all users. I'm going to put a check mark for user 1, and then over on the far right, I'm going to choose Enable to enable MFA. I will click the Enable Multi-Factor Authentication and close. So currently it's enabled. So the next time user 1 signs in, they're going to have to provide some more sign-in information for future logins, which will require multi-factor authentication. So I'm going to go ahead and close that window. Now let's go back to our default directory in the breadcrumb trail here. We're looking at the properties of Azure AD, Azure Active Directory. What I want to do is I want to make sure that we enable conditional access. Now the first thing I have to do here is scroll down, and on the left I need to click Properties. And then on the right, I'll scroll down to the bottom and click Manage Security Defaults, and I'm going to turn off Security Defaults because I'm going to select my organization is using conditional access, and I'll click Save. Now to configure conditional access, we would click on Security on the left, and from here I have conditional access policies that I can work with. Before we do that though, I'm going to create a configured named location. A named location can be referenced within a conditional access policy, so it can be one of the conditions that must be satisfied. The user must be signing in from a particular location. And we could add specific countries, IP address ranges. So I'm going to click Countries, and I'm going to add Canada. So I'll put in Canada as the name for it. And down below, I'll have to make sure I filter that list and select Canada as well. So people must be signing in from Canada. So we'll just click that, and then Canada shows up as a named location. So I'm going to click Policies over on the left, and I'll click the New Policy button up at the top. So I'm going to call this Canadian Sign-ins. And I'm going to assign this to a specific group. For example, I'll click on Users and Groups, and over on the right, I'll choose Select Users and Groups, and it's going to be users and groups that I select from Azure AD. I'm going to choose a group on the right here that I've already created called East Group 1. And it contains a number of members such as User 1. So I'm going to choose the group, and I'll choose Select. The next thing I want to do is make sure that we specify that the users must be coming from Canada. So for that on the left, I'll click under Conditions on the link, and on the right for Locations, which is currently showing not configured, I'll click on that. So what I want to do then is make sure that I choose Yes for Configure, and I'm going to choose Selected Locations, where I'm going to choose Canada, which we created previously. Then I'll choose Select for that. Next on the left under Access Controls, I'll click on the link under Grant. We could either block or grant access to people signing in from Canada. Well, specifically for members of East Group 1. So I'm going to grant access. Now at the same time, I could also require multi-factor authentication, and of course we've enabled that for User 1, which is a member of the group that is part of this conditional access policy. We could also require the device to be marked as compliant, so up to date with antivirus settings and so on. However, I'm just going to go ahead and enable MFA, and I'll turn that on. So at this point, the default in the bottom left is that it's in report-only mode. It will log this type of activity, but will not enforce it. So to actually enforce it, I would click On, and then I would click Create to create my conditional access policy. And after a moment, our Canadian sign-ins policy is now created. So there are many different tools out there that let you create conditional access policies, such as for VPN authentication, maybe requiring clients are using a certain type of device, they're signing in from certain locations, they have a firewall enabled, they have up-to-date antivirus signatures, and so on. Two-factor authentication, also called two-step verification, is something that you can enable with a user account for a variety of different apps. Why would you do it? Isn't username and password enough? No, even though that's two items, username and password, they are both considered single factor because they're one category. They are something you know. So with two-step verification, we can make it a little bit more difficult for someone to try to break into a user account. We're going to go ahead and do that here with Google. We're going to enable Google two-step verification. So I've already gone to the Google landing page for this configuration in my web browser. So I'm going to go ahead and click Get Started. Then I'm going to specify the email address for a Google account, and I'm going to go ahead and click Next. Of course, I'll then have to enter the password for that account. Once I've done that, I can click Next to go through the two-step verification setup. So here we can protect our account with another layer of security as it says on the page. So we could have our password along with our email address and a unique verification code that can be sent to our phone, that type of thing. So I'm going to go ahead and click Get Started. I'll pop in my password, click Next, and here I'm being prompted to use my phone as a second step to sign in. If I go under Show More Options, I could also use a physical security key, like a YubiKey device, that I must have in my possession for signing in. So text messages sent to my phone, voice calls, all of that stuff. So currently, my Galaxy Android-based phone is being shown here. So that's the one that we're going to be using in my particular case for two-step verification. So I'm going to go ahead and click Continue. I'll make sure my phone number is specified. It's blurred out here, of course, for security reasons. And I'm going to make sure that it text messages me. I don't want to get a phone call. I want a text message sent to my device when I sign into this Google account. Now, if I scroll down, I can also choose Use Another Backup option. So I get a number of codes that I can save or print that I can use for signing in if for some reason I don't have access to my phone. So not a bad idea. And I'm going to click the Send button so it can send a confirmation code to my phone via SMS text message. And I'll go ahead and enter the code that was sent. So this is multi-factor authentication because besides having the knowledge of the username and password, I have to have my phone with me to enter in this code. So I'm going to go ahead and enter the code that was texted to my phone. So this is multi-factor authentication or two-step verification to be specific because I have to have knowledge of the username and password, and I must also possess my phone so I can receive this code and enter it in here. So I'm going to go ahead and click Next. Okay, once it's verified that that PIN was correct, it asks me, do you want to turn on two-step verification for this account? I'm going to go ahead and choose Turn On. Okay, now at any point in time, I can go ahead and turn that off. So let's see what happens when we sign in fresh using that Google account. So I'm going to go ahead in the upper right here and sign out, and we'll do a fresh sign in. So I'll select the account. I still need to know the password. I'll go ahead and put that in. And it automatically says, check your phone because we've sent a notification and I need to tap yes on the notification to continue. So on my phone, it's asking if I'm trying to sign into Google, which I am. So I can either opt in by saying, yes, this is me. Or if I'm not trying to sign in and someone's trying to hack my account, I can choose no, it's not me. So on my phone, I'm just going to tap yes because this is valid. And it's triggering me to sign in immediately on my laptop computer. It's always important to make sure that you limit access to a network in the first place, besides doing the standard hardening for all of the infrastructure devices and hosts on the network. So in this case, we're talking about a wireless network. Here I'm connected to a D-Link simulator for a Wi-Fi router. And the idea is that we want to make sure that we harden this network. We don't want the D-Link wireless router performing authentication. Instead, we want it to forward authentication requests off to a centralized Radius server. That means the D-Link wireless router then would be called a Radius client. Now, devices that try to connect to the Wi-Fi network would be referred to as supplicants. So let's get started with this. The first thing I want to do here is click Wireless Settings over on the left. We've got some standard Wi-Fi options here that we might choose to enable or disable or just change the settings of. For example, changing the wireless network name. Now, the last thing you want to do if this is a Wi-Fi router for Boardroom A in your building is to call it Floor 10 Boardroom A. We don't want to do that because it reveals way too much information. Now, even if you enable hidden wireless, so if you disable the SSID broadcast, there are still freely available tools that can still end up finding the name of your Wi-Fi network. So using a generic name is actually preferred, believe it or not. Now, we would only enable extended range mode if we wanted to make sure the signal was reachable from further away over a longer distance. Now, generally, we don't want to do that beyond a controlled perimeter, such as within the walls of a building. Now, down below, the security mode is currently set to disable wireless security, and it says not recommended. So this is an open wireless network. We don't want that. So here I could choose WEP, Wired Equivalent Privacy. The problem with that is that it only uses a 40-bit initialization vector, and it's known to be crackable easily in seconds. We could use WPA or WPA2, and if it supported it, WPA3, we could also choose that. So if I choose WPA2 Wireless Security Enhanced, down below it sets the cipher to TKIP, the Temporal Key Integrity Protocol, which means the key is not static like it is with WEP for every transmission. Instead, it's dynamic. It changes. However, we could also choose AES, the Advanced Encryption Standard. And instead of leaving it on personal, where we enter and confirm a passphrase, this is a pre-shared key, a PSK, and of course, any connecting device would have to know the same passphrase, so it's like a secret symmetric key. Instead of that, because remember, we said we don't want this Wi-Fi router performing authentication. We just want it to forward it off elsewhere. And so under Personal/Enterprise, I'm going to choose Enterprise. When you configure Enterprise mode, what you're really saying is, this is not home personal use, this is more of a business use, and we've got an authentication server elsewhere. So what it wants are the IP addresses of one or more Radius servers. So I'm going to go ahead and fill out the blanks. Now, by default, Radius uses port 1812, and we still have to enter a shared secret here that must be known, of course, by this device to be able to make a connection to the Radius server. The Radius server would have to be configured with the same shared secret. Now, Radius server is just a server configured to support the Radius standard. It could also be a Windows server. It could be a Linux server. It doesn't make a difference, but it is an authentication server where authentication actually takes place. So we need to make sure that that server is hardened and is only reachable by the appropriate devices, such as this one. Remember, this wireless router would be called a Radius client. So the benefit is that if, for example, this wireless router were actually compromised by a malicious attacker, well, then they wouldn't have access to a large set of credentials. The reason is because the credentials aren't stored here. The credentials are stored elsewhere on the Radius server. In a Windows environment, we can use dynamic access control, which can be based on user attributes in Active Directory to determine which permissions they are granted in the file system on Windows file servers. So the first thing that we have to do in order to use this functionality, which is different than just putting people in groups and the group automatically has permissions, this is based on the attributes of a user. To do this, we first have to turn on a group policy setting. So here on my Windows server, which is also a domain controller for an Active Directory domain, I'm going to go in the Start menu under Windows Administrative Tools, and I'm going to go down and select Group Policy Management. Now I'm then going to drill down under my forest hierarchy down to my domain, and I'm going to right-click and choose Edit to edit the default domain GPO or Group Policy Object. Next, I want to drill down under Computer Configuration on the left under Policies and under Administrative Templates, then under System. I'll just kind of widen this window a little bit. What I'm looking for under here is the Key Distribution Center for Active Directory, or KDC. I want to make sure I go into this KD support for claims, compound authentication, and Kerberos armoring. A claim in an identity management environment is an assertion made by an authority, an identity authority like Active Directory, with some details, such as the department the user is in, the IP address of their device, the type of device, whatever we configure. Those types of details are called claims. So I need to make sure then that we enable claims, and that down below it's listed as supported. Okay, next thing I'll do is click OK. Now that might take some time to propagate throughout your Active Directory domain, but I'm just going to go ahead and open up a command prompt and force it right away with gp update. So I'm going to run gp update /force. And then I'll exit out of there. So now I'm going to go into my Start menu, and what I want to do is I want to start the Active Directory Administrative Center. So from my Windows Administrative Tools, I'll choose Active Directory Administrative Center. And I'll maximize it, and on the left, I'm going to click Dynamic Access Control. Then I'll right-click Claim Types, and I'll choose New Claim Type. And down below in the list of attributes, I'm going to choose department, which is a string value, and this is a claim that relates to users. Now, this depends on Active Directory admins having filled in the department attribute for user accounts in Active Directory. Now, down below under suggested values, we could specify some values by clicking add. And let's say the value, would be sales, and that's also what the display name would be. This is a value for the department attribute. And maybe we'll add here HR for human resources, and that would be yet another valid value. So we can go ahead and do this when we are configuring claims. So I'm going to go ahead and click OK. So if I were to double click on claim types, we would have our newly created department claim. But remember that this option, Dynamic Access Control, is used to control access to Windows file systems. And so what I need to do then is I need to make sure that for Dynamic Access Control, we configure resource properties. Now, what's a resource? Didn't we just do that? Well, we configured access to user attributes in Active Directory, specifically for a department. However, a resource in this context is a file or a folder in the file system. So really it should say file or folder properties. What I want to do is make sure that the department property is enabled. I need to right click and choose enable. Notice that the icon changes. Now the next thing I'm going to do is go into my start menu on my server and fire up Server Manager. This is because I need to add some software here so that we can use that department property in the file system, basically to match that people are from a certain department and that they should have certain access to files flagged for that department. Okay, so I'm going to click Add Roles and Features. I'll click Next, and I'm just going to keep going through the wizard accepting defaults until I get to the Roles screen. I want to make sure under File and Storage Services that I expand File and iSCSI services, and I'm interested in File Server Resource Manager, FSRM. So I'm going to select that and tell it I also want the tools for that. This is important when you want to do comparisons with properties or when you want to classify data on a Windows file system. So I'm going to go ahead and click Next and accept all of the defaults to continue on through the rest of this wizard. Okay, once that's done, I'm just going to go ahead and click Close, and I'm going to go to my Start menu, and under Windows Administrative Tools, we will now see in the Fs that we have File Server Resource Manager. That's the role service we just installed. Now, if I open that tool up, I'm interested in classification management, where we can classify or assign tags, metadata, properties to file system items. So if I expand that and go to classification properties, here's the department global attribute that we enabled. That was the resource property we enabled through the Active Directory Administrative Center. Now, if you don't see that, you could click refresh. It just might be out of date. So it's good to see that that is there. So now we can couple the two together. What I mean is looking at Active Directory user attributes, and if they're in the right department, they have certain file system privileges to files flagged for that department. So let's open up, let's say, Windows Explorer. I've got a sample file on drive C under Projects. So I'm going to select Project A, let's say, and right-click and choose Properties. Because I've installed File Server Resource Manager, I have this classification tab showing up. So I'm going to click on it. The department is currently set to none, but what we can do is select from the values down below. Now, these aren't the values that we entered. We entered the values that we were checking for Active Directory user department items. This is the department we're assigning at the file system level, so Department of Sales, let's say. The idea being for users that have the Department of Sales set in Active Directory, that'll match files flagged as sales, and we want to give read and write access to them. So I am manually configuring that. Now I could go back into the File Server Resource Manager and configure classification rules that run on a schedule that might look for certain things in files and flag them as sales. But I've just flagged it manually, and that's okay for now. So I'm going to close the File Server Resource Manager, and I'm going to close my file system in Windows Explorer. That puts us back in the Active Directory Administrative Center. So I'm going to click on Dynamic Access Control on the left, and I'm going to click Central Access Rules. We don't have any, so on the right, I'll click New, and then Central Access Rule. Call this Central Access Rule 1 Sales. Down below, what I want to do is I want to target specific resources. So I'm going to click Edit, and I will click Add a Condition. So the resource, remember, is a file or a folder. So we could look at various properties. The only one that we've enabled, remember, here centrally is department. And so we can say if it equals a value of sales, then we want this central access rule to apply. So this is for file system resource that have a department that equals sales. Down below, we can say use the following permissions as current permissions, and we could click Edit here to add certain principals. For example, I could choose Select a Principal. Let's say I put in domain users, which is a group, and I'll click OK. However, I don't just want every domain user to have read, and I'll turn on write permissions to sales files. Instead, I'm going to add a condition. And I'm going to select that the user department, this is an Active Directory, must equal, and this is what we filled in, let's say, sales. And I'll click OK and OK, and then OK again. So now we've got our central access rule. Now I'm going to go into central access policies. I have to build a central access policy. I'm going to call this Central Access Policy 1. Down below, I have to add the rules that we've created. Central Access Rule 1 Sales. You could have more than one. And then I'll click OK. Now, the final piece of this is that I need to go back into Group Policy to tell it to deploy this Central Access Policy to the objects in Active Directory that it should apply to. So I'm going to go back into my Start menu, down into Windows Administrative Tools, and in the G's, I'm going to go into Group Policy Management. And again, I'm going to drill down to my domain level GPO, and I'm going to right-click on it and edit it. On the left, I'm going to drill down under Policies, Windows Settings, and then Security Settings, and we're talking about file system security. So I'm going to go down and specify Central Access Policy. Now, there's nothing here until we right-click and choose Manage Central Access Policies. There it is, Central Access Policy 1. I'll click Add and OK. Now, the idea here is that this group policy setting we've done in the default domain policy will apply to all file servers joined to this Active Directory domain. Otherwise, you could scope it out by OUs and so on. So that setting needs to be put in effect for Windows file servers to allow users in Active Directory configured in the sales department to have access to files in the file system flagged as sales. So if we were to go, let's say, back into the Start menu under Windows Administrative Tools, and let's say we go into Active Directory users and computers, this is where we'd have to make sure users are configured with the appropriate properties. So when I create or modify existing users, if I just open up User Properties, we are interested here under the Organization tab in the department. This is where we'd have to enter sales in order for that to match our policy, which gives read-write access to files flagged for sales. Passwords are still widely used as an authentication mechanism, and so it's going to be important then to implement security policies to enforce password settings. Things like complex password requirements where we might have to have a mixture of upper and lowercase letters, numbers, symbols, maybe no repeating letters one after another, that type of thing. Maybe setting the minimum password length to 8 characters and requiring password changes every 60 days. All of those things are part of a password policy. And we could configure it on an individual Windows device, such as a Windows client machine not joined, let's say, to an Active Directory domain. You can configure group policy locally on it with those settings. But in this case, I'm going to do it centrally in Active Directory, specifically through group policy. And so here on my server, I will start by going into the Start menu, and under Windows Administrative Tools, I'm interested in Group Policy Management, so I need to go down to the G's to get to that. Now, when I launch the Group Policy Management editor, or tool, the editor comes next, I can drill down in my Active Directory hierarchy. So I'm going to drill down under my domain, domain1.local, and here I've got a default domain policy. Every Active Directory domain has this, in which we can configure literally thousands of settings, including password settings. So I'm going to go ahead and right-click on that and choose Edit. That takes me into the Group Policy Management editor, where on the left, I'm going to drill down under Computer Configuration, and I'm going to go down under policies. I'm going to go down under Windows settings. Then I'll expand security settings. I'll just widen out this panel a little bit. And I'm interested in under account policies, the password policy. So when I select that, over on the right, I have a number of items that can be configured. For example, enforcing the password history is currently set to remember the last 24 passwords. Now that goes hand in hand with the minimum password age of 1 day, which I'm going to bump up, by the way, to be 30. What this means is users won't be able to reset their password right away one time after another. They're going to have to wait at least 30 days each time. And coupled with the fact that it's going to remember the last 24 passwords, so users can't reuse that, this is a good thing. It means we can ensure users have unique passwords. I'm going to set the maximum password age here, let's say, to 60 days in accordance with organizational security policies. That's when the password absolutely must be changed. Currently, the minimum password length is 7 characters. I'm going to bump that up to 8. And I can also make sure that password complexity is enabled, which it is. But while we're here, we've also got the account lockout policy, which is currently not defined. So I'm going to go ahead and double click on the account lockout threshold. I'm going to set that to a value of 3. Basically, after 3 incorrect login attempts, I want the user account locked. And I want that timed. When I click OK, it's got some default settings, including for the timing, which is set to 30 minutes. I want it to be 60 minutes. So I want the account lockout duration to be 60. And I also want to set the other policy value for resetting the account lockout to be 60 minutes. Now, this is great because if we've got brute force password attacks that keep hammering accounts with a multitude of passwords, this will kick in and thwart that attempt. These days, attackers are a little bit more suave. What they will often do is use a technique known as password spraying, where they will have, for example, a password that they want to use or try against an account, but they will try it against many accounts. So it's very slow, and then they'll cycle around and try another password against all of the accounts. This way, we aren't hammering a bunch of passwords to one account all at the same time. And so that is one way that attackers will try to get around these account lockout type of policy settings. Now, you need to be careful, because if I were, let's say, to create a group policy object for an OU, so let's do an example. Let's say I go into my Start menu under Windows Administrative Tools and Active Directory Users and Computers because I want to build an organizational unit. So under Domain 1 Local, I'm going to right-click and choose New, Organizational Unit. Let's say I'm going to call it East_region. Okay, so now in there, I could create user accounts, group accounts, could create computer accounts, and essentially have them organized under that OU. So back here in the Group Policy Management tool, if I click Refresh at the top, there's East Region. I could right-click on that here and create a GPO and link it to that OU. East Region _settings. That's the name of the group policy object or the GPO. Okay, that's cool. So now if I right-click on East Region Settings and go into Edit, then within here I can do pretty much the same thing that we just did. I can configure any setting, but we're talking about password policy type of settings. So down under Policies, Windows Settings, Security Settings, Account Policies, here's Password Policy. Let's say, for example, that what we're going to do here is set the maximum password age. Well, let's say we're going to set that to 5 days. That's vastly different from what we did in our other GPO. I'm going to go ahead and OK that. Now, let's close that out because you also have a domain controller's OU, and the server we're sitting at here is actually a domain controller. And if we go back to Active Directory Users and Computers under Domain Controllers, here it is. It's called Server 1. If we were to open up a command prompt and type hostname, this is Server 1. Okay. So let's say I wanted to apply password policy settings that would affect only domain controllers. So I could do that by going into the domain controllers GPO. Let's go back to group policy. There it is. So I could right-click on it and edit it and do the exact same thing again. What we're seeing here is we can set the same settings at different levels. Now, depending on where user accounts or computer accounts reside in the Active Directory hierarchy will determine which group policy object settings are applied. So let me just go back here into password policy real quick. Let's say we're going to set the maximum password age here to 10. Okay, so at the domain controller level, the maximum password age is set to 10. If we double check our work, the default domain policy, if we go back and drill down to the same location, the maximum password age is not set to 10, if you recall. If we go down and take a look at it, the maximum password age here is 42. Okay, why am I doing this? Well, you'll see. What I want to do is make sure I now put those group policy settings into effect. Now, I can either wait, and depending on your Active Directory replication topology, you might wait a few minutes, you might wait 90 minutes, a couple hours. It just depends. But I can force group policy to apply immediately by going into a command prompt on this host. So to force it to update on this host, I can run gp update /force. So we'll wait for it to update the policy. And so an important point to be made here is that only the domain level group policy object password settings will apply to domain users, even if you've configured GPO settings related to the password policy for GPOs linked to organizational units where users have their accounts. The settings will not apply, only from the domain level GPO. There are plenty of ways of cracking passwords. In the case of a Linux system, we could do it live by trying to brute force accounts. Same thing with the Windows system. Of course, if password policies have intruder detection or lockout settings, accounts might be locked out after a number of subsequent attempts. However, password spraying is a technique that a lot of malicious users will use to use the same password against many accounts, so it's not in quick succession, before looping back and enumerating through all the accounts again and trying another password. The other thing to watch out for is that if you have hashed passwords, especially if they're not salted with some kind of random data, it makes it much quicker for attackers to break them. So here, we're going to take a look at how to use John the Ripper. This is an old tool that's still valid today that can allow us to crack passwords for things like zip files or Linux hashed passwords. So I'm using Kali Linux and I'm connected here as user root. And what I'm going to do for starters is add a new user account here in Linux using the user add command. I'm going to create a user called C Blackwell, and I'm going to use the password command PSSWD to set a password for user C Blackwell. Type in the password and I'll confirm it, and it's done. It says it was updated successfully. Now note, if you're not logged in as user root, you might need to prefix all of these commands with the sudo command to run them in elevated privileged mode. Now, if I were to, let's say, run the tail command to show the last few lines of a text file, let's start by doing a tail of /etc password. We can see we've got user C Blackwell listed here. So that account has been created, but there's no password reference here because the password by default is stored in /etc shadow. And we can see here that we've got user C Blackwell and a hash for that person's password. And that's what we're interested in trying to crack in this particular case using John the Ripper. John the Ripper includes a command called unshadow, where you can put together some credential files, essentially lump them into a single file that you use for the attack. So of course, never do this on a system that you don't own or a system that you don't have express permission to use for this purpose. But here it is a system I own, so there's no danger. So I'm going to use unshadow. I'm going to specify I want to lump together the etc password file and /etc shadow. And let's say we'll output that using the output redirection symbol, the greater than sign, to a file called creds.txt. Okay, so if I cat the creds.txt file, all right, looks like we've got the contents here, including, of course, the password hash information. So looking good. So I'll clear the screen with the clear command. Now what I'm going to do is run the John command, and I'm simply going to specify the name of the file, the creds.txt file. And I'm going to press enter. and let it start doing its thing. And it doesn't take very long for it to determine that the password for user C Blackwell is green. So I'm going to go ahead and press Control C. Now you can also, I'll just clear the screen, run the John command with -- show after the fact, specify the file, in this case creds.txt, to get a listing of all the passwords that it managed to figure out. And here we just have one password hash that was cracked. In this case, it's the password for user C Blackwell. So we want to make sure that we limit access to a host in the first place. Naturally, this only succeeded because I had access to some sensitive files on this host. Remote Desktop Protocol, or RDP, is what's commonly used to remotely manage Windows hosts using a GUI. So here on my Windows server, I'm just going to open up the Start menu and search for Remote and click on Remote Desktop Settings. So the first thing is we need to make sure that on a given Windows host that Remote Desktop is enabled and that a firewall rule allows the traffic in. So in this case, Remote Desktop is turned on. Now what I want to do is switch over to the command line so we can take a peek at whether RDP is in a listening state. So I'm going to use my up arrow key to go back through previous commands, and I'm going to run one that I've used recently. It's netstat/p. We're looking for the TCP protocol. /a, and then we're going to pipe that to find string, and I'm looking for 3389 because Remote Desktop Protocol listens on RDP port 3389. And indeed, on this particular host, it is showing up as being in a listening state. Now, this is fine on an internal network, but you don't want to do this on a public-facing network, only because if this gets scanned and discovered, there are many brute force RDP type of attacks that can be executed against the host. Let's just check out this host IP config. It returns back 192.168.4.117. So here in Kali Linux, I'm going to run an Nmap scan on my subnet to make sure that host is discovered. So I'm going to run nmap-p for port, looking for port 3389, and I'll specify 192.168.4.0/24. That is my subnet. Let's go ahead and give that a moment to see what we get. Okay, so if we go back through the output, we'll be able to tell whether port 3389 over the TCP transport is closed or whether it's up and running. If we scroll up and take a look, we're going to see one that's open, but it's not the server that we expected. So there's another host up on the network that has that in a listening state, or rather a filtered state. So why isn't our host showing up? It's probably because it's firewalled, and so any scans against it won't reveal it. But let's turn off the firewall and take a look. Okay, so naturally you don't turn off the firewall just for kicks. We only do it for testing purposes on non-production systems. So to do that, here from the command line, since we're already here, I can run netsh netshell advanced firewall, and I'm going to set all firewall profiles to a state of off. So it says okay. Let's go back and let's actually run a scan directly against this IP.117 to see whether or not it shows up in our Nmap output. So back here in Kali Linux, I'm going to run Nmap again, and we're going to do pretty much the same thing. -p for port, and we're going to do once again 3389, except this time 192.168.4.117. And so this time we have port 3389 actually wide open. So it doesn't take much for an attacker to perform reconnaissance scans to discover these hosts in the first place. So what do they do next? Let's check it out. Okay, so I've changed directory into the /usr/share/wordlists folder. And if I clear the screen and do an ls, I've got a file here called rocku.txt. That was a zipped file, and I simply used the sudo g unzip command to unzip it to this text file. What is it? It's a large text file with a lot of different passwords in it. For example, if I use the Linux head command to ask for the first few lines in that file, then we'll see some of the passwords that are in there. Now, there are many more than this. What I've done to speed this up is I've put in the password that I know is being used for RDP on the host we discovered. Realistically, you would let it go through the entire list. Actually, let's see how big this is. If I were to run cat against the rocku.txt file, it just goes and goes and goes on and on and on and on and on. So I'm going to go ahead and press Control C to quit out of that. Now, really, we probably don't need to go through this many passwords because year after year, the most common passwords are things like, I'll just type it in here, 1, 2, 3, 4, 5, 6, and stuff like that, or the word password. So usually it's not that hard to break into a lot of these things because on the whole, most users and technicians don't use complex passwords, although of course that should be happening. So let's make this all come together using the Hydra tool. I'm going to use the Hydra tool and specify -L, that's lowercase l, we're in Linux so that matters. The administrator account is what I'm going to test, -P, and I'm going to specify the word list here. That would be the rocku.txt file. And then I'm going to specify RDP : / and then 192.168.4 and 117 was the IP address of that host. So at this point, it's trying to attack the RDP port on that machine. Naturally, disclaimer, don't do this on machines you don't own or have express written consent to do this to, such as for a penetration test, because you could end up getting yourself in hot water. Don't use these tools randomly over the internet. Plus, it's not ethical. Now we can see very quickly down below that for the host that we specified, it was able to successfully log in as administrator with the password that I fed into the file, of course. But the point is that it read the file, it applied it, applies everything, and it finally was able to find the password for that host. That's pretty easy, and we're talking about using freely available tools, and anybody can do this by watching a tutorial or watching this video. You can just take a few minutes and figure out how to do it. And so we want to make sure then RDP ports are not exposed to the internet because it's just way too easy for this to happen, which also lends credence to being very careful about who we let on our networks in the first place. So using network access control and MAC address filtering, and make sure we disable unused switch ports. All of that stuff goes a long way in securing your network. Role-based access control, or RBAC, is a great way to limit or delegate administrative permissions in an IT environment, including in the cloud. So here in Microsoft Azure, we can use roles, which are collections of related permissions that are assigned to users or groups, and we can apply those roles to a part of the Azure hierarchy, such as an entire subscription. So for example, here in the Azure portal, if I type in subscription at the top and go to my Azure subscription, there's my subscription. It's a pay-as-you-go one. When I click to open it up, in the left-hand navigator, I'm going to have something called Access Control IAM. IAM stands for Identity and Access Management. If I click here, then I can click on Role Assignments to see any roles that were assigned at the subscription level. In Microsoft Azure, under the subscription in the hierarchy, we have what's called a resource group in which you can deploy specific related cloud resources, like storage accounts and virtual machines and web apps. So you can apply roles at the subscription level here, and it will flow down to all of the resource groups in the subscription, and of course, by extension, to every resource. Of course, you could be more specific and assign a role to a resource group so that it only applies to the items in that resource group. You could be very granular and, for example, set virtual machine permissions for a cloud technician to a specific individual virtual machine in a resource group. So we're going to go ahead and apply some permissions here for virtual machine management at the subscription level. So to do that, I'm going to click the Add button at the top and choose Role Assignment. First thing I have to do is select the role. So I can click to open the role drop-down list and then filter it by typing in, let's say, the word virtual. And what I'm interested in is the virtual machine contributor role to allow virtual machine management. I can assign this, for example, to a group. I've got a group that I've already created here in Azure Active Directory called East Group 1. So I'm going to select that group. Members of that group will have virtual machine permissions to the subscription. Let's go ahead and save this assignment. After that's done, if I just click refresh here, because we're already under the Role Assignments tab, then East Group shows up here with virtual machine contributor role permissions to this resource, which of course is our subscription. Now in the left-hand navigator here in the Azure portal, I can click on resource groups, and I can get a list of resource groups. Now, I've got some already here, such as one called testing. I'm going to click to open it up because when I open up a resource group, I can do the same type of thing. I can click on Access Control IAM on the left. I can view any role assignments that were created or that were inherited. Here, East Group 1 shows up with the virtual machine contributor role, but notice it says that it was inherited from the subscription level. So that's very interesting. So in the same way, if I were to go to individual resources within this testing resource group and do the exact same thing, go to the Access Control IAM tab on the left, I would also have a listing for East Group 1. So it flows down through the hierarchy. Now, when we work with roles, we should be aware of the roles that are available. So for example, if I click the Roles tab on the right, it'll take a moment for the list to load up. Here we have a list of all of the various roles that are available, and there are quite a few of them. So for example, why don't we take a look at the one that we have worked on? That would be the virtual machine contributor role. So we could filter by role names at the top to make it easier. Here's the virtual machine contributor role. So if I were to click that up, we have a listing here that shows the assignments for this role, East Group 1. And if I click permissions, here I'll get a list of all the permissions that are applicable in this role. Because remember, a role is simply a collection of related permissions. So if I were to click, for example, on Microsoft Compute, we would see there are some read and write and delete permissions that are applied as appropriate for this particular role. Now, if the built-in roles don't suit your needs, you of course can build your own custom roles. But there's quite a few roles there that are built in Azure. So it's a great way to delegate cloud technician access without giving them full access to everything within your Azure subscription. Now we could also look at this from another perspective. So in the left-hand navigator, which I'll click to open up, I could scroll all the way down and select Azure Active Directory. Here I'll click on Groups. We had assigned a role to East Group 1. So I'm going to go ahead and click to open up East Group 1. And if I click Azure Role Assignments over on the left, from here, we have another way of looking at the same configuration. We have a listing showing that the virtual machine contributor role was assigned to this group. And of course, that applies to our subscription, our pay-as-you-go subscription. If we were to go, let's say, back to the default directory breadcrumb trail icon up at the top, and if I were to go look at users, for example, user 1, and if I go into groups, user 1 is a member of East Group 1. So by extension, we would think then that user 1 should have that Azure role assignment for virtual machine contributor. And indeed, they do. So what we're seeing here is that the role was assigned to our pay-as-you-go subscription, and the group membership of East Group 1 for this user is how the user gets those permissions. You can't properly protect sensitive data if you don't know what you have for sensitive data and where it is. And so it's important to have some automated way to discover data and to try to classify it, such as financially sensitive data or protected health information. We can do that in Amazon Web Services in the public cloud using Amazon Macie. This way, we can comply with laws, regulations, or contractual obligations when it comes to the protection of sensitive information. So let's get started here in the AWS Management Console. I'm going to search for S3 in the top field. S3 is a reference to the storage buckets in the cloud, the storage locations where we can store data. And I've already uploaded some sample data. Let's just take a look at it very briefly. So I have a bucket here called Bucket YHZ172. It's in the Canada Central region. Now, the region can be very important when it comes to data sovereignty issues. In other words, legal jurisdiction. If the data is stored in central Canada but is being accessed from other countries, what happens and what laws and regulations apply to that data? In the case of GDPR for European Union citizen private data, it doesn't matter where the company is, where the data resides. If it's European Union citizen private data, the GDPR, the General Data Protection Regulation, applies. But in other cases, it might matter, for example, if a data center in central Canada is subpoenaed for all of the storage devices, then how does that work, even though the organization might be elsewhere? So to answer those questions, get proper legal advice. In this case, I'm going to open up the bucket so we can see what's in it. I've uploaded some sample files here, including some CSV file information, TXT files, a JPEG file, an HR employee list, customer transactions, and so on. So what we're going to do is have Amazon Macie discover this data and analyze and classify it. So to do this, in the top center search bar, I'm going to search for Macie, M-A-C-I-E, and then I'll click on Amazon Macie. So because I've never configured this before, I'm given the Get Started button, so I'm going to click Get Started. There's a note here about role permissions being assigned for our AWS account so that Macie has the required privileges to be able to go in and look in our buckets for sensitive data. So that's fine. I'm going to click Enable Macie. So at this point, Macie is starting to discover what we have. Okay, so Macie has discovered one S3 bucket, and if we click on it, it's our bucket YHZ172. But notice under the monitor column, it currently says no. Well, what we want to do is we want to monitor that bucket. So I'm going to turn on the check mark for that bucket, and I'm going to click Create Job in the upper right. And then I'll just continue through here by clicking Next. It's going to be a scheduled job, let's say daily. It will evaluate what's in that bucket, or it could be a one-time job. In this case, I'll just do a one-time job. I'll click Next. We could also work with custom data identifiers, and I have a link to click in the upper right. It's called Manage Custom Identifiers. So I'm going to hold Control and click on that so it opens up another window, just so we can see what the custom identifiers looks like. So what I can do is I can actually click on the Create button, create an identifier, and what I'm specifying here is a regular expression. If you're a Unix or a Linux person, and in some cases Windows command line person, you might have experience with regular expressions. These use special symbols for pattern matching. Maybe you're looking for credit card numbers or social security numbers or postal codes or anything else like that that you specifically want to weed out. However, there are some default identifiers that will be used, so I don't need to build any custom data identifiers. I'll click Next. This job, I'm going to call it Job 1 Bucket YHC172. I could give it an optional description. I won't. I'll click Next. And at this point, we're ready to go. So I'm going to scroll down to the very bottom right, and I'm going to click Submit. So we've submitted this discovery job. It's a one-time job, and the status is that it's currently active and running. As you might guess, the more stuff you have in your bucket or buckets, if there's more than one, the more stuff you have will determine how long it takes for this to complete. Okay, after clicking the refresh button, the status of our job will then change to complete. So it's had a chance then to analyze what is in our bucket. So I'm going to open up our little menu over on the left. And under Findings, I can view the results in a number of different ways, such as by bucket. So we've got our bucket, and apparently there are two findings. We can click by type, and apparently it's found one occurrence of financial sensitive information and one occurrence of sensitive personal information. We could also see it by job. There are two findings by the job ID that was assigned for the job that we just submitted. So, for example, if I go by type, financial, well, what is that? If I click on that, it will give me some details. So we've got a high sensitivity level for something that it has found in our bucket. And if I click the little link here to open that up, we'll get some further details. It's found what appears to be some financial sensitive information within the card data DB file, database file. Okay, well, that's good to know. If we click on personal and do the same type of thing, we've got one occurrence in the bucket. We've only got one bucket that we selected, but this one is flagged only as a medium type of finding. Well, if we follow the link for that one, we'll also get some details here about what it's looking for in the customer transactions XLS spreadsheet. And as we scroll down through, we can read more and more details. Apparently, there are 6 cells that might have some sensitive information. We can click on that link. We can actually see some of the details within that spreadsheet. So what we're finding then is Amazon Macie was able not only to kind of scrape through our bucket looking at the data, but also to start to identify certain types of sensitive data based on data identifiers. And if we wanted to, remember, we could have made our own custom data identifiers to classify it in a different manner. And you might have to do this to comply with contracts or laws or regulations. Azure Information Protection, otherwise called AIP, is a cloud-based data loss prevention or DLP tool. The idea is we want to safeguard sensitive data in the organization and prevent the unauthorized dissemination of that sensitive information outside of the organization. So for that, we need to work with AIP policies and labels and the AIP client. Here in the portal, in the top center of the search bar, I'll choose Information Protection. That puts me in the Labels view, so I'll click Add a new label on the right. Now the label is enabled, so I have to give it a name. We'll call it Highly Sensitive. Next, I have to specify a description. So I can then, down below, select a color to distinguish this from others. Let's say orange. I'll set the permissions to protect. In the blade on the right, I have the option of setting the actual permissions. So I'm going to go ahead and click Add Permissions. Now from here, I can select some users within Azure AD. So I'm going to go ahead and choose Browse Directory to do that. And I'm going to select a user I know already exists in my list of users and groups. So user Max Bishop. So I'll select Max and click Select. Now down below, we have to determine the permissions that will be applied for the documents labeled this way. So it can be viewer, co-author permissions, or even custom permissions where you can choose what Max Bishop can do. So I'll use co-owner, click OK. There's no file content expiration. I'm going to choose never for allow offline access. So there needs to be an internet connection. I'll choose OK. So the protection is now configured. Down below, we can also add a header or a footer or a watermark, which I'll turn on. I'll put some text here. Property of LaChance IT, that's a background document watermark. I'll leave the other defaults here for the watermark color and position. Now I'm going to specify a condition for when we should add this label. What we could do here, for example, is choose financial as an industry. And down below, what I might select is that if it detects a credit card number, then we want to label documents, in this case, as highly sensitive. So I'm going to save that credit card number condition. We can also determine, I'll just click Save. We can also determine if labels are applied automatically or recommended. So I'll save that change, and we've now got a label called Highly Sensitive. But it's not tied to a policy. So I'll click Policies on the left. I'll click Add a new policy. I'm going to call this Policy 1. I'll select the users or groups that should have this policy applied. So I'm going to keep going in the right and search for Max. I'm going to select our user Max Bishop, and I'll just OK out of that. So I've selected a user that will have the settings in this policy applied. But I have to add labels. So I'm going to select the label to add to the policy. And on the right, I'll choose our highly sensitive pre-existing label that we created. So then I'm going to scroll down. It's been added to our policy, but I can also set that as the default label that would be applied if users don't specify a sensitivity level. So I could turn that on to make sure that documents and emails have to have a label applied. I could also turn this on for automatic, for email messages, and displaying the information bar in the Microsoft Office app. So I'll click Save to save this policy, and then I'll click OK. So at this point, I've configured an Azure Information Protection policy called Policy 1. And if we go back and look at the labels, the highly sensitive label is now associated with Policy 1. Now that we've got the Azure Information Protection label and policy created, the next piece of the puzzle is the Azure Information Protection client, which needs to be used on client devices. We've got an Azure Information Protection Viewer app for a multitude of platforms. Windows, for the Mac OS, for Windows phones and iOS devices and Android devices. And then we've got the actual Information Protection client, which I'm going to click on down below, which I can download and install on my Windows machine. Here in Microsoft Word, I am creating a brand new document. I've already installed the Azure Information Protection client. We can see the Protect icon up at the top. Notice that Highly Sensitive is there, Show Bars there. So Highly Sensitive is applied as a default label according to my policy. for user M Bishop, Max Bishop. That's who I'm signed in as here. Back here in the portal, I'm just going to search the top center bar for info. So we can go to information protection. So we can see that we've got a label, highly sensitive. That's the one that's being applied. If we click on policies on the left, there's policy 1. If we open up policy 1, this is what uses our highly sensitive label that is currently showing it up within Microsoft Office. We didn't even have to do anything. It's set as the default label. In addition, if we scroll down, we can also see that we have enabled the display of the protection bar in the Office app. So that's why we see that protection icon. Back here in Word, I'm going to type in some sample text, and I'm going to go ahead and then save this document. When I do that, highly sensitive shows up. That's the default label that's being applied. And also I can view permissions. Now they're all set there with a value of yes. And my watermark has been added automatically in conjunction with my policy configuration. A Microsoft Azure resource is something we create in the Azure cloud, whether it's a virtual machine or a storage account or a web application. And what we can do is we can add additional metadata to each of those resources, and pretty much all resource types, really. We can add key and value pairs, a maximum of 50 tags. These key and value pairs are called tags. And the reason you would do this is to add more meaningful information, like tying resources to a project or a department, which can make things a bit easier in Azure because you can filter lists of resources by tag, so maybe show only the resources for a certain department. And when it comes to billing, you can even organize your costs by tag value. So let's talk about how we can work with this. So for example, let's go into the virtual machines view and let's open up a virtual machine. Whenever you're looking at the properties of a resource, over on the left, you'll be able to select tags. From here, we'll see any existing tags. Now, we don't have any, but we can also add some tag names and values. Now, when I click on name, any existing tags that have already been used will show up here. For example, project has already been used. If I select project, I can then specify a value for it. And similarly, when I click on value, any values already entered for that tag name will show up. So I see ABC in my drop-down list, which tells me that that has already been used. And I can either select that or type in something new. Well, let's say that this resource should be tagged as Project ABC. So I'll do that. But remember, we can have up to 50 of these key and value pairs. So I can go down and add another one. Maybe I'll make one called Cost Center. And maybe I'll put in like an airport code or however we do it in our organization. So I've got 2 here. So I can go ahead and click Apply, after which my tags are now shown down at the bottom. Project ABC, Cost Center, YYC. But we're looking at how to apply this to an Azure resource after the fact. And it really doesn't matter what type of resource it is. So let's say I went over my left-hand navigator and selected all resources, and let's just pick something. How about a public IP address resource? If I click on that and open it up again, here I have tags I can use. And because I just created Cost Center, it shows up in the list. And I can either select that value or I could even enter a different Cost Center value, whatever is appropriate. Okay, so we've got a couple of things that we can tag here that already existed. But you can also specify tags when you're creating a new resource, whether here in the portal, using PowerShell, the CLI, ARM templates, it doesn't matter. You can specify tags at any point. So if I go back home and click Create a Resource in the upper left, let's say I was going to create a Windows virtual machine. I can go, in this case, I'm just going to jump right ahead to tags. This is where I can add my tag items. So I could add, for example, Cost Center. I could select from the values that were already used or add new ones, doesn't matter. But notice here we've got a resource column that says 12 selected. What on earth is that? Well, when you build a virtual machine, there are a number of other items that are also potentially going to be created, like a public IP address, a network security group, a network interface, a disk, and so on. And so you can also deem that those items should also be tagged that way. Okay, so we can set the tags at creation time or at any point thereafter. Now let's go back into the All Resources view. Here, I can select one or more objects or resources, whatever you'd like to call them. It doesn't matter what type they are. Here I've got what? Storage account, a log analytics workspace, and a public IP address. Well, when I've made that selection, up at the top here in the All Resources view, I have an Assign Tags button. And when I click that, I can add new tag items. So the resources are shown down below. I can click the little trash can if I perhaps mistakenly selected one, but I didn't. And at this point, maybe I want to assign those selected resources to a project, like Project ABC. Okay, so once I've done that, I'll click Save. And it won't take very long. I can track this by looking at my notification or bell icon in the upper right, where it's going to be assigning the tags, and then it says it successfully did it. It assigned one tag to 3 resources. Okay, cool. Now, the other thing that's interesting here is we can also filter based on tag. So right now, we've got some filters. The subscription is all subscriptions, all resource groups, all types of objects or resources, all locations. Add filter. Let's add another one. So the filter here I could select would be tags. Now, when I choose that, I can select the tag I'm interested in, like project, equal, and then I can select the appropriate value, like just project ABC. After I do that, the list will be filtered. This is a smaller list now. It's only showing me items that have been tagged as ABC. So if I open up one of those resources and go to tags, then it's going to have the project ABC key value pair, as you might have suspected. Now I can remove that tag filter at any point in time just by clicking the X up here. Let's go into our subscription. Now the reason I'm doing this is because we know that billing occurs at the subscription level. I've got a pay-as-you-go subscription tied to my Azure AD tenant. So I can see the current cost, and that's all great, but I want to open up that subscription. Because one of the things I'd like to do is take a look at some of the costs. So I'm going to click Cost Analysis over on the left. Okay, so I get a sense of the actual cost and the projected forecasted cost and so on. Now what I can do here is click Add Filter up towards the upper right. And in this case, of course, we're talking about tags. So I could select Tag, and I could select Project, and for example, ABC, and click outside to put that in effect. And now we're looking at costs as applied only to items that are tagged as Project ABC. There is always a point in time when sensitive data, whether stored on paper, so printed on paper, or whether stored on digital media, there's a point when that data is no longer useful. Perhaps the data is still useful, but the underlying storage media is not. And so we need a secure way to get rid of that media, to make sure that sensitive data artifacts can never be recovered. Now, there are many things that we can do. We can physically shred or destroy, for instance, with an incinerator, burn up devices. Or if the devices are going to be reused, there are some certain approved tools that we can use that might use multi-pass overwrites of the disk storage blocks to make sure data is not recoverable. So the National Institute of Standards and Technology, NIST, has special publication, or SP 800-88, Guidelines for Media Sanitization. Now, if you open up the latest revision for that, you'll be able to go through the entire document to read about proper document shredding techniques and data removal from solid-state drives, from SCSI hard disks, and so on. So, for example, if I look for, let's say, write pass, as in overwriting with multiple passes, then we see some listings here. For example, for storage devices that are magnetic media, spinning disks, a single overwrite pass with a fixed pattern can make it much harder when others might attempt to retrieve data. However, the idea is we want to use multiple write passes. So we have the option of doing that depending on the tool that we are using. So we're going to go ahead and use a hard disk scrubber tool to do just that. We're going to use it to wipe a magnetic hard disk securely. There are many tools available that can do this. In this particular example, I'm going to use the hard disk scrubber tool. This is a tool that you can get your hands on in order to be able to securely wipe media. Okay, so I've downloaded that hard disk scrubber tool, so I'm just going to go ahead and right-click on it and run as administrator so that we can get the tool installed. And then I'll click Next. I will accept the agreement. I'll click Next again. go through and accept all of the defaults to get this installed in the default location. And at the end, it wants to launch the hard disk scrubber. So I'm going to go ahead and leave that checked on, and I'll click Finish. Okay, so here we are in our tool. So the first thing that we need to think about is which disk device connected to this host do we want to sanitize? So from the drop-down list, I'm going to choose drive letter E, which is a data volume. So presumably this would have sensitive data on it, or did have sensitive data on it. And we just want to run a multi-pass overwrite to make sure the disk is properly scrubbed so that data artifacts cannot be recovered by unauthorized users. So down below, we can do a scrub type of normal, random pattern only, heavy with 3-stage patterns of zeros and ones, and then random, super, or ultra, which is DoD recommended. So I'm going to go ahead and select ultra, and at this point in time, I'm going to click Scrub Drive. So it's now scrubbing that drive, in this case, drive letter E. So naturally, you want to make sure that that's a disk that you want to be able to cleanse. You want to make sure it doesn't have any data on it that you need to keep. So we'll give it a few moments here to do all 9 passes to properly sanitize drive E. So depending on the size of the disk, will determine how long it really takes for a multi-pass sanitization or scrub to occur. Also notice here that we do have the option of writing a log file. Now that might be important, so you have some documentation to go hand in hand along with this action of actually scrubbing storage media. The Shodan.io website is an important website for cybersecurity specialists. Now, the reason this is true is because it allows you to explore vulnerable devices, whether they're baby monitors in a household, whether they are gas pump sensors at a gas station, whether it's a wireless router or a wired router that's not been secured. The idea with the Shodan website is that a lot of these devices are simply discovered by an automated algorithm that crawls the internet and compiles the information in one central location. That would be the Shodan.io website. So what you can do here is you can register for free, which allows you to go beyond a few pages of search results when you start poking around in here. So I'm going to go ahead and log in with an account I've previously created for free. So now that I've signed in, I'm going to go ahead and click the Explore button towards the top center of the web page. Now from here, I've then got a categorized list of items I can start exploring, whether it's industrial control systems, databases, video games, webcams, and default passwords that are still set on devices. For example, if I click on default password, I now get a page of devices. Each of these listings is a separate device. We also have some location information, such as Slovenia or Taiwan, and we have some details about the default username, and in this case, the default password. Now, what's interesting is we also have a link. We can click the link icon to jump to that device. However, if we get a 401 unauthorized message as shown here, that means that the default name and password will not work against that device. Naturally, we want to make sure that we do not abuse this site. We don't want to use the Shodan.io website with the intention of finding vulnerable devices to break in, because that is illegal. So why are we here then? We are here to simply state how incredibly easy it is for unsecured devices to show up here for the bad guys to get access to. That's why we're here. So if I were to try to follow one of these links, in this case, it'll open up a web browser window. If I go back and try the default username and password, which we know will not work, so admin and 1234, in this case, when I go to sign in, I don't get in because it's unauthorized. Now, you don't want to just try these things out on items that do not state that they're unauthorized, because you might actually get in. And at that point, you probably have crossed the line, regardless of where you are in the world and which laws apply. It's just not worth it, not legally, and it's also wrong ethically. Now, some IT security specialists might argue that if you follow up the discovery of a vulnerable system you were able to get into, and you're only going to know that if you get in, if you follow that up immediately with responsible disclosure to the system owner, then maybe it is ethical. That's a gray area legally, and you want to be very careful about that. So at any rate, here we are looking at a number of different types of devices that might use default usernames and passwords. But let's go back in our browser because we've got other items here, such as industrial control systems, or we can view ICS devices. As we scroll down, we see it categorized by protocols. These are industrial control system types of protocols like Modbus. We can look at Siemens S7 communication devices, so programmable logic controllers, PLCs, that can control a number of different types of devices in an industrial environment. The DNP3 protocol is shown here. So we've got a number of items that are available, and from here we could browse it. For example, if I were to click Explore Siemens S7, then we have a number of devices that show up. We see the geographical location of these items, such as Saudi Arabia, Malaysia. We have IP addresses shown. And if we start clicking on these devices, we may or may not get a link to the device. Now, bear in mind, some of these devices might have been pulled off of the network, so to speak, so they're not publicly accessible since they showed up on the Shodan.com website. So we have the ability then to try to explore some of these or simply to view the information. Really, the point here is that all of these devices that are accessible in some way over the internet get discovered, and they show up here on the Shodan.io website. Let's go back again. That was industrial control systems. So I'll go back to the point where we can then view databases. And from here, we can start determining what kind of database that we're interested in looking at, whether it's MySQL, PostgreSQL, or an elastic type of database, Memcached. All of these items are potentially available. So if we click on Explore MySQL, what will it have discovered that is potentially vulnerable? Well, quite a bit of items, as we can see. So we have a number of items shown here in different parts of the world with their IP addresses. So we could use a MySQL client tool, whether it's command line based or GUI based, like the MySQL Workbench tool, to attempt a connection. But again, you would only do that if you have a high risk appetite, because remember, we don't want to cross that legal or ethical line. So really, we are here just to point out that this is a point of interest that these items actually show here. We'll just keep going back. We can also go back to the point where we can even view webcams that are available out on the internet potentially. Now, sometimes webcams are available out on the internet intentionally. They're designed as a live feed, maybe of a tropical beach for people around the world to enjoy. And when you try to follow some of these links sometime, you'll get no response. Other times you might get messages like this: your connection isn't private. So really, it says the certificate authority is invalid. And if I click on Not Secure here in my Microsoft Edge browser, it really says the certificate is not valid. Okay, well, why is that? If we click to show the certificate, the CA root certificate is not trusted. It was issued to a company called Internet Widgets Pty Limited by the same authority. So it's not trusted internationally. So what does that mean? It means a self-certified certificate is being used. The other thing to bear in mind is you don't know if you're trying to connect to something that really, in this case, is a webcam, or if it's a honeypot device that's been set up to track this type of activity from Shodan. We just really have no easy way of knowing that. But at any rate, there you have it. The Shodan.io website is a centralized list of what might potentially be vulnerable devices. We want to make sure that we don't follow through and connect without explicit permission provided by the system owners. We know that smartphones are widely in use by individual persons as well as by business people. And so it's important to make sure that we harden smartphones. They're computers that we carry around in our pockets, and potentially they can contain lots of sensitive information. So to get started here, one of the first things that we should consider is disabling things that we don't need. That would include things like network connections. So here on my Android phone, I'm going to slide down from the top, go into my settings, then I'll tap connections. Now, one of the first things I have to think about doing is enabling or disabling Wi-Fi connectivity depending on what my needs are. The same thing would be true for Bluetooth. We might enable Bluetooth, for example, only when we're going to go for a jog and we want to connect our Bluetooth headphones. Otherwise, if we don't need it for anything, it should be turned off. The same is true with NFC tap payment options. We could also enable flight mode to turn off all of those wireless connection items. That's what you would do if you're on an airplane and traveling. If I go all the way down to mobile hotspot and tethering, I can tap on mobile hotspot. This is where I could choose to enable a Wi-Fi hotspot, name and a password to allow other devices to connect to the internet through my device. The next thing I'll do is back out to my settings, and I'm going to scroll down and choose lock screen. Currently, the screen lock type here is set to a PIN, so I have to know the 4-digit PIN if I physically have the phone to unlock it. But there are other options available besides that. Smart lock, for example, we could enable, so that if the device is on us, we could turn on on-body detection, so when the device is with us, it's unlocked. But how does that work? Do I need a chip implanted in my body or something like that? Of course not. All it's doing is really detecting motion. And so if you were to set the phone down and it's motionless for a period of time, then the phone would automatically lock. That's how that works. We could also add a number of trusted places where the device should be unlocked automatically. Or we could add trusted devices that are nearby, which would mean that this device would be unlocked automatically. So we have a number of options related to that. I can also go back into my secure lock settings, where I could enable the phone to be locked automatically after a certain number of seconds of inactivity. I'm just going to go back to my main settings screen and then biometrics and security. This is multi-factor authentication. Because we would have to have the phone, we would have to have a unique characteristic like facial recognition or fingerprints, in addition to physically having the device, so multi-factor authentication. We could also go to security update. We know it's absolutely crucial that we apply updates to all computing devices. So here, I've already got it downloaded so I can choose to install the update now, or I could choose to schedule the install, perhaps in the middle of the night when I'm sleeping. I'm going to go back to my main settings screen. I'm going to scroll all the way down until I get to apps. When we install an app, we're often prompted to specify what access the app has to the device, whether it's a contact list, microphone, the file system, camera, and so on. So we have a number of app permissions that we can set. Here, I'm looking at my Amazon shopping app and the allowed versus the denied permissions. So it's always important to make sure that we have a trustworthy source of apps. Using a centralized mobile device management or MDM solution, we can limit or restrict the use of app stores. So in other words, the company controls which apps get pushed out to mobile devices. We can also prevent sideloading of apps, which means installing apps when you have the source files on a mobile device without going through an app store. So centralized MDM policies then can be used to specify all of these types of hardening options and many more from a centralized location instead of doing the exact same thing over and over and over for each and every smartphone device. A centralized MDM solution can also provide reports on compliance, which devices are compliant with our security policy settings versus which ones are not. A mobile device management or MDM solution is a centralized way to register mobile devices, whether they're laptops, tablets, smartphones, and having them in one central registry where you can then deploy policies to control their configuration, maybe to make sure those mobile devices comply with a security baseline for the organization, or maybe to push out apps or updates for the apps or the mobile device OS. All of that type of thing is possible, essentially, when our mobile devices are centrally inventoried with an MDM. And there are plenty of MDMs out there, one of which is Mirador. So here on the Mirador.com website, I'm going to go ahead and click Get Mirador Free. That opens up a registration page where I'm going to have to fill in an email address and agree to the terms of service and turn on the check mark for I'm not a robot. So I'm going to go ahead and do all those things. So once I've done that, I'm going to go ahead and click Send Activation Link. It then gives me a screen telling me that the instructions were sent to that email address. So the next thing to do, of course, is to open up the email account for that user. Okay, so here in my user mailbox, I'm going to go ahead and open up the email message from Mirador. So it asks me to continue registration by following the link that's provided. So I'm going to go ahead and click that link to continue. So at this point, I need to specify some details like the company name, a password for this Mirador account, and fill in some details related to the country, phone number, and so on. So I'm going to go ahead and fill all of that in. I don't need to fill in a phone number, so I'm going to leave that field blank. It's not required because it doesn't have an asterisk next to the name like some of the other mandatory fields on this web form do. Okay, so having done that, I'm going to go ahead and click Start Now. So what it's going to do is create what Mirador calls a site within which I can then configure device registration. All right, so now that we're signed in and we've got our site created, I now need to basically get some devices enrolled or registered here in my Mirador site. So over on the left under Enrollment, I'm going to choose Android Enterprise. Now from here, we have a couple of options for enrolling Android devices, such as requiring encryption and so on. Now, a lot of these are unavailable because I would have to upgrade my subscription if I wanted to use a lot of these features. So I'm going to go ahead and choose Enroll Device instead over on the left, where I can select from many different platforms. So Android-based, iOS or macOS, Windows, and Windows Phone devices. Here I'm going to choose Android. And I'm going to choose Lite because the Lite enrollment method is recommended if I'm using BYOD, bring your own device. Otherwise, we could use Full if we had company-owned devices that were issued to users. So because I'm BYOD in my particular case, I'm going to choose the Lite enrollment. What it will do is send a notification, basically an invitation to enroll the device to this email address. We could also send that via SMS text message. So I've got the email address of a user whose Android device I want enrolled here. So I'm going to go ahead and choose Send Enrollment Invitation. Now, another option too is, of course, to go to the mobile device itself, for example, to the Google Play Store in the case of the Android platform, install the Mirador client, open it up, and enter the credentials shown here, and then choose Enroll Device. So it says that the enrollment credentials have also been sent to you by email. Let's just go and check our inbox here for that user. So the next thing we have is an Enroll Your Device welcome message from Mirador. And we could choose to enroll the device in case we are actually using email on our device right now where we're reading this. However, I'm going to switch over to my Android phone and we're going to install the Mirador client from the Google Play Store. So here in my Android device, I've gone to the Google Play Store and at the top I've searched for Mirador. So at this point, I'm going to go ahead and tap Install. So we're going to get this software installed, and after I open it up, I can enter the credentials that we were provided to enroll this device with my Mirador site. Okay, so the app is now installed, so I'm going to go ahead and choose Open. And then I'm going to click Continue. And it asks if we want to allow it to access our contacts. I'll choose Allow. Should it be able to make and manage phone calls? Well, depending on how you're going to use the Mirador client will determine if you want that to happen. For that, I'll choose Deny. Should it be able to take pictures and record video? I'll deny that. And should we allow it to access this device's location? I'll say only while we're using the app. Should it be able to access photos, media, and files? Well, if you want the Mirador solution to be able to inventory items on mobile devices, then you would choose Allow, such as inventorying files. Okay, so here we're being asked to enter the credentials. So for example, I'll enter in the provided username and the password. And once I've done that, I'll tap the Enroll Device button. After that, I'm giving this message about the Mirador online client and what's going to happen as I continue activating this device. So deleting the data on this phone, changing the screen lock, setting password rules, and so on. So if I'm happy with that, then I could choose to activate. Now back here on my management station where I'm working with my Mirador site, if I go under management on the left and then select devices, we will have our Samsung Android-based phone that is running Android 10, which is now showing up as being enrolled here in the Mirador client. So once you have enrolled devices, you can then begin to manage them centrally using this MDM solution. Once a mobile device has been registered with a centralized mobile device management solution, you can then manage it on the device itself. So if I open up my apps and open up, in this case, the Mirador client, here I see it's connected to a site called Quick24x7. I have some date and timestamps for when it was last connected, and I can also go into the settings to set things like the query interval, the timing related to that. I can also disable any restrictions by entering a security code from this centralized tool, or I could tap on View Logs at the bottom to view logs on this registered client device. So we have a number of logged items related to synchronizing with the centralized management tool. I could also choose Sync Now. It then says Querying at the top, and then after a few moments, it's connected. So it periodically queries our centralized MDM tool to retrieve policy configuration changes and that type of thing. From a more centralized administrative view, we can also log into our MDM or mobile device management solution, where we can manage a multitude of registered devices or configure device enrollment. So once I've signed in, I can either create a new site and register devices with it, or I can connect to an existing site, which I have over here on the left, and I'll click on it. Now, when I do that, I can then click on Dashboard on the left to get an overall view of how my devices are doing and what I have out there. So I have a dashboard chart, devices by platform. I have an Android device. Its status is that it's online. It is active. However, it is unknown whether or not the passcode has been set, so I must not have deployed a configuration policy to have determined that. And as I scroll further down, I have options as to whether the device location is available or not, the number of enrollments by month for my mobile devices, and also, in this case, the operator network, which is being shown as TELUS Mobility, and the device manufacturer, which is being shown here as Samsung. So a lot of rich information. Now, if I click Reports on the left, if I upgraded the business plan for this particular MDM tool, I'll be able to run a number of professional-looking reports based on what this MDM tool knows about my mobile devices. Under Enrollment on the left, I could choose Android Enterprise, and we could configure some enrollment settings. There's a QR code here that can be scanned for enrolling devices, and we might require encryption for devices. We might have to have them configured with a certain language or time zone, and we can configure a number of other items that we might want to have enabled. Under Management on the left, if I click on Devices, I'll have a list of the devices that are currently registered. The green circle indicates that it is active. So I have details here like the product name. It's a Samsung Android phone. The software version is Android 10. We have the user account information and when it last connected or reported to this centralized MDM tool. And I can turn on the check mark for that device in the box on the left, and it lights up the menu up at the top where I can go under Add. Well, we've already got the device enrolled. We don't need to do that. But under Actions, I can force a synchronization immediately. I can update the client software on the mobile device that is being used to connect here to the MDM solution. I can even add tagging information if I want to add some metadata, like a cost center, that kind of thing. I'm going to cancel out of that though. We can also do a number of other things. So if I go to deploy, we can deploy a configuration profile. Now, configuration profiles are available over on the left under Management. There are some default configuration profiles for Windows phones, Android phones, iOS, such as the minimum number of digits in a passcode. But we can also click Add and add other configuration profiles for the selected platform, whether it be Android, iOS, macOS, Windows Phone. And it can be related to VPN connections, device encryption, location tracking, Wi-Fi settings, passcodes, all of that stuff. So if I go back and look at my devices, we can select one or more devices, and from the Deploy menu, we can choose to deploy a configuration profile. So that's important because we're doing it centrally and it could potentially affect many, many devices instead of configuring those devices individually with the same settings. If I turn on the check mark again for my managed device, we can also go to Lifecycle and unenroll the device if it no longer needs to be managed centrally here, or retire it. Under Security, we can choose to lock the device. We can reach out to it and play an alarm sound. We can also enable lost mode. When we enable lost mode, we can specify details like a message that will appear on the device along with a phone number and a footnote. Also, having selected that item again under Security, we can also choose to remotely wipe the device. If the device is lost or stolen, wiping it makes sure that any sensitive information is not retrievable by whoever has the phone in their possession currently. On the left under Management, we can also deploy specific applications. We can work with file management. We can deploy files. We can also get an inventory of files on remote managed devices. We can work with patch management. So this is the idea of a centralized mobile device management or MDM solution. You have one-stop shopping where once devices are enrolled, you can manage them centrally. The National Institute of Standards and Technology, NIST, publishes numerous very interesting and useful publications. They're often referred to as special publications or SPs. Now, Special Publication 800-82 is related to industrial control systems and security. Note that we are told at the top of the webpage that it is superseded by Rev 1, Revision 1. So this is how we can get to and download these documents. Now, I've already downloaded this, so let's go ahead and take a look at what's inside this document. This is a very interesting document. It's related to industrial control security. It's actually entitled Guide to Industrial Control Systems, or ICS Security. So related to SCADA systems, distributed control systems, and how to protect PLCs, or programmable logic controllers. So as we go down through this documentation, we have quite a few references on what we can do to protect our environment. So for example, the section that discusses threats does make a reference that it could be adversarial sources. This has happened in the past where you might have a nation state that might try to infect an industrial control system network, such as in a nuclear power plant or a uranium enrichment plant, if they think that another adversary is trying to enrich uranium for the creation of nuclear weapons. This kind of stuff has happened. So hostile governments, it could be terrorist groups, industrial spies, disgruntled employees, malicious intruders. So it could come from the outside, or the threat might come from the inside. So we want to be very careful about our organizational or government agency security policies and making sure that they are very strict in limiting access to industrial control network environments, and that the people that do have access have had thorough background checks run against them. Further down, we have section 3.3.2, which focuses on platform vulnerabilities. Whether it's flaws that are inherently built into software tools like monitoring stations in an industrial control environment, or it could be flaws built into the firmware controllers that are used by PLCs. It could be a misconfiguration. It could be poor maintenance, meaning updates might not have been applied. Or we might have an industrial control network that is exposed to the internet directly. It has happened, instead of being air-gapped from a hardening standpoint. Down further below, we have lack of adequate password policy as being a vulnerability. So not using complex passwords, perhaps not using multi-factor authentication, or the use of the same password for multiple systems. All of this is a major vulnerability that can have catastrophic effects in your industrial control environment. Further down, when we get to section 3.5, where it discusses possible incident scenarios, there's some really interesting stuff here. I'm specifically interested in the third bullet point under section 3.5, which states that one possible incident scenario is false information being sent to control system operators, either to disguise unauthorized changes or to initiate inappropriate actions by system operators. If that sounds familiar, it might be because you remember the old Stuxnet attack, which was designed to report false information back to stations that controlled centrifuges for uranium enrichment, to the point where the malware would report back that the centrifuge was not spinning at the rate that it really was. And so operators would unwittingly spin the centrifuges faster and faster and faster and faster to the point where it would destroy the device. Now, there are many theories that state that this might have been a nation-state-sponsored attack, such as from Israel and the United States working together to derail Iran's uranium enrichment program. But there's no necessarily definitive proof that says this is true, but it is out there as a theory. And it really did happen in sense of having this worm that propagated on a network focused on specific types of PLCs to do just that, to report false information to operator stations. Now, if that's an air-gapped network, then the only way that that type of a worm would have gotten on that network would have been through removable media, like a USB thumb drive. A PLC, or a programmable logic controller, comes in many different forms. Many different vendors create these devices. We've got a couple of pictures here based on my search of a Siemens S7 PLC. And if we go down even further, it explains a little bit about it. For example, what is the S7 protocol for Siemens PLCs? It enables the connection of S7 automation devices without any communication partner. So the S7 PLC then can be used to make a connection to control many different types of industrial devices, because PLCs have multiple connection inputs, whether it's for manufacturing robotics or controlling sensors, valves, pressure gauges, thermometers, any of those types of things. Having said that, here on the SourceForge.net page, the project page, I've searched up Snap 7, where I am told that this is a 32 and 64-bit multi-platform Ethernet S7 PLC communication suite. It's an emulator suite. Now, I might use this as a honeypot if I want to make it look like I've got some PLCs running on my network, or I might want to use it just for testing purposes if I want to be able to program this type of PLC and I want to kind of observe the behavior without doing it against the real thing. Either way, I can download this item here in the GUI, but what I want to do is use Ubuntu Linux at the command line to download this using the wget command, and then we're going to go ahead and move a few files around after we extract the download, and then actually start an S7 PLC server emulator. Okay, so how does this craziness all begin? Well, here in Ubuntu Linux, I'm going to run wget, and I've pasted in the download URL, and I've specifically put that in single quotation marks. So I'm going to go ahead and press enter, and it looks like it's in the midst of downloading it. Not a very big download. So if I clear the screen with clear and type ls, I've got my download. It's just called download. So what I want to do is extract that. And I'm going to use the 7ZA command, space lowercase x for extract, and the name of my download, as we see here, is simply download. Okay, so it's going to extract that. Let's clear the screen and see what it did with ls. Okay, it made a Snap 7 folder or directory. So I'm going to change directory into that. And actually, if I do an ls, here it is, we've got a build directory. What we're going to be doing is just basically compiling this from source so we can run it. And it's basically this emulator is a Python app. So I'm going to go into the build / let's say Unix directory. What do we have in here? Aha. This is what we want. We've got a bunch of files that end with .mk. These are make files. So that's perfect, because what I'm going to do is run make-f for file, and I want the x86_64_linux.make file. So I'm going to go ahead and press enter. Okay, so let's see. It looks like it's got all kinds of stuff that's been done here. So let's change directory ... to go back one level, and then change directory into bin. And then I'm going to change directory into x86_64-linux, if I can just type this in correctly. Okay, what do we have in here? Well, this is the file that we need to copy to a different location. a library file, libsnap7.so. So we need that module elsewhere. So I'm going to copy it using the sudo to run elevated commands, sudo cp for copy. I want to copy that libsnap file to /usr, that's Unix System Resources, /lib. Okay, now we're ready to rock and roll. That means we can start our Python interpreter. So sudo python 3. The first thing I want to do now that I've copied that library file to where it needs to be is I'm going to import it. It's called snap7. So import snap7. So far, so good. Now I can start calling upon the actual emulator commands. And I'll do that with s7 server equals snap7.server. In this case, the last occurrence here of server, it has an uppercase S. And open and close parentheses, calling on a function or a method. Next thing, s7 server.create, open and close parentheses, again calling on a function. So far so good, we're not getting errors. s7 server.start. Let's start our S7 PLC emulator server. Okay, this is cool. It seems like it's working, but we can verify it with the, let's see, s7 server.status, open and close parentheses. No, okay, hang on a second. That would be s7 server.get underscore status, open and close parentheses. That's the one. And now we have a return listing that tells us that our S7 PLC emulator server is now in a running state. So again, why would we bother doing all this craziness? Because we want to have a sample S7 PLC server up and running, maybe to experiment with maybe some code that we want to program it with, or we want to set up a honeypot that makes it look like we've got PLCs on an industrial control type of network. What you're looking at here in Ubuntu Linux is the fact that I have a Siemens S7 server PLC emulator up and running. I've run the get status function against it, and it returns that the server is running. I've done this numerous times, so we know that our S7 PLC server emulator is indeed available. Now, what we're going to do in this example is we are going to exploit this remotely over the network from another Linux host. Essentially, we're going to use Kali Linux with Metasploit, and what we're going to do is we are going to stop this PLC emulator. Now, the real-life ramifications of stopping a PLC without authorization really depends on what that PLC is doing. PLCs have multiple connections where they could be linked to robotics used in a manufacturing environment, such as in an assembly line, or it might be used to read settings from gauges or other types of devices or sensors. And so it could have serious ramifications. So here we're just going to do it from an educational standpoint. We would never run this kind of an exploit against something without full express written consent from the system's owner, such as during a pen test. Okay, so we're going to switch over to Kali Linux now. All right, how do we reach out over the network and stop that thing, given that we can get on that same network in the first place? First of all, is that device responding on the network? I happen to know the IP, so 192.168.4.95, and indeed it is up and running. Now, of course, we could run an Nmap scan if we wanted to discover what was on the network and what services might actually be in a listening state. Here in Kali, I'm going to run search exploit, that's a command, and in single quotes, I'm going to tell it I'm looking for capital S7. Are there any exploits related to S7? And there's one here of particular interest for a Siemens Symantec S7 300-400, where I can remotely start and stop the CPU on the device. And the file for that is under hardware, remote, and the file is called 19831.rb. Okay, so that's interesting. Bear that file name in mind for a few moments. Now, the full path is /usr/share/exploitdb/exploits/hardware/remote. And then, of course, the file is called 19831.rb. That's what we just looked at. So here in the exploit definition, as we get down far enough, we get to the point where we have a listing for the stop CPU packet. And as we go further and further down, after that stops the PLC, then we're checking if the CPU has been stopped or not. Okay, so that's interesting. So I'm going to press Q to quit out of that, and we're just going to clear the screen. So the next thing I want to do then, in my home directory, which I am in, pwd, print working directory, return/home/Kali, is I want to make a directory structure. So -P to make an entire structure. I'm going to start with a hidden directory called .msf, Metasploit Framework 4, /modules, /auxiliary, let's say, /hardware, /SCADA. Okay, so we've got that subdirectory structure created, so let's change directory into it. So the ms4 /modules, /auxiliary, hardware, SCADA. Okay, so we're now in that subdirectory structure. What I want to do is I want to copy that RB file we were looking at into this location. So I'm copying /, let's see, usr/share /exploit db /exploit /hardware /remote, and the file is 19831.rb, and I'm just going to copy that into .current directory. And if we do clear screen, a clear, and then an ls, indeed we have the file shown here. Now the next thing I want to do is use the nano editor to open up that file, because there's a change that I want to make. So if I scroll down here, what I really want to look at is this instruction here, opint.new, which the mode is currently set to false. So what I want to do is go to the end of that line where we have comma false, and what I really want to do here is I want to basically set that to true. In other words, a value of 1. So I want to put the CPU into stop mode. So I'm going to go ahead and I'm going to press Control X. It asks me to save the modified buffer. I'll type in the letter Y. It asks me for the file name to write to, which I'll just press enter to accept the default file name. And now that part is done. So the next thing I'm going to do is start a Wireshark packet capture within Kali Linux before we actually run the exploit. Now specifically, this is Kali Linux 2020.4. Sometimes different versions of Kali will yield different results, so just bear that in mind. So from the menu, what I really want to do is go down to sniffing and spoofing, and I'm going to fire up Wireshark. Of course, it wants me to enter my Kali password, which by default is Kali. Okay, Wireshark has fired up. So what I want to do is I want to monitor traffic, let's say, on the Ethernet 0 interface. We could also select any interface if we wanted to look at all of them, but I'm just going to double click on Ethernet 0, so it's now in a capturing state. I've got a separate PuTTY session to that same Kali Linux host where I'm going to run MSF console to start the Metasploit framework console environment. So I'm going to go ahead and type search Siemens. And what I'm interested in is our Simatic S7 300-400 CPU start-stop module. And so up here, the path we see is auxiliary /hardware SCADA 19831. So I'm going to go ahead and copy that. And what I want to do is use that. So I'm going to type in use, and I'm going to paste in that path. So now we are using that exploit. So now what do we do? Well, if I type show info, I get some details about this exploit, including the name of some of the variables that I can specify, like our hosts, the target host, or could be more than one. I could specify a range through a CIDR IP address notation. However, what I'm going to do here is I'm going to set our hosts, that's the variable I just saw by running show info, and I know that the remote IP of my PLC emulator is 192.168.4.95. That's my target that from a malicious standpoint or testing standpoint, I'm going to quote unquote attack. Okay, that's been set. Now we simply run exploit. So it's attempting to send the CPU stop packet. So it looks like it has executed our exploit. So why don't we see if the S7 emulator is still running back in Ubuntu Linux. So back here in Ubuntu, remember previously we had run the get_status command, or we saw the result of that output, and it said that the server was running. Let's do that again now. So when we do that, and I've run it a couple of times just to verify, we used to have an S7 CPU status run, but now we're getting an S7 CPU status stop return result. The PLC is now stopped. That's a result of running our exploit from Kali Linux to stop it. Back here in Kali Linux, remember I had started up a Wireshark packet capture on the ETH0 interface, so I've stopped that. I'm going to filter it for S7COM, the S7 communication protocol. And sure enough, we have a lot of traffic between our Kali Linux attacking station at 192.168.4.108, destined for the target 192.168.4.95. And as we look at the packet payload, as we drill down, we have some information related to the S7 communication protocol. Capturing network traffic periodically is not a bad idea. You might even schedule it because it could be suspicious and could set alarms when we have a number of packets coming from the same host to a PLC over S7COM that aren't expected. If we normally don't have that kind of traffic from that source IP, then we might be triggered to think that something suspicious is happening on the network. Rapid7 provides a free vulnerable web app in the form of a virtual machine that you can download. This virtual machine is called Metasploitable. So you can get this for free on the internet. You just have to fill out a form to download it. It is a VMware virtual machine. So when you fire it up, it asks for login, which is MSF, that's Metasploit Framework Admin, and that is also the password. And if I were to run ifconfig, that would reveal the IP address, in this case 192.168.4.124. So that's what I'm going to hit in a web browser just to see that we've got a web app listening at that host. So yes, in my web browser, when I navigate to that IP address, indeed, we do have a web application. We see the title here, Metasploitable 2. So excellent, it's up and running. We're good to go to test it for vulnerabilities. So here in Kali, what I'm going to do is open up the menu for tools, and I'm interested in web application analysis. And on the right, I'm going to choose ZAP. That's the OWASP Z attack proxy tool. Now, it normally checks to see if there are any newer updates, and if there are any, I would recommend that you make sure you install the updates. It'll provide the instructions for you. You want to make sure you have the latest vulnerabilities available that you can test for. So I'm asked if I want to persist my ZAP session so it can be remembered multiple times when I invoke it. I don't want to do that, so I'll leave it on no, and I'll click Start. Now, what I want to do in here is specify the web app that I want to begin testing for vulnerabilities. So I'm going to choose Automated Scan, and let's say here we're going to leave it on Firefox headless. That's how we're going to do the attack. It's going to be using an AJAX spider, and here I'm going to put in the URL, which in this case is just the IP 192.168.4.124. So it's going to use the browser I select here in headless mode, no GUI. It's going to be an AJAX spider. So at this point, I'm going to click the attack button. So it's attempting to access the URL. It's opened up this AJAX spider tab down below, and it's starting to discover everything on that web application. Now, depending on the web application, we'll determine how long this actually takes. But now's probably a good time to get up and make a coffee. What we want to do is keep our eye open for the Alerts tab to see what it's discovering that might potentially be a vulnerability in our web application. Okay, so now that the scan has completed, under the Active Scan tab, we have a number of entries, essentially a record of what was done when testing our web application. If we go to the Alerts button up at the top, then in this case, it's telling us we have 19 discovered alerts after it's had a chance to scan that web app. If we expand that section, we have a cross-site scripting alert. And if I drill down into that, we can click on the specific URL that was used to test that. And what it looks like it's trying to do is include some JavaScript, calling upon the JavaScript alert function within a URL or a field. So as I scroll down, I have the detailed attack that was used to succeed with cross-site scripting, which really means, remember, that an attacker can inject executable malicious code, normally through JavaScript, into a web app that isn't properly validating what users put, for example, into form fields. So we know that that is a big problem with this application. Then we have cross-site scripting again. Next, we have SQL injection attacks. Again, if I click on one of those tests, then we get a sample down below about what might be used by passing Boolean conditions like 1 equals 1 and then retrieving every record within a database. Then we've got application error disclosures. Usually that means that there's too much information being returned by an error or a warning message. Directory browsing is possible. Directory browsing means that it's possible for an attacker to be able to navigate the file system on a specific web application. That might be intentional, but at least it's alerting us to the fact that that is happening. Up above in the alert section on the left, if I actually look at path traversal, this is specifically an attack that definitely gains access to files that should not be accessible through the web app. For example, looks like we've got a URL here that's trying to get into the etc password file in Linux. That is the file that contains user account information. So just for fun, why don't we go ahead and copy that URL, and let's go ahead and test it in a web browser. So maybe I'll just Firefox here really quick so we could see what that would look like. So if I were to paste in, for example, that URL, then indeed in the web app, it has actually returned the contents of the /etc/password file, which incidentally does not contain Linux hashed passwords. That's in the shadow file, but still nonetheless, this is not information that should be accessible through a web app interface. So as we scroll down through the alerts on the left, we can learn more about what the problem is with this web application, and there are quite a few little issues that need to be addressed. Now, the great thing about using the OWASP Zap tool is that we can also generate a report and hand it off to the developer or the development team or a project manager, whoever it is that is responsible for this web app, so they can begin to address the issues. So if I go to the report menu, I can choose to generate an HTML report. Now, how about we call this report1.html? It'll be in the local documents folder for the Kali Linux user, so that if we were to minimize a lot of these screens, then we'd be able to get to our scanning report, which is shown right here. So once we look at our scanning report, we could start to learn about where those problems lie. We're really looking at the same information that we saw in the OWASP Zap interface. The difference is that it's a nice formatted HTML report with all of the problems that were discovered in that application. Incidentally, here in the OWASP Zap tool, note that under the Tools menu, we can also go to Fuzz. I'll choose HTTP fuzzing, and then I'll select our web app. From here, I have the ability to actually add different types of fuzz tests, which is normally used to send unanticipated or random data to a web app to observe its behavior, to make sure it doesn't disclose anything sensitive, and to make sure that it isn't easily crashed. Logging is a very important part of monitoring so that we can detect security incidents and respond as quickly as possible. In Linux, we can use remote log forwarding so that instead of having to view logs in each individual Linux host, we have a centralized host where logs are sent to that we would then instead connect to. That's also beneficial because if individual hosts are compromised and their logs are cleared, we have a copy of that log information elsewhere. So with remote log forwarding, you can forward all log information to a central host, or you can filter out which log messages that you want to forward along. Here on my Linux host, which I'm going to call the logging host, this is going to be the central server in our example that will receive log messages from other Linux hosts. So I need to make some configuration changes. I'll start using the sudo command because some of these commands require elevated privileges. I'm going to use the nano text editor to open up /etc/r syslog.conf. What I want to do in here is make sure I uncomment the lines for UDP and TCP reception of log information from other hosts. Now you don't have to do both. You can do one or the other, but notice that the default port number here is 514. Okay, so having done that, I'll press Control X, and I'm going to type in the letter Y for yes. I'll press Enter to write to the file, and it's done. Now, at that point, we are now ready to receive remote syslog information on TCP and UDP ports 514. So let's say on this same central host, I would run sudo netstat to show the status of network connections and port numbers and so on. And I'm going to pass it a bunch of command line parameters here because specifically I want to look for a port number that is currently being listened on. And I'm going to pipe that to grep, and I'm going to look for our syslog. Now we don't get anything returned because we've made the configuration change, but we've not restarted the daemon. So I'm going to run sudo service our syslog and restart. And now at this point, if I just use the up arrow key and let's go back up to our netstat command, we can now see that this server now has some listening ports for 514. Okay, so this part is done. We're going to switch over to a different Linux host now and configure it to forward log messages to this one that we've just enabled logging on. Now, what we should do before we leave this server is get its IP address. So I'm going to type ifconfig so we can do that because we're going to need to specify where we want to send log messages to. And I can see the IP here is 172.31.88.210. So we want to make sure that there's no firewalls blocking connectivity over port 514, otherwise this won't work. So that's good. Okay, let's go back to our other server now. So back on my first Linux host where I'm going to forward log messages to the centralized host, I'm going to run sudo nano against /etc/rsyslog.conf, just like we did on our centralized logging host. But what's different here is I don't need to enable reception on port 514. This is not the centralized logging host. I'm just going to go to the very bottom and I'm going to tell it that I want to send all types of messages. Now the first asterisk would be from a specific subsystem, because if I go up here, notice we can specify, for example, mail messages. Mail.star would be all types of messages related to the mail subsystem, or all messages related to cron. If I want to send everything, then I could put star.star. All facilities, as they call them, are all sources and all types of messages. And I'm going to put in an @ symbol, and I'm going to specify the IP address of our centralized logging host. Now, we saw that on the previous Linux host when we ran ifconfig. The IP is 172.31.88.210. That's all we need to do on this host, assuming that's what we want enabled. I want all messages going there. So I'm going to press Control X, type in the letter Y, press Enter. And of course, just like on our centralized logging host, to put that into motion, we need to restart the rsyslog daemon or service. So sudo service rsyslog, and let's just go ahead and tell it restart, and that's it. Okay, so the next thing I'll do on my initial source Linux server that is generating log messages is I'm going to force a log message using the logger command. And it's going to be hello world from Linux. I'm going to put that message in quotes, and I'm going to press enter. So I am manually sending a specific log entry, and I can view that on this host itself using the tail command, which shows me the last few lines in a text file. So on this host, I've run sudo tail /var/log/messages, the system log file, and I can see here I've got my hello world from Linux. But did that get sent over the network over port 514 to our centralized logging host? Well, let's switch over to it and let's take a peek. So we're back here on our logging host where we can see it's listening on port 514. I'm going to run the same command we just did a moment ago, sudo tail /var/log/messages. Now I don't see the message here, but bear in mind that the tail commands only show me the last 10 messages. So there might have been a lot of activity. We're just simply not seeing it. So instead, why don't we do this? Let's run sudo cat to show the contents of /var log messages. We'll pipe that to the grep line filter, and why don't we just look for the word hello? I'll just have to make sure I put in the correct file name here. It's messages, not message. And indeed, we can see that we have the hello world from Linux message that was generated on the other Linux host, and it was sent through centralized logging to this one. Log fatigue. It happens to the best cybersecurity analysts. The idea is that we need to be able to find relevant, pertinent information within log files, but we want to be able to filter out all the white noise. So what we're going to be doing here is analyzing log information, log entries on a Windows system, but we're also going to take a look at how to filter things out so that you don't waste your time looking at things that don't matter. So here in Windows 10, I've gone to the Windows Event Viewer on the local machine, although notice I can right-click on that and choose Connect to another computer. So a technician then can reach out over the network if it's been configured, if it's allowed, and firewall rules don't prevent it. They can reach out over the network and view event log entries for remote network hosts running the Windows operating system. Now, if I expand Windows logs, there are a couple of standard items here. The application log, the security log, which is used for any audit configurations. Here, it's for user account management, but we could also choose to audit the success or failure of people trying to access files in the file system. And the results would show up here in the Windows security log on the host where those files might exist. The main system log is simply called System. And we can see the level, whether it's informational or some kind of a critical error, the date and time of the logged entry, the source of it, the event ID, which indicates what happened. So if we've got some kind of a hard disk failure of a specific type, it will always generate the same event ID, and you can filter or search on that. See the category. Of course, when you select a log entry, you can see the details down below. Under General, you have a lot of information, like the computer where that occurred, as well as further details. So you can view it in XML, for example, if you want to take a look at the data that way or copy it and export it to another system. Now, as we go further down this list manually, we can see, for instance, that we have, in this case, a couple of errors, and it's date and time stamped. What's that about? Well, if we go back under General, having selected that logged entry, looks like it's for a wireless network interface. It says, has determined that the network adapter is not functioning properly. Well, that's not good. Now, other than manually scrolling through looking for this, for example, in the system log, we can also right-click on the system log and we can filter it. What I might say is, look, all I want to see is critical and error items. Don't care about anything else. We could specify event ID numbers, certain keywords, usernames, computer names. I'm just going to leave it on critical and error, and I'll click OK. Now, that is all that I am looking at. If I scroll right through down all the way to the end, I'm only looking at those types of items that I've filtered out for. Sometimes when you're looking for that proverbial needle in a haystack related to a security incident, you're going to need to filter out the noise so you can just focus on the issue at hand. So I'm going to right-click on System and choose Filter Current Log again and basically turn it off so I'm not filtering any longer. Now, other than filtering, you can also right-click and choose Find and look for something specific within the log. So we can do that as well. Now, over time, you might find it cumbersome to come in and filter on errors or whatnot. So what you could do is build a custom view. I'm going to right-click on Custom Views and choose Create Custom View. Basically, I only want to see critical and error items in one place. And I don't want to have to keep filtering the system log. So I want to filter out critical and error items for specific logs. Let's say the Windows system log, and under Application and Service Logs, maybe I'll also choose under Microsoft Windows, just scroll down here, Cloud Store. So I can select exactly what it is I want to filter out. In other words, the source of those log events. And as usual, as we saw when we were filtering, I can filter by event ID, username, keyword, computer, all that stuff. I'm just going to go ahead and create this. It's going to be called, this custom view is going to be called Nothing But Problems. That's really what it's going to show me. And I'll click OK. There it is, Nothing But Problems. It will always be here in the left-hand navigation panel under Custom Views. And all I'm going to see is problems. We asked for critical and error. That's all we're ever going to see. Naturally, make sure you're always looking at the date and timestamp so you're not taking action on something that occurred 1 year ago. Not that that's not still important, but ideally you will have already dealt with that issue. Now I can also right-click on that item and I have the option of filtering the custom view. So I can even filter it further for specific keywords or computer names or usernames or event IDs. All of this stuff is entirely possible. So it's just really about filtering out the noise and getting to what matters in determining if an incident occurred and then in dealing with the incident response for that item. The importance of monitoring doesn't change whether you're working with on-premises resources or cloud-based resources. In this particular case, we're going to poke around in the Amazon Web Services or AWS Cloud. We're going to focus at looking at some of the logging options related to EC2 instances. In other words, virtual machines running in AWS, followed by taking a look at how to use the centralized CloudWatch monitoring tool to work with things like alert notifications. So to get started, I'm going to go to the EC2 Management Console. I'm going to go to the Instances view, where I can see I've got a couple of instances, one of which is stopped, one of which is running. I'm interested in the running one so I can get some statistics about how it's performing. So when I select an EC2 instance down below, I can go ahead and click on the Monitoring tab to get some details about performance metrics. Now, down below, we can see CPU utilization, and it's graphed, disk reads, disk read operations, disk writes, disk write operations, network traffic in, we can see some spikes there at certain times, network traffic out, and so on. So we can see a number of items that are automatically listed here. It does say no alarms are configured. So this would be another way that we could configure or create an alarm based on EC2 performance. So for example, I could click Create Alarm, and I could specify an SNS topic notification endpoint, in this case an admin's email address. I can take a specific action for the instance, such as recovering it, stopping the instance, terminating or rebooting it, and then I specify what I'm interested in looking at. The default is CPU utilization greater than or equal to a specific percentage, such as 80. So we can configure this type of notification right here while we're monitoring the EC2 instance. Now down below, notice that it's showing, by default, data for the last 1 hour. So I might choose the last 1 week to get a bit of an idea of the overall performance over time related to these listed metrics. I can click on a specific metric if I want to zoom into it. And I can choose the statistic. Am I interested in the average, in this case, CPU utilization over the last week, or the minimum, or the maximum, or the summation of them? So, for example, maybe just the maximum. So I can see here it's listed. So I can do that. The other thing I can do is enable detailed monitoring. If I do that, what I'm doing is getting these metrics at 1-minute frequencies. So if I need to have more up-to-date performance metrics, then I could enable detailed monitoring. I'm going to cancel out of that. So from here then, we have an easy way to look at EC2 instance performance metrics. Now another option is to actually view the virtual machine system log. Now the instance doesn't have to be running. You can still retrieve the last system log if you wish. So if I select an EC2 instance, we can see here it's stopped. I can go to the Actions menu, I can choose Instance Settings, and from here, I can choose Get System Log. And here I can see some detailed logged items about that specific EC2 instance. And this can sometimes be helpful when troubleshooting. CloudWatch is the built-in AWS logging centralized tool where you can configure alarms so that you get notifications when certain types of events occur or when specific thresholds are violated. So to get started here in the console, I'm going to search for CloudWatch, and that will let me launch the CloudWatch console. Now within the console, the first thing I need to do is click on Alarms over on the left in the navigator. Now when I click on Alarms, I can then click the Create Alarm button. We can see that there are no alarms currently configured. So I'll click the Create Alarm button, and I'm going to choose Select Metric. Now down below, I have to select the category that I'm interested in. So whether it's AppStream or the Elastic Load Balancer ELB, and keep scrolling down until I find what I'm interested in getting alarm notifications on. For example, maybe here I'll choose EBS for Elastic Block Store volumes, and I'll choose per volume metrics, and then from here I can select the appropriate metric that I'm specifically interested in. Let's say I'm interested in the volume queue length. Now this one is important when it comes to disk I/O because the more items that are queued up, that means that the disk subsystem is busy and can accommodate those requests immediately. So a smaller amount of items in the volume queue is good for performance. Many items backed up in the queue, not so good for performance. So I'm going to select that metric. Now the next thing I have to do, if I scroll down here, is specify the conditions. So I can use a static threshold type where I specify a threshold value, which I will do, or I can enable anomaly detection. So outside of a specific threshold, I'm just going to choose static. Basically, I'm going to say if we have more than 1,000 items, in this case, queued up for an EBS volume, then I want that to trigger an alarm. So I'll click Next. And I'm going to scroll up here. I want to make sure that I select Alarm. I could also say if the alarm state is just OK, then I want that to be a trigger, or if the alarm state is insufficient data. So those are the three choices for alarm state. In alarm, OK, insufficient data. So if we're in an alarm state, then I want to select either an existing SNS topic for notification or create a new one or use an ARN. So I can specify here any existing SNS topics. I've got one here called topic 1, and that SNS topic, as we can see, has an endpoint here for email, sending it to a group of administrators for notification. Down below, I can also configure potential auto-scaling actions, but that doesn't really apply in this case. So I'm going to go ahead and click Next. The alarm name here, I'm going to specify alarm 1, and I can put in a description. I'll click Next. Now down below, I can see the conditions. So if it's greater than 1,000, this is a review screen, so I can click Edit for each section if I want to make a change, but I don't want to. So the configuration is good. I'm going to go ahead and click Create Alarm, and the alarm now shows up in the view. Now whenever we get any alarm information about alarm 1, it'll show up over here in the left-hand side under alarms. In this case, currently it's insufficient because there's no data. It just got created, so it doesn't have any data yet. It says pending confirmation. Of course, we don't have to come back here and look at it if we've configured an SNS topic notification for email notifications when the threshold is violated. So here on the snort.org page, I can not only download the Snort engine itself, but also download a common rule set, which I'm going to do by clicking on Rules. In this case, I'm going to choose Snort version 2.9 Community Rules. So I'm going to select the tar.gz file and download it. On my computer, I've got 7-zip installed. This is a tool that allows me to extract compressed archives. So what I'm going to do is choose Extract here. And we can see it results in a .tar file, a tape archive file. So I'm going to right-click on it, choose 7-zip, and also choose to extract it here. Finally, we now see a community rules folder where I can see we have a number of files. Now, the largest file here is called community.rules. I'm going to go ahead and open up that text file. And so in this community rules file, we can scroll down and start to read the details, the actual syntax. Now, bear in mind, anything that's got a pound symbol or a hashtag in front of it is a comment. So the first keyword we see here is to generate an alert, such as if you're running Snort and you want an alert written to the console. Then the protocol. Then we can see the source location. The $home_net is a variable that exists inside of the Snort config file. Let's take a look at that for 1 sec. So here what I want to do in my Linux box where I'm going to run Snort is simply run the nano command. We want to take a look at our Snort config. So that's going to be in /etc directory under Snort, and the file is called snort.conf. So let's just kind of scroll down here just a little bit to see what's up. So here we can see we've got a variable. It's called home_net, and it's set to any. But we could put in a specific IP network range if we wanted to. So these can be referred to within rules is the point. So let's just press Control-X to get out of there. Back in our rule, we can see a port number. Now this is from, because notice the direction here of the arrow is from and to. So traffic going to the external network on any port number. We are generating a message, so we decide what this is, that says malware, backdoor, and so on. And the whole thing is within double quotation marks. Then a semicolon. And then we're checking to make sure that we have an established connection. And then we're taking a look in the content of the transmission. Now, depending on what kind of traffic you're looking at, such as if it's IPsec encrypted with DSP, your Snort rules won't be able to see that detailed content. But this is what's in the payload of the transmission. It could be a text string. In this case, we've got other values. And essentially, the next thing we're doing is, as an option, setting a class type. We're setting the Snort ID, and we're setting a revision number. So for example, this is the 14th revision of this particular rule. So you're going to see a lot of rules in here that you can use if you really want to. But we can also build our own rules. So back here in Linux, in addition to using the rules that we can download and keep updating, we can also build our own custom rules, and that really is the power. You can tweak existing rules or create your own to really configure how you want intrusion detection to behave in your environment. So I'm going to go ahead and open up /etc using the nano editor, /snort/rules, and I'm going to open up a file called local.rules where I've already added 3 custom rules. These 3 custom rules are shown here on separate lines. The first rule here is running alert, and I'm interested in basically generating an alert if I see ICMP traffic. So from anywhere, any port going to the home network, that's the variable in the snort.conf file, and any port on the home network. Then the message I want to generate that will show up is ICMP test. I can set a Snort ID number as long as it's over 1 million, which it is, 1,000,001. And then I'm setting revision 1 of this rule, and I can optionally set the class type, in this case to ICMP-event. So the class type is just a predefined Snort category type that can help when you have a lot of rules for organizing them, especially in other tools, visualization tools. Okay, so we're looking for any type of ICMP traffic from anywhere going to the home network, any host and any port number. Although if you're pinging, for example, that doesn't really use a port number anyway, just an ICMP type. The second rule here is using an alert looking at the TCP protocol. And what we're doing is really looking for anything targeting anything on our home network range to port 23. TCP port 23 is used for telnet. We want to know if there are any telnet connection attempts. So it says telnet connection attempt. That's what we've decided we want the message to be. And all I'm doing here is giving it the next Snort ID number, so 2, so 1,000,002 to be specific, and it's revision 1 of my custom rule. And notice the syntax here. Each of these components is separated with the semicolon, and the entire rule, after you've defined the direction and the source and target, is enclosed within opening and closing parentheses. Finally, the last rule here is TCP-based. Really, what's different here is we're looking at content. Content is in the packet payload. I'm looking for the text not found. So then, besides the default Snort community rules, we can also build our own custom rules to determine what we feel is suspicious activity in our environment. After you've configured some Snort IDS rules, the next thing to do is to test them to make sure that they work as the way you intended them to. Now, on my sample vulnerable website here, badstore.net, if I attempt to log in or register, let's say I put in an email, fake@abc.com, and some kind of password. And I'm going to attempt to log in. So it didn't work, user ID and password not found. But let's take a look at a Wireshark packet capture of that transmission. So here in Wireshark, I'm on packet number 1. I'm going to go to Edit, Find Packet. I want to look in the packet details for the text not found. And here it says user ID and password not found, and so on. So basically, when you use content with your Snort rules, you can look at any of this visible content to trigger some kind of action, in this case, an alert. I want it to say, or I want to look for rather, not found. I could get more detailed, but that should be sufficient for this example. Okay, and I want the message to say failed website login for bad store. Excellent. So I'm going to press Control-X to get out of there. Now, the next thing that we want to do is load up Snort so we can see messages on the console. So I'm going to run Snort -A console. Capital A means I want to run Snort in alert mode. Lowercase q for quiet mode. I don't want to see initialization information. I'm going to specify the config file with -C. So the default is /etc/snort and then snort.conf. And finally, -I for interface. I want Snort to listen on interface Ethernet 0 on this host. Now, what's going to happen is it's going to be in alert mode. And if there are any existing rules that will generate alerts, we'll see those. But we want to test our 3 custom rules to see what we get. Okay, so this is good. It shouldn't return anything until it starts seeing traffic that it should be reporting on. So here in Windows, I'm going to run telnet against a host. And it's trying to connect to telnet. Couldn't open it because there's not a telnet daemon there. Back here in Linux, where Snort's running, notice we've got telnet connection attempts showing up. We also have some other ones like universal plug and play or UPnP scans. That's from the default rule set. I didn't create a rule for that in our custom Snort file, but so far it's picking up our telnet connection attempts. Back here on my Windows host, a different host on the network, I'm just going to go ahead and send a ping to that host. Now that host is the one where we're running Snort, but it doesn't have to be if Snort can see all the traffic. So we're getting a reply and ping is happening. Let's go check out the Snort console. All right, so we can see a lot of ICMP ping. It knows it's coming from Windows. And of course, we can see the IP addresses from and to. So this is the station that I initiated the ping from, and it was targeted to what happens to be this host running Snort. But remember, you don't have to create Snort rules and only watch what's happening on the Snort host. That would be crazy and not very flexible. Back here in our badstore.net, let's try to log in with a fake account. Let's call this fake1, and I'll just put in the password being the same thing. And it says user ID not found. Oh, a data breach on a site might have exposed your password. That's fine. That's the Chrome web browser telling me that. That's a good thing. And back here in Linux with Snort, we've got a lot of activity, but we can see if we go far up enough that we've got some failed login attempts, so failed website login for badstore. Back here in the /etc/snort/snort.conf file, I've opened up that file with the nano editor and I've pressed Ctrl-W to search and I've looked for the word output. This determines the format of output files under /var/log/snort. So we'll start with snort.log, and we can see some details related to that. So that's where you're going to be going to look at some of the output aside from the console. The TCP dump command has long been included in Unix and Linux operating systems. TCP dump allows you to capture network traffic, and we all know that monitoring network traffic and then analyzing it can be absolutely crucial for the detection of security incidents. Or you might just use it for performance reasons. The network seems congested and is being very slow, so capturing traffic and analyzing it can also shed light on why that might be happening. So here in Kali Linux, I'm going to start by typing ifconfig. One of the reasons I'm doing this is to point out which interfaces I have available to capture on. In this case, ETH0, ETH0, my Ethernet wired network interface. So what I'm going to do then is start with the basics. I'm going to run TCP dump. And I'm going to specify my interface -I, lowercase I, ETH0. Now, if I'm not logged in as root, I'm going to get a message that states, listen, you don't have permissions to do this. No problem. Let's clear the screen, use the up arrow key to bring up that command, and let's put sudo in front of it to run this with elevated privileges. So we'll have to supply the password for the user that we're currently logged in as. Well, the username is Kali, and so is the password. So at this point, we can see it is capturing all of the network traffic that is visible to this particular host. Now, it looks like there's an awful lot of SSH traffic because I'm actually SSH'd here using the putty tool into my Kali Linux host. I'm just going to press Ctrl-C to stop that capture. So that's one way to work with that. But now what I want to do is I want to specify TCP dump with my interface of ETH0 2 lowercase n's, capital SX, and then port, I want to look at HTTPS traffic only, so port 443. Now at this point, the only thing I am actually seeing is HTTPS traffic, as evidenced when we see some of the captured traffic destined for port 443. So I'll press Ctrl-C to stop that. Next thing I can do is view detailed information from or to a specific host. Now I'm not going to specify the interface this time. Let's say I want to specify any access to a destination of 192.168.4.1. Now, 192.168.4.1 happens to be my default gateway or my router. So this way I am monitoring traffic that is destined for that. Now, mind you, depending on how this station is plugged into the network will determine what traffic it can see. Remember, if you plug this into a specific switch port, by default, it can only see the traffic or conversations related to this device plugged into that switch port unless you've configured it as a span port, a switched port analyzer port, where all traffic in the switch is copied to that port and thus visible when you're doing this type of thing. So I'm going to press Control-C to get out of that, and we'll clear the screen. So if I actually want to analyze the payload or the contents of packets, I can run TCP dump -c (1) $X. So basically what I'm doing is trying to view the contents, let's say, of ICMP traffic. So here I've got some traffic that is an ICMP echo request. In other words, someone is pinging something. And it looks like we've got a host that's trying to ping our default gateway. So we're able to see the actual payload or the contents in the packet because we asked for it with our TCP dump command line parameters. Let's do some more examples of TCP dump. Let's say I want to capture only port 443 traffic, and what I want to do is write that with -w to a capture file. So I'm going to call this https.cap, and I'll press enter. And notice there are variations on command line syntax. In this case, when I wanted to capture stuff for port 443, I didn't specify any of those other command line parameters. Just be aware that you might see some variations, but if you're not sure what to type in if you're doing it yourself, just go ahead and experiment. So because we're writing out to a file, we shouldn't expect to see any output here on the screen. So I'm going to press Control-C, and we're just going to clear the screen and do an ls. Indeed, we do have an https.cap file. Now, why don't we go into the Kali Linux GUI and try to open that with Wireshark? So here in Kali Linux, I'll go to the menu, and what I want to do is go down to sniffing and spoofing, and I'll choose Wireshark. I will enter the privileged password of Kali. Then here in Wireshark, I'm just going to maximize it and go to File, Open. And I'm going to select Computer over on the left and go back to the root of the drive. I want to go into my Kali Linux user directory. So I'm going to go into Home, Kali, and there's the HTTPS cap file that we generated using TCP dump. Notice that I can open it directly in here if I want to use this particular tool to view it in a little bit more of an easy format than perhaps using -R to read it into standard input on the Linux console. There are plenty of tools out there that will let you capture and then analyze network traffic. Could come in the form of a physical hardware appliance that you plug in-line into the network, so it's got multiple network connections, or you might use software on a device like the built-in TCP dump command in Linux, or what we're going to be focusing on, the free Wireshark GUI tool. So when you capture network traffic, you can capture everything that can be seen by your network interface, whether it's wired or wireless. You could filter that by setting a capture filter. Maybe you're only interested in capturing HTTP traffic. Or you could capture everything and then filter it after the fact. So you can save these as capture files and analyze them at any point in time. There are even online services where you can upload packet capture files and have those online services examine them looking for anomalies. Here in Wireshark, I've already got a specific packet capture opened up. So we can see each line, of course, is a packet. And when we select one of those packets, in the middle, we can see the packet headers. And of course, as we go through and select parts of the packet headers, we can see what's being selected down below to the eventual payload stored within the packet. Now, filtering out this information is going to be important because notice as I scroll through, there's quite a bit of information here. So what we can do then is start applying a display filter at the top in the address bar where it says apply a display filter. And we can start with easy stuff. For example, if I want to only see ARP or Address Resolution Protocol traffic, I could simply type ARP, press enter, and notice that we've now filtered the list to only show us ARP traffic. So we can select any one of those transmissions and we can see in the packet headers, we've got the Ethernet frame with the broadcast of all Fs in hex. That's a broadcast at the MAC address level, layer 2 of the OSI model. And we can see the source MAC address. In parentheses, you see the full hex value of that source MAC address, but the first 3 portions of that hex address identify the vendor, in this case, Motorola. So that's why you've got these 2 variations of the source MAC address. And after that, you can see the Address Resolution Protocol, or ARP, header with some of the details here. Notice there's no IP header. What that means is that ARP is a local area network protocol. It doesn't work across routers. But we can also filter based on other types of traffic. So, for example, if I'm interested in HTTP type of traffic, I could specify that. And now we're filtering the list to only see HTTP communications. So we can see the source and destination IP addresses. Of course, in this case, we know the protocol is HTTP. That's what we filtered on. And then we have a little bit of detail or info about the type of transmission. Of course, if you want to learn more about the transmission, you should be looking in detail at the appropriate packet headers, such as the TCP header, or perhaps the HTTP header, or whatever the case might be, to actually see what's happening. And notice, we can actually see some clear text here. This is not an encrypted transmission. Now, we can also filter on things like addresses. For example, ip.addr, and I could put in a double equal sign. And if I want to filter on a particular IP address, so 192.168.4.24, then I could put that in and press enter. And now I'm filtering only on that IP address, whether it's the source or destination. You can also specify source or destination, but here I've simply specified ip.addr, or address. And again, notice the use of the double equals sign. Now I could take that a step further, because notice here that I've got a lot of transmissions here that are not specifically HTTP. So we can start to put conditions together using the double ampersand. So maybe HTTP. So and HTTP, press enter. So now not only am I filtering on that specific IP address, but also only for HTTP transmissions on the network. So the list is much smaller, as we can see. Now you can also click the expression button over on the far right of the address bar, where you can start to put together your filters. We've got a number of protocols that are listed here. So notice, for example, if I were to choose something, well, it could be anything. Let's say we were to choose the Address Resolution Protocol, or ARP. So why don't we go back up in the list a little bit. There it is, ARP. And here we can see we've got a number of items here. So we can see like the destination hardware MAC address or the target MAC address. If I were to select that, it adds it at the bottom. So ARP.dst for destination.hw_MAC hardware MAC address. And then I can choose whether it's present, whether it equals something, whether it does not equal something, is greater than or less than, contains, matches, and so on. And then I can put in a value. And notice it's constructing it as I click on items in the screen. So let's say I'm going to scroll down here and I'm going to say arp.source. I'm looking at the source MAC address, source hardware MAC address. So let's see, source hardware MAC address right here, sender MAC address. Let's say I want to say not equal to, and I'll just put in a value here. This is a MAC address, so we can see that that is shown. So if I click OK, it'll then add that up here to whatever was up here already. Now, I've actually put that right in the midst of the expression, when really I want that to be the only expression. arp.source hardware MAC address not equal to, and we've got a specific value here. So when I press enter, we can see that we've filtered everything out. Basically, we're seeing any transmissions that do not include the MAC address that is specified here. So of course, I can just click the X over here or delete everything to remove all filters. Now what we can also do, let's see, why don't we filter on HTTP? Let's filter on HTTP, and I've got the first packet selected. We can also go to the Analyze menu and choose Follow TCP Stream. So instead of going through each and every individual packet in that session, it puts it together and makes it a little bit easier to read here. So we can see that there's not much that was encrypted. A lot of it was sent in clear text. Now, I'm going to close out of that. And finally, one of the other things we should know about filtering, let's just remove our filter here, is that we can search. So if I choose Edit, Find Packet, I could choose, for example, the packet details, and I'm not going to turn on case sensitivity, but I'm going to look for a string, in this case, authentication. And I'll click Find. And it's found authentication down here in the payload. So it stopped at that packet. Find again, it goes to the next packet, and so on. So essentially, you can search for things quickly when you've captured network traffic and you're analyzing it, and you can also filter out the things that may not be of interest. Nmap seems to be the industry standard when it comes to network scanning. So to discover which hosts are active on a network, determine which services are running on them, so by checking listening ports, and even for OS fingerprinting. So there's a lot you can do with the Nmap command, and it happens to be built into Kali Linux, which I'm going to use here. So the first thing I'm going to do is type ifconfig to see my own IP address, which is 192.168.4.108. Okay. Having done that, let's run Nmap against ourselves. So 192.168.4.108. Now, the only thing we really see here is that we have TCP port 22 open running an SSH daemon, and that's actually how I'm connected to my Linux host here using the PuTTY remote tool on a Windows station. But let's say we were to start up another service here on our host. Would it get detected with an Nmap scan? Well, the answer, of course, is yes, it would, but let's just make sure that that's true. So I'm going to run sudo to run this with elevated privileges, service NTP, the network time protocol, start. Okay, well, no news is good news, I guess. So let's clear the screen, use the up arrow key, and go back to our original Nmap command. Now, notice it still only shows that we have port 22 SSH open. Where's the NTP port, which is actually UDP port 123? Well, that's part of the issue, is we have to tell it that we want to do a UDP scan. So as an example, let's clear the screen. So to perform a UDP scan, I'm going to run nmap -lowercase s for scan, uppercase U for UDP, and again, I'll scan my own host here. So I'm going to put in my IP address, but it tells me that my scan type requires root privileges. No problem. We clear the screen, use the up arrow key to bring up that command, and we prefix it with sudo to run the command with elevated privileges. And after a moment, it will run just fine. So notice now what we've got is we've got port 123 on UDP showing as being open. So this is our NTP, our Network Time Protocol service that's up and running. NTP is used for time synchronization between devices and hosts on a network. Now that's fine, but can't I view both TCP and UDP ports that are open at the same time? Well, of course. Let's do an nmap, once again prefixed with su-lowercase s, capital U. We'll add a T there, and then we'll add 192.168.4.108. And this time in the output, we have both our SSH port, which is TCP22, and our NTP port, UDP123. Now, this is part of the attacker method when it comes to reconnaissance, learning what is out there on the network and what it's got in a listening state, what kind of services are running. Now, those services can indicate that the organization is using those services. That certainly implies that. But at the same time, it could also be a machine that hasn't been fully hardened where those services are enabled by default and haven't been disabled to reduce the attack surface. But either way, we can figure that stuff out, at least what's up and running, very easily using Nmap. Now, we could also run Nmap against an entire subnet. For example, Nmap 192.168.4.0/22, and I'll press Enter. 22 defines the number of bits in the subnet mask. So before too long, it's finished the scan. So let's scroll back up and see what it did for us. So what it will have done is scanned that entire range to see which hosts are up and running. So we'll get a report for the first host, and we'll see any ports that might be available on that host. Then it repeats. We then get the next host and what's running on it, and so on and so forth. So Nmap can be run against an entire subnet. Now, if we're only looking for a specific port number, we can also do that in conjunction with scanning an entire subnet. So I could run Nmap -P, let's say 53, if I'm looking for DNS servers, and I'm looking for DNS servers on that entire listed subnet. Okay, so let's go back and take a look at the output. So sure enough, what we have is a report specifically for hosts that are up and running that are running DNS servers. So TCP port 53. Of course, it could also be UDP if we did a UDP scan, which is what is listening for client requests. Normally, TCP port 53 on DNS is used for synchronizing DNS domain information or zone data between DNS hosts. So we would be focusing then in this case on those that are not closed, but rather open. Nmap can also do OS fingerprinting, so we can have a sense of what kind of operating system is running on a host that is up on the network. So let's run sudo Nmap dash capital O, now the capital O is for OS fingerprinting, and why don't we point, for example, just even to ourselves in this example, put in our IP address. What it's going to report back is that we are running a variation of a Linux 2.6 kernel, which is correct. So we could modify the IP address, let's say against our default gateway or our router, to try to figure out what kind of an operating system it is running. Okay, so this one reports back it's running a Linux 3.x or 4.x type of kernel, and it's one hop away over the network. Every time you go through a router, that is an additional hop. I'm going to run Nmap with the -D for decoy mode, which allows us to specify fake IP addresses from which it will appear the scan is coming from. So this isn't any less loud of a scan. It's just we're kind of obfuscating where it's coming from. We're actually spoofing it. So I have a comma-separated list of IP addresses that I want it to appear that this scan is being initiated from. So I am capturing this traffic in a Wireshark session. Now here in Wireshark, take a look at some of these source IP addresses. 4.5.6.7, 1.2.3.4. Looks like it's coming from multiple IPs targeting the same host as it begins scanning it. So Nmap then is a popular scanning tool, but its presence can be detected. Capturing network traffic is a great way to analyze what kind of things are flying around your network and whether there's any suspicious activity or not. But if we stop for a second and think, how do we know exactly that there's suspicious activity or that there's malware present? For example, here I've got a packet capture file, a PCAP file. If I open it up using Wireshark, which is a free tool, and I've downloaded and installed it, I can browse through this packet capture. But how do I know exactly, just by looking at all of these individual packet entries, that there's something nefarious going on? It's not always easy to do, especially when you have to filter through hundreds of thousands or even millions of captured packets. So there are plenty of online tools that will allow you to upload a PCAP file, a packet capture file, and these online tools will analyze the communications behavior within that packet capture file to identify anything suspicious, including malware. So one of these online packet analysis tools is apackets.com. We can view analyzed PCAPs submitted by others, or we can upload our own and have it analyzed. Let's just start by viewing analyzed PCAPs. So for instance, I could check a specific packet capture file, and in the overview page, it will give me a breakdown of what it found within that submitted PCAP file. For example, here we have the top traffic sources, but notice that we don't have anything listed for protocols. However, if we were to choose a different packet capture file, because it really depends on what kind of traffic is within it, so let's say I'll just choose a different PCAP, then we do have protocol details. So in this particular packet capture, overwhelmingly the traffic is HTTPS based, and as we scroll down, we'll see the top traffic sources listed by host IP address, and we can click on the left to filter out traffic such as by address resolution protocol or ARP traffic, HTTP traffic, and so on. However, let's analyze our own submitted file. So for that to happen, I'll go back to the apackets homepage, I'll click Upload PCAP File, and I'll choose From Device, and I'm going to upload a malware PCAP file that I have. Once that's done, I'll click the View Report link. So here, it's analyzed my packet capture file, and it's broken down the protocols. So overwhelmingly, we have HTTP traffic at 74%. We see that there is also some HTTPS, SMB, and DNS and DHCP traffic. And as I scroll further down, we get a listing of the top traffic sources. So the most chatty host is at this specific IP address. And if I hover over that part of the pie chart, it'll show me the host that it was connecting to. As I scroll further down, I'll get a listing of any HTTP server types that were detected in that packet capture and web browser types or HTTP user agents, like Internet Explorer. Over on the left, of course, if we wanted to view, let's say, connections between hosts, we would see the listings. So we have a sense of who's talking to who. We can view HTTP details and maybe filter by HTTP put requests versus get requests and so on. We can click servers to see any servers that we're connected to. We can click network so that we get kind of a visual listing of the communications. Now, it can be a little bit overwhelming when you have a lot of captured network traffic. Let's try another online packet capturing analysis tool. This one is the hybrid-analysis.com site, which will actually give us a breakdown of whether or not it discovered malware. So I'm going to go ahead and click in the area where I can specify the PCAP file I'm going to upload, and it's going to be the same one that we had looked at and uploaded in the previous example. Once that's complete, I'm going to go ahead and consent to the terms and conditions, and I'll choose I'm not a robot, and here it wants me to select the squares that have a crosswalk in it, so I'm going to go ahead and do that. And then I'll click Next. And then I'll click Analyze. Okay, so at this point, well, I see a lot of red. That doesn't look good. So, for example, if I look at the Meta Defender listing for this and click on the details link for it, well, a lot of the virus scanners out there didn't detect anything. However, a couple looks like they have detected that this is a Trojan. So some antivirus scanners detected nothing, some detected what appears to be a Trojan. Let's check the virus total details. I'll do the same thing here. Oh yeah, it definitely looks like within that packet capture, we've got some kind of a Trojan that is communicating on the network. And we also have a listing for the specific name of the Trojan, which is going to be important if I want to research this further. Now, if we click the Details tab here, this is kind of cool. If I scroll down and read some of the details, under the interesting HTTP requests, it looks like there's a request to go out and get an executable. There's a couple of them here. That doesn't seem right unless in that packet capture we were specifically, or somebody was specifically and legitimately trying to go out and download these executable files from those websites. But nonetheless, that looks and feels suspicious. As I scroll down further, the Snort Intrusion Detection Alerts section, I can start to expand some of those things, like a network Trojan was detected. Looks like we've got suspicious queries, and again, it looks like it's telling us the Trojans that are probably in action within that packet capture. Now, if I go down under Relations, so that's a tab at the top, I can kind of scroll down and see contacted domains, and looks like we have a lot of potential detections here for Centler.at. So I'm just going to go ahead and copy that. And here on the main virustotal.com page, where I could upload a file for analysis or specify a URL, I'm going to click on URL and paste that one in there. And sure enough, yeah, it looks like this is a malware or suspicious type of URL. However, notice many other antivirus engines do not think that there is a problem with it. Well, this is enough of an issue for me to probably perhaps block connections to that specific DNS domain. So the point then is that there are some great online tools. Many of them are free, where you can specify a URL, a packet capture, or what you suspect might be an infected file of some type, and it will have its own sandbox environment where it can essentially detonate that or look at that URL or open up that file without you having to worry about infecting your own machine. And then it can generate reports based on what you've submitted. The Nessus tool is an example of a vulnerability scanner. So it's a little bit more sophisticated than just a network scanning tool like Nmap, which can identify hosts that are up and running and maybe any services that are running on those hosts. But Nessus takes it a step further because it can get very specific about vulnerabilities within an operating system that are detected. If you configure a credentialed scan where you feed it credentials to sign in to different hosts on the network when it's conducting the scan, it'll give you very detailed reports on what it finds as weaknesses. So you can go to the Tenable.com site to download Nessus and acquire an activation code. I've already done that and installed it locally, so I'm just going to go ahead and sign in using my credentials. I'm currently running a trial edition, so I'm just going to click the X to remove that message in the upper right. And at this point, we can specify a scan. So immediately I can specify a scan target. I'm going to do that, 192.168.4.0/22, 22-bit subnet mask. That's the subnet that this host is connected to. So I'm going to go ahead and submit that scan. After a moment, we can see it's begun to discover hosts on the given subnet range. So I'm going to go ahead and up in the column headers, turn on the check mark to select all the ones that were discovered thus far, and I'm going to choose Run Scan. After a while, we'll see for each discovered network host, it's begun to determine how many vulnerabilities, if any, that there are, and it's still in the midst of running, as we can see here over on the right. Now, blue is of no concern according to the vulnerabilities legend. That's informational. And if I kind of hover over it, we kind of know we have 87% of our vulnerabilities or messages are just informational. We can see the number per host. But what concerns me is that we've got some vulnerabilities here showing up as being medium, according to the legend, for the hosts. Now, I'm going to click on that for a particular host to jump into it. It looks like right away we've got SSL issues related to that particular host. So I'm going to click to open that up. What are those issues? Well, we've got 3 medium and then some informational. SSL certificate cannot be trusted. So if we click on that, that usually means it's a self-certified certificate. Okay, well, that's okay. Depending on what our environment is, we might have configured a trusted root key on all devices so that it would be trusted. The other thing we can do here, I'll just go back to my scans and my basic network scan, just to get back here. We can also actually click directly on the host to get a list of everything about that host. For example, I can see it's running the Linux kernel, and also I can see any type of items that it's discovered. So it's discovered some items running on that. So it's discovered that there are SSL and TLS versions that are supported. It knows that the Nessus scanner is installed on it. So that would be the host we're sitting at right here that was discovered on the network. So we can see some of that also shown here. Now, when we go back to our scans, let's say I go back to my basic network scan, we can also just view all of the vulnerabilities at the top by clicking the Vulnerabilities tab. This way, that's what we're focusing on. So for example, I've got multiple DNS issues, 12 instances under count, and if we click on it, we can also see that, okay, it looks like we've got them broken up now into the count per DNS issue. I'm interested not necessarily in just these informational items, but more so in things that are problematic, like medium level threats. So DNS server cache snooping, that's not good. I'm going to click on that, and we can read a little bit about what that means, but more importantly, at the very bottom, we can see the port number. So UDP port 53, it's a DNS server accepting DNS client queries, and we can see the IP addresses of the discovered hosts where that's an issue. So we can start to remediate or solve that problem because we know the identity of the hosts where that problem exists. Now, the thing to remember about vulnerability scanning is that it's getting very in-depth on a machine, and it will be checking specific software on the machine and versions and known vulnerabilities. And to be up to date with that, it needs to have some software updates applied. So if I go to Settings, Software Updates, Update All Components is set to occur here daily. Back here to Scans, if we click the New Scan button, we get to select from a number of different templates. For example, if I want to scan for WannaCry ransomware instances, then I could select that and fill out the details. But notice that we can also specify whether we want to have a credentialed versus a non-credentialed scan. Depends on what your intent is. If we want to be able to reach out across the network, maybe using a standard admin set of creds that work on all devices, then we could specify that here. And there's no question that this scan will be much more thorough if that's the intent. The intent is to see what vulnerabilities could be detected by malicious users that don't have that information, then you might go with a non-credentialed scan. You can download and run the Metasploit framework on a number of different platforms. If you're using Kali Linux, well, Metasploit is already included automatically for your convenience. And the Metasploit framework is an important penetration tester's tools. It's got a number of different payloads and exploits that we can run against vulnerable hosts to try to exploit those vulnerabilities. But of course, we only do this if we are conducting a pen test and we have written approval to do it against those systems, or if we're just playing around and learning and using it against systems that we own. So in other words, don't use the Metasploit framework against systems that you don't own or have the right to run pen tests against. So here in Kali Linux, I'll type in MSF console to get started. And after a moment, we can see that we've started the MSF console as evidenced by our command prompt. It says MSF5 as opposed to being in a regular Linux shell. We can also see the version of Metasploit listed here at the top, along with the number of exploits and payloads and encoders and so on. So I'm going to go ahead and type clear to clear the screen. We're going to do an ls of the /usr/share/metasploit-framework. And then we're going to go further within that and look at the modules, so /modules. So when I press enter, notice here that we can see there are subdirectories for auxiliary, encoders, evasion, exploits, nops, payloads, post, a lot of stuff here. So for example, if I were to go into the exploits location, so let's bring up the previous command with the up arrow key. Let's change ls to cd just for fun, so we can change directory into one of these things. And let's go into the exploits location. I'll do an ls. Now we can see we've got categories here, such as for Android and for Apple, iOS, for BSD, Unix, for Windows. Well, let's go into Windows. I'm going to change directory to Windows. We'll do an ls in here. And then we can see it's organized by the specific category, whether it's antivirus, backdoor, email, HTTP, and so on. So the list goes on and on and on. So this is where the file system stuff really does show up. Now I can use the back command to keep going back multiple levels once I've navigated into a specific exploit location. So for example, let's say I were to type use exploit /windows/smb/psexec. So once I do that, notice that the command prompt changes. I'll clear the screen here so we can see that we're in that location for that exploit. And this is where if I were to type back, it would take me back to where we were before we actually started that. However, I'm going to use the up arrow key to bring that back up for a moment. Now you would use an exploit because you want to start configuring it and then running that exploit to test a vulnerability to actually see if it's exploitable. Now when you're in an exploit, you can type show options to see what can be set. These are a lot of variables, such as remote hosts, the remote port number, the service description, the share name, the SMB password, SMB username, and so on. We can also, if I just clear the screen, type show payloads. Now these payloads will be specific to working with Windows SMB PSexec. So we can see there are a lot of payloads here that can be executed, such as injection types of attacks against VNC, and so on. So there's a lot that's available in here. So I'm going to go ahead and use a payload. Let's say use payload /windows/shell_bind_TCP. So you kind of have to know what these things are called, but you can figure that out by typing in these commands to learn about which ones are available. So I'm going to clear the screen to do that. So from here, I could type show options again. And when I do that, I can see the specific variables that we could set the value of using the set command, by the way. We can also see the current setting for the variables and whether or not the variable is required, whether it's mandatory. So I'm going to go ahead and type back just to back out of this. I'm also going to type in search. And let's say that we know that we've got a name of a specific category we're looking for. In other words, I'm looking for exploits related to the Microsoft platform. So Microsoft and then type : and then let's say exploit. So I'm searching for name : Microsoft, type : exploit. Now we can see that we have quite a large list that has showed up here. So this is how you would know, for example, what to use. Here we've got exploit Windows SMB, and we've got MS05. So I could use the use command. So I could say use exploit /Windows/SMB/MS05. And I can even use tab completion to finish it off by pressing tab, as long as I've typed in enough characters to keep it unique. Once again, we can see our command prompt has changed. We can say show options. We can start to see some of the variables here that we might want to set before we actually run any of these attacks. Most people on the internet will in some way partake in commerce, whether it's buying things through Amazon, setting up a PayPal account, looking for things on eBay, or doing online banking. In this particular example, we're going to show how incredibly easy it is to steal somebody's banking credentials. Now, the way that we're going to perpetrate this is by creating a fake website that looks just like the real banking website. It could be any website. We just happen to randomly choose Scotiabank Online Banking. So what I'm going to do then is copy the URL for the real site first to get started. Now that I've copied the URL, we're going to switch over to Kali Linux. Now the reason I copied that URL is because we're going to tell Kali that we want to clone or copy that website. Even though it's going to be under our control, it's going to look legitimate. That's where things start to get really scary. So here in Kali Linux, I'm going to run the SE toolkit. As you might guess, SE in this case stands for social engineering. It's hard to believe that we have a menu system with a bunch of social engineering hacks, but it is what it is. So I'm going to start with number 1, for social engineering attacks. I'm looking at website attack vectors in this case. So number 2, and I want to try to get people's banking credentials. So I'm going to press 3, which takes me into credential harvester attack method. I want to harvest their banking credentials. Number 2, site cloner. Well, that's why I copied that Scotiabank URL initially. First of all, we have to give it the IP address where we want results spit back to. And that, in this case, is going to be the Kali Linux host that I'm sitting at. And it already has the IP address for that in square brackets. I'm just going to press enter to accept it. Then I have to enter the URL to clone. So I've gone ahead and pasted in my Scotiabank authentication page. I'm just going to press enter. And essentially, it now tells me that the credential harvester is now running on port 80 on this IP address, so the one listed up here for Kali Linux, and that any information that is of any use is going to be displayed here on this screen. It'll generate a report after we exit out if we want to exit out of the social engineering toolkit. So this is interesting. What we need to do then is somehow trick people into visiting this IP address. Of course, we could use a DNS name that resolves to it. Okay, well that was easy. I'm now in my browser connected to the IP address of Kali Linux where we've cloned this Scotiabank sign-in page. It looks pretty legitimate. So if I start entering in a username or a card number and a password, so I'm going to put a password in here. When I click sign in, the user isn't informed that anything is wrong. And as a matter of fact, it looks like they're redirected to the real thing. It looks like we've got a secured connection. So the user won't even know anything happened. But why don't we go back to Kali Linux and see what it's telling us? Wow, I can see the username and password are both specified here based on what the user entered into that cloned fake Scotiabank web app. Naturally, you don't want to do this for real against people without their explicit permission. In other words, their knowledge of what you're doing. This is not something that is probably going to be looked upon favorably if you get caught doing it. So, standard disclaimer, only use this in an environment where you control everything or you have express written permission to do this type of thing. Now, this is one of those kinds of things that's very easy to do. It doesn't take a genius to make this happen. And the other interesting thing about this is it's a great way to really bring the point home to end users with training or training videos. So instead of spending time telling them about using complex passwords, because they're already going to know they have to do that, they're just going to have to do it when they have to reset passwords based on your password policies. But this type of thing is not so readily apparent. People need to be aware of how easy it is for the bad guys to do this through social engineering. So social engineering is one way to trick people into following this link, or maybe you've poisoned a DNS server or a DNS client cache so that when they enter the URL, it gets redirected to your malicious website on a different IP address than the real one. By far, the quickest and easiest way to take over or compromise someone's web browser is to fool them into clicking a link or visiting a website, or maybe even downloading a file and opening it that in turn infects their machine and gives control to the attacker of that web browser. We're going to see how that works using a Kali Linux tool called BEEF, B-E-E-F, which stands for Browser Exploitation Framework. So to get started here in Kali Linux, we're going to have to load up the BEEF daemon or server-side service for this to work correctly. So I'm going to change directory or cd to /usr/share/beef-xss, as in cross-site scripting. Then I'm going to use the sudo command to run the nano text editor that's built into Kali Linux, and I'm going to edit a file in /etc beef-xss, and the file's called config.yaml. One of the things that we can do here is specify the username and password that, as a malicious user, we would use to authenticate to the Beef web GUI tool, so the web interface. So once I've changed that, I can press Control X for exit, and if it prompts me to save to the file, I would choose the letter Y and press Enter for yes. Now that that's done, I'm going to use the sudo command again because I want to run this as a privileged user. And I'm going to run /, well, no, that'll work actually. I'm in the correct location, /beef to start up the beef daemon. We can see it's actually loading right now. We just have to wait a few seconds. And we can see here the IP address that it's running on, in this case, 192.168.4.52. Notice we also have a UI URL. That's what we would connect to manage any hooked or compromised web browsers. There's also a hook URL. There's a little JavaScript file here that we can actually use this and embed it within for example, an HTML document within script tags. And this is what would actually execute in victim web browser computers that would compromise their system and connect it to the Beef server. Okay, let's take a look at how this actually works. So in a web browser window, I've popped in that URL for the IP address of the Beef server. It listens on port 3000 by default, /UI, and then in this case, /authentication. And I'm going to put in my Beef credentials according to whatever I've placed in the Beef config YAML file. And after I've done that, it will authenticate me into the UI. Now here I've got online and offline browsers. Offline browsers are ones that were previously hijacked or connected to this interface. Now on the Getting Started page, we've got a couple of demo pages here that we can use to hook a web browser. So for example, I'm going to right-click on the first link for the demo page and copy that link. So this is what we would have to trick a user into visiting through a social engineering phishing email. So once they connect to this link, here we have a sample page that says we're hooked into Beef and have fun while your browser works against you. The web browser is now compromised. Now, sure enough, under online browsers, up here on the left, we can see the IP address of the browser, and it appears to be Google Chrome. I can just hover over it and get some details. It looks like it's running Windows 10. If I click on it, I can also see a number of other details that are available. So we can see the browser name. We can also see the platform. We can also see browser cookies. So here's a cookie related to hooking into the Beef GUI, this interface running on our server. And we can see a number of other details here, like the window title for the web browser that we've compromised, and the URI, and so on and so forth. So having done that, we have a number of interesting things that we can do. For example, we can go to logs, and we can see what's been happening. So for example, let's say I go back to this page, which is still active, and I'll type something in. I'm going to type in happy birthday. Even though it's not being typed in anywhere, I'm typing it in. So back here in the Beef control panel under logs, I'll just click the refresh button at the bottom, and we can see here I've typed in happy birthday. We can actually see that that is what has been typed in to that browser. That in and of itself is extremely alarming. There are plenty of things that are possible here. So let me just go to the commands tab here for a moment. And let's say we just go to, miscellaneous category, maybe raw JavaScript. Here we can send some JavaScript to the controlled browser. So here it's just going to say Beef raw JavaScript, and it worked. Let's go ahead and execute that. And it says that the command was sent, and let's just go check it out in our browser. If I switch over to Google Chrome, indeed, here it is. Here's our raw JavaScript that was just executed on this hooked browser. So you can start to send messages to unsuspecting victims so that you could trick them into doing something they otherwise wouldn't do. Now, we wouldn't do this under normal circumstances. We would only do this in a test environment for the sole purpose of learning how to mitigate or stop this type of activity. Back here in the beef control panel, there's just so many things that could be done. If I expand browser, let's say here, we could see hooked domain, and we could choose get cookie. We could execute that, and we could start to see the results. And it might take a moment before you start seeing results that are sent back here. You start to see cookie values. Cookies can contain sensitive token information for current web browser sessions on the user device. So that is a concern. There are other things that we can do. So for example, let's see, what else can we do here? We could close up browser. Maybe we'll go to network. So many options. Now, if we've got a green symbol, it means that beef has detected for sure that that will work. Although you just have to be patient. But just because something is red doesn't mean it won't work. It's not been detected that for sure it will from this interface. But again, it doesn't mean it won't work. So we've got a number of good things that we can do here. For example, if I go down under social engineering, this is a good one, fake LastPass. So LastPass, of course, is a password manager tool that is often used online that encrypts passwords. So we can actually trick people to essentially sign into LastPass. So here's how this would work. Choose fake LastPass, and then all we have to do is click execute over here on the right. And all of a sudden, this is what pops up in the user's web browser. And if they're a LastPass user, they might think, oh, my session must have timed out. I'll just log back in again. So I'm just going to put in some credentials here, and the user would click login, and hopefully they think everything is okay. Back here in beef, if I take a look at the result of sending that command to the hijacked web browser, we can start to see that it looks like the username, well, let's just scroll down at the bottom and make our life easy. The username specified then for LastPass was user, and the password was password. Scary stuff. We can even do other things, such as maybe making it look like there's a Facebook notification timeout or something like that. All of these things are possible here. For example, I'm still under social engineering. If I choose pretty theft on the left, I'm not going to change any of the default items here, but notice it's going to use a Facebook dialog box, but it could be YouTube, Yammer, it could be LinkedIn, it could be anything. If I leave it on Facebook and simply just click execute, this is what the user sees. And if indeed they are a Facebook user, it looks like their Facebook session timed out. And again, we could specify some details here. The user might say, oops, I better sign back in again. And they'll click login. Of course, this is now all available to the malicious user. So if we look at the command output for that, we can see the username or the email address and the password that was sent. So this can be a little bit scary. Now, interestingly, if I go all the way back up, see to network, we even have the option here of detecting social networks. There it is. And so, again, you have to be patient. So I'll execute that. And when I go look at the result of the command and come back after a minute, we're going to start to see that the user, well, let's take a look at an older command result. Gmail, the user is not authenticated to Gmail. Twitter, user is authenticated to Twitter. Well, that's a timeout. And Facebook, the user is authenticated to Facebook. So that might trigger the malicious user to start trying to trick users with Facebook dialog boxes. Now, in this particular example, we started this whole thing from getting started by essentially pulling up a page that was infected. And so if that page is stored on a server, then that would be an example of a persistent or a stored XSS or cross-site scripting attack. In this demonstration, I'm going to be using essentially a dictionary attack to crack a WPA2 passphrase for a wireless network that's configured with pre-shared keys, or PSK. So essentially what we really need to do is get a wireless network interface in monitoring mode. We need to essentially tell it that we want to capture traffic for clients on a specific existing wireless network. And then we need to save that to a capture file and apply our password file to the capture file once we've seen a WPA2 handshake to try to crack the passphrase. So here I've got the configuration page in my browser pulled up for our sample wireless router. This is a wireless router entirely under my control for testing purposes. You don't want to run these kinds of tests against wireless routers that you don't have permission to do that to. It could be considered illegal to try to crack these passwords because there is an intention of privacy. So be careful how you use these tools. So I can see if I click in the WPA PSK, that's the pre-shared key field, I can see we have a variation of the word password as the password for this Wi-Fi network. I can also see the wireless network name, the SSID. Up at the top here, the wireless network is called RT-N628-2G. Here in Kali Linux, I'm going to type iwconfig, where I can see I've got a wireless network interface here called WLAN 0. What I need to do is put that into what's called monitoring mode, because what we want to do is watch any conversations between clients that are authenticating to the wireless router. If we can capture that traffic, we can then try to brute force it to guess what the password is. Here in Kali Linux, I'm going to type iwconfig, where I can see I've got a wireless adapter in the form of an interface called WLAN 0. So here I'm going to run airmon. I want to monitor network traffic. I want to start it, and the interface I want to do that for is WLAN 0. Now, what we're trying to do here with monitoring traffic, we want to capture any clients that are authenticating to the wireless router and then dump that into a capture file. And what we're going to do then is try to brute force the password from a password list against the capture file. So I'm going to clear the screen and type iwconfig once again. And when I do that, notice the interface has been renamed. Now it's called WLAN 0 Mon. That's good. That means we are now in monitoring mode. So now what we want to do is start to gather some information about clients that will be authenticating to that wireless network. First things first, let's run arrow dump-ng, and right now our interface is called WLAN 0 Mon. What I want to do with this is get a list of wireless routers in the vicinity and also get their address information. Each of these lines that we see here is showing me a number of different wireless networks. There's our RT, well, it keeps changing, but there's our ARIS, there's our RT600. There's all kinds of wireless networks that show up here. We can see if they're using WPA2 or if they're open or WPA3. And we can also see the 48-bit MAC address, the hardware address for the wireless interface in each of those wireless routers, and that's under the BSSID column. Now, having done that, what I really want to do is just press Control-C to get out of there. It says quitting at the bottom. Our network that we are interested in is this one, RT-N628-2G. We can see it's listening on channel 9, and we can also see its MAC address, which I'm going to select and copy by pressing Copy. Now, why did I copy that? Because we need to focus our attention on monitoring traffic for clients authenticating to that specific interface on that wireless network. Okay, so having done that, how do we make that happen? So now I'm going to run arrow dump-ng-bssid, and I'm going to right-click to paste in the MAC address of the Wi-Fi interface in our wireless network, our router. Then I'm going to specify -C9, because remember, that wireless network is using channel 9 for communications. I'll use the --write parameter to write out to a file. I'm going to do that by specifying a location. So maybe the / the root of the file system on this host, and WPA. That'll be the prefix for the capture file names. And finally, I need to specify the interface I want to capture on. And we know that that is now called WLAN 0 Mon. When I press enter, what I'm seeing at the top here is simply a reference that, yes, that is the MAC address of that wireless network. What I want to do at this point is make a connection from a client device. So I'm going to use my smartphone to make a connection to that wireless network. And sure enough, we can now see that we've got a connection on our wireless network from a client device. This is the MAC address of my smartphone. Now, what happens is we want to be capturing traffic when that occurs. Now, if clients are already connected, we can actually de-authenticate them. There is a command in Linux that will allow us to do that. It's the air replay-ng command. You can de-authenticate them, which forces a re-authentication, so you don't have to hang around and wait for this to happen. In this case, we just happen to see a client has connected. So we're ready to go. I'm going to leave that open and switch to another terminal screen for Kali Linux. Now, before we do that, just to note, we know that we've got what we need because we can see the WPA handshake was captured. We see this in the upper right. We don't see what it is, but we know it was captured, so now we can compare our brute force password list against it. So back here in Kali Linux, in a second terminal window, I'm going to use the cat command to take a look at USR, share, word lists, and I've got a sample text file where I've placed just a handful of password variations so we can expedite this example. Realistically, you would have a larger file. If I just bring up the up arrow key, there is a sample here in Kali Linux. It's called rocku.txt, and that's a much larger file with many, many variations, as you can see. And so there's no specific amount of time it might take to crack this password through brute force mechanisms. However, it's going to be much quicker because we have just a tiny sample txt file here. Okay, let's make this happen. So first things first, we also want to make sure we know which capture files are currently being used. So if I do an ls of the root and any files that end with .cap, remember we use the prefix of WPA to write output to? So there's the file wpa-01.cap. That's important to know. And you'll see that as we enter in this current command. So what we're going to do is we're going to run aircrack-ng, and I'm going to specify the name of the capture file here on the root that we are interested in. So that would be wpa-01.cap. The next thing we have to do is specify our word list, -w. That's USR, share, and we just looked at that a moment ago, and it was called sample.txt. That's it. Press enter. And immediately, this is what we're looking for. It found the key. It knows that the passphrase to connect to this WPA2 wireless network is shown here as a variation of the word password. Now, we're lucky. It was very quick because we have a tiny word file. It could take much longer than this in reality, but it is possible. You can use the Linux dd command to acquire an image of a disk partition for forensic analysis. But the first thing that you're going to have to do in Linux is take a look at the partitioning of the disk devices on this Linux host. Now, in a forensic situation, you will probably boot through alternative means like a live boot CD to get an image from that machine. So I'm going to run fdisk-l. What we've got here is our first device /dev/sda. It's about 40 gig in size. Then we've got /dev/sdb, which is about 8 gigabytes in size. SDB has been carved up into one partition /dev/sdb1. So it's pretty much the entire size. It's about 8 gigabytes. What I want to do is I want to take a bit-by-bit copy of SDB1 and store it as an image file for image analysis. So first, I'm going to generate a hash for that, and then generate a hash after we take an image. So I'm going to clear the command. So I'm going to clear the screen and run SHA-256-SUM. This is a built-in Linux command. I want to generate a hash of /dev/sdb1, and I'll use the output redirection symbol, a greater than sign, to redirect that to /sdb1_orig_hash. So just writing out to a text file. So depending on the size of that partition, SDB1 will determine how long it'll take to generate a hash of it. And before you know it, it's done. Why don't we use the cat command in Linux to take a look at that SDB1 original hash file to see what's inside. So here's the unique hash for /dev/sdb1. That's a SHA-256 hash. Okay, so now we can use the dd command to actually take a bit-by-bit copy of that entire disk partition. So dd space input file if equals /dev/sdb1. Now we want to copy that out to another location. So output file or OF equals /sdb1.img. We're going to store this image file on the root of our file system. Okay, so it's completed the copy. If we do an ls of the root of the file system of all items that end with img, we've got our sdb1.img file, our image file. Let's run a hash on that. So SHA-256-SUM space /sdb1 image file. Okay, so if we compare the current hash we've just taken is identical to the hash above of the original device. So we know we've got a forensically sound copy, bit-by-bit copy, of the original disk partition, so that original file system. So now we can analyze the file system using whatever tools are required to perform the analysis. Now, when you gather evidence in digital forensics, you sometimes want to make a copy of a disk partition and then analyze it later. So we've just already taken a copy. So let's take a look here with ls/ everything on the root again, and there's our sdb1.image file that we took. So this means it's the second disk device, SDB, the first would be SDA, and this is partition 1 on that device that we've got copied into the image file. Now in Linux, the file extension doesn't really matter. It doesn't hold the same relevance that it would in a Windows environment, but that's okay. We'll still work with it as sdb1.img. So other technicians that would acquire this for analysis would run SHA-256-SUM against the image file to make sure it matches the original hash of the original file system. Now we've already done that, but this is what another person would do if another person is playing the role of the analyst of that forensic image. Now bear in mind, this is a SHA-256 hash. If you were to use another algorithm, so let's say you used the MD5 sum command for a message digest version 5 hash, which really is deprecated, you shouldn't be doing that, but if you did, you would get a different result. So make sure that you use the same hashing algorithm that was originally used when you do your comparison. So the analyst would then compare that to the original hash. If we can use the cat command to look at the original hash, and we know again that they're the same. Okay, so this might be spread across multiple persons. Now to get into the image of that Linux file system, we need to mount it so we can examine it. To do that, I'm going to make a directory as a mount point location. So it's going to be on the root. So if I were to ls the /analyze directory, it's empty. So I'm going to mount /sdb1.image to /analyze. Now what if I do an ls of analyze? I can see the contents of that forensic image file. And this is what we would analyze. So we would use whichever tools are required to look at file contents, maybe recover deleted files, and so on. In this demonstration, I'm going to use a forensic disk imaging tool to both acquire a disk image and also to analyze it. Here specifically, I'm on the Access Data website where I can get a free copy of the Forensic Toolkit, or FTK. If I expand that, I can go to the download page for the latest version of Forensic Tools, which I'm going to do. So I'm going to click to open that page. Now that I'm on that page down below, I'm going to click the Download Now button. That'll take me down on the page where I can download full disk ISO files. So I'm going to click the AD for Access Data Forensic Tools. When I click that button, I'm then prompted to save the download. So I'm going to save this in my local downloads folder. Okay, so I've installed the Forensic Toolkit and I've restarted my computer as required. But before I get into it and use it, here I've got a USB thumb drive, drive letter E, that I've plugged in, and it's got a number of files. Now, I have deleted a few files off of the root of this USB thumb drive. There used to be a logo.jpg file, and there used to be a project A txt file, but of course, these are no longer shown on this USB drive. So I'm going to go ahead and go to my Start menu to start the Forensic Toolkit, or FTK. So I've opened up the FTK imager, and the first thing I'll do here is click the second button in the toolbar from the left that, when I hover over it, pops up and says Add All Attached Devices. Drive letter E, as we know, is our USB thumb drive, and if I expand that, I'll have my file system shown. If I go to the root of the file system, I'll see files and directories that are currently there, but items with a red X to them have been removed. Examples being logo.jpg. Even though the file was removed, I can still select it and actually see the contents of that file. Same goes with project A.txt. So those files were actually removed from the drive and were unavailable. However, what I would want to do here is take a forensic image of that device if it was going to be collected for potentially being used as admissible evidence in a court of law. So I'm going to right-click on that drive, and I'm going to choose Export Disk Image. And what I'm going to do is specify a destination of where I want that stored. So I'm going to take a raw image. Notice it has DD here. In parentheses, that's a reference to the Linux DD command. I'm going to choose next, and I'm going to give it a case number of 4567, evidence number 123, description, USB thumb drive found at scene. The examiner, I'll just put my name in here, and I'll leave notes empty. So I'm going to go ahead and click Next. So the image destination folder, this is where I'm going to go specify a location to store the image file. So I've specified the location. I've created a nice folder structure for that case, and I'm going to specify an image file name. I'm going to call it USB thumb drive 1 underscore 123 underscore case 4567 for the file name. And I'm going to go ahead and specify finish. Now, what I can do is verify images after they are created to make sure that it isn't corrupt or anything like that. So I'm going to go ahead and start with the creation of that forensic image. Okay, so it's finished creating our forensic image, and we have the computed hash at the MD5 level as well as the SHA-1 level shown here. Those are different hashing algorithms, of course. So I'm going to go ahead and close out of that. Now what I could do here is click the first button to the left to add an evidence item. So I can specify the source, such as an image file. And I could specify the path to that image file. So I'm going to go ahead and select our newly created forensic disk image for that USB thumb drive. Once I've specified that, I'll go ahead and click on Finish. So this is what another analyst might do, for example, on a different station using an analysis tool like we've got here. Now, from here, what we could do is expand it and again start to drill down and explore the file system. For example, even looking for items that were deleted. But at this point, if you're going to start doing an analysis, it should always be on the forensic image and never on the original disk drive itself. Now, I could also right-click on that image that we've now loaded, and I could choose image mounting to make it available, for instance, through a drive letter, such as in read-only mode. So I could go ahead and click Mount to make that happen. It's going to use the next available drive letter, which in this case is going to be drive F. And so now in Windows Explorer on that machine, if I open up drive F, I'm exploring the contents of that drive in read-only mode because it's been mounted onto drive letter F. Back here in FTK Imager, I'm going to close that out. I could also right-click on our image here, and I could choose to verify it. Let's give it a moment to verify that image. So again, what we saw when we created it is we had an MD5 and a SHA-1 hash, of course, that were available here. So we could copy that, screenshot this, whatever the case is that we need to do in order to verify the integrity of that evidence. Now, generating a hash of the entire image is great, but what about a hash of all the individual files within that forensic image? So for that, I'm going to select my USB thumb drive image here, and I'm going to choose File, Export File Hash List. And after a moment, it begins with the hash generation. So once the list of hashed files is completed, let's open it up and take a look. So that is a CSV, a comma-separated value file. I've elected to open that up in Microsoft Excel. So why don't we just kind of expand this all out? So we've got the MD5 and the SHA-1 hashes for each and every item that is available on that forensic image, including items that were deleted, such as our infamous logo.jpg file. We've got the MD5 and the SHA-256 sum. So there you have it. This is how we can acquire a basic forensic image and begin to take a look at some of the data within that forensic image using the FTK Imager tool. The Android Debug Bridge, or ADB, is normally used by software developers for debugging and testing software on an Android device. But you can also use it for forensic purposes, like to acquire data from an Android phone, normally connected through USB. It doesn't have to be, but that's the wired way it's done. So here on my Android-based smartphone, I'm currently in the settings. And what I want to do is I want to be able to enable developer mode so I can use the Android Debug Bridge software on a connected station. So I'm going to go down and tap About Phone. I'll tap Software Information. Now from here, what I need to do is tap the build number 7 times. It'll show me a little countdown as I start to do that, and it'll tell me how many more taps I need until I get to the magical 7. After which, I'm prompted to enter my PIN. Once that's been done, developer mode is now enabled on my Android phone. So if I go back into my settings at the very bottom I'm going to have my developer options. I can select that, and I have a number of options I can play with here, such as enabling connectivity, for instance, through USB mode and selecting the debug app and so on. So there are a lot of settings here depending on how you plan on using the phone. Now, the next thing we need to do is actually download the Android Debug Bridge software. We can do that from developer.android.com. So from here, I will download this and then run the installer. Next, if I go into the Windows Explorer and navigate to the installation location, which in this case is drive C under Program Files x86, Android, Android-SDK, and then finally Platform-Tools, what I'll notice is the presence of the adb.executable program. That's the Android Debug Bridge. So what I want to do then is I want to navigate to this path from a PowerShell command prompt. So here in PowerShell, I'm going to change directory to that path. I've pasted it in here, but I've put double quotes around Program Files x86 because there are spaces within that structure name. So I'm going to go ahead and press Enter. Now I'm in that location, so if I do a dir, there's the adb.exe, the Android Debug Bridge. So how do we work with this? Well, the first thing I might do is run /adb, it's in the current directory, space devices. Which devices do we have? Currently, it doesn't list anything. Now that can happen if you haven't enabled USB debugging in your Android phone settings within your developer options. So just because developer mode is on doesn't mean USB debugging is on. So if I were to do that and then allow connections from the computer where I've got my USB cable plugged in, now when I run the list of devices command, adb devices, I now see my Android smartphone listed. So from here, there are a number of interesting things that we can do. So for instance, I can run ./adb shell. So now I'm basically connected to my Galaxy A51 Android-based phone as evidenced by the command prompt. And from here, if I type ls, I am actually viewing what is available on that device. Now, I might have permission denied messages for a few items because I'm not essentially logged in as root. I haven't rooted that device, and I don't want to root that device. If I run change directory, let's say to /SD card, we can then view the contents of the SD card on this device. So here, for example, if I were to go into music, I would see any music that is available on that device. If I were to go into movies, same thing. If there are any movies on the device, I would see them. If there are podcasts, pictures, all that stuff. We're actually browsing the contents of that device through the Android Debug Bridge from a Windows station, although we're connected to an Android-based phone. So let's say I were to run the screen cap command. I want to do a screen capture of whatever's on the screen on the phone right now, and I want to store that in the SD card, and why don't we call it screen1.png. Okay, so if we take a look here at the SD card, we've now got screen1.png. Well, why don't we actually pull that from the Android device onto the laptop and take a look at what was happening on the phone at the time I took that screenshot. So if I were to go into the GUI, let's say, and just navigate the root of that phone, there's the screen1.png file, and if we double click it, here's the screenshot. So it looks like I was in the USB debugging screen where USB debugging was enabled. That's a screenshot of the phone that we captured through the Android Debug Bridge. Now we can also record the screen and not just be satisfied with the screen grab. For example, back here in PowerShell, if I were to run .adb shell screen record, let's say /SD card /1.mp4. That's what the recorded file will be called. At this point, it's recording everything that's happening on that Android device. So let's say I just go back, for example, into my settings and maybe go into connections and maybe just go into Bluetooth. Anyways, let's stop the recording at that point with Control-C and then we'll check it out. Back here in Windows Explorer, I've gone to my Galaxy A51 Android phone, and now we have a file called 1.mp4. Let's play it. I'm going to double click and open that up. So here it's playing inside the VLC media player, and we can see I was going back in my phone settings all the way up to connections and then Bluetooth. So there you have it. There are a number of interesting, cool things that we can do through the Android debug bridge, even if we're not an Android software developer. Steganography is all about hiding things in plain sight. For example, embedding secret messages within a benign-looking JPEG image. And there are plenty of freely available tools in the public domain that can do this for you. One of which is JPHS, which stands for, as it says on the download site, JPEG Hide and Seek. So we can go ahead and download this file. It's a zip file, after which we can then run the tool, which shows up here, where we can specify a JPEG file that we want to open, so a benign-looking image. Then we can embed a secret message within it with some kind of a passphrase, and then the recipient would have to know that passphrase to retrieve the secret message from the JPEG. So the neat thing about this is that we could attach the JPEG file to an email message and send it off to somebody without fear of someone being able to intercept and then read that message. The only way someone would know that something was up with that file really is if they focused on it and tried to reverse engineer something within it, or if they had a file hash of the same original file, which probably wouldn't happen with the random picture, like it would with an operating system file, for instance. So let's take a look at how the JPEG hide and seek tool actually works. Okay, so which ingredients do we need for this nefarious recipe? Well, we're going to need a JPEG file, we're going to need a secret message file, and we're going to need the program. So if I open up the picture, I've got a picture of a dog. My dog is wearing a straw farmer's hat. Looks pretty innocent and cute and fun. But what we're going to do is embed a message within it. Now, as an added layer of fun, why don't we generate a file hash of the picture of the dog before we embed the secret message within it? Because then we can do a file hash comparison after the message is embedded to see whether or not the hash is different. You can probably guess what the result will be, but we'll confirm it afterwards. So first, let's generate a file hash. Okay, so here I'm in PowerShell on my machine. I'm on drive D in the temp folder. If I type dir, there are the files we were just looking at. So I'm going to run the PowerShell get-file hash commandlet, and I'm going to run that against my JPEG, which is called doggy.jpg. And it generated a SHA-256, that's the default hashing algorithm that gets used. It generated a hash based on that input file. It begins with 558C, 59A, and so on. We'll just keep this on screen because we're going to come back and generate a hash after we've embedded the message in it. So let's go back and embed the message in it. So let's first double-click and open up our secret message txt file. It simply contains the text string, "This is a secret." Okay. So let's launch our JPHS, that's our JPEG hide and seek tool, executable. We can accept the terms of usage. And the first thing I need to do is get an input JPEG file specified. We don't have any details for a JPEG file, for the hidden file, or for the saved file, but we will once we complete the process. So for starters, I'm going to click Open JPEG, and I'm going to select a picture of the dog. So then the details about that JPEG file are listed under Input JPEG File. Next thing we want to do is click the Hide button. Now before we can select the secret file that we want to embed within this JPEG, we have to specify and confirm a passphrase. So I'm going to go ahead and do that, and I'll confirm it. Now, the recipient of this JPEG file must know this passphrase, and of course they have to be using this same tool, but of course it's freeware, in order to extract the hidden secret message file from the picture of the dog. So let's go ahead and click OK. Now it wants me to select the file I want to hide. Perfect. I'm going to choose our secret message txt file and open it. And now that detail is specified under hidden file. So we can either elect to save the JPEG, overwrite the original doggy.jpg file, or we could save it as a different file name. So in this case, I'm just going to click Save JPEG, and it overwrote the original doggy.jpg file. So let's go back to PowerShell then, and why don't we generate another file hash to see if it's the same as it was before we embedded the secret message, or if it's different. Okay, so back here in PowerShell, let's use the up arrow key to bring up the get file hash statement again against that file name, and let's press enter. As I'm sure you would have guessed, the file hash is different. because the file is different. It doesn't look different. If I double click and open the picture, it's still the same picture of the dog. And with visually inspecting it, really, I have no way of knowing there's anything else to that file but what I'm seeing. However, if I'm really looking for something and opening a hex editor to view the contents of the file, I might get suspicious about some additional data being in there. Of course, if I had generated a file hash and was comparing it, I would know the file had changed. But what are the chances of somebody doing that on just a random picture of a dog? Chances are slim to none. So let's play the part of the recipient of the JPEG file with the embedded secret message. So how do they get it out of the picture? Well, on their end, as we know, they're going to have the JPEG file. Presumably, we would have transmitted it to them, perhaps as an email file attachment. They're going to need the same program and know the passphrase. So I'm going to open up the program. Yes, accept the terms. So this is the recipient of the message doing this. So they would open the JPEG. Okay, so they would open the file that they received, presumably through email. Then they would click Seek. At this point, they're going to have to enter the passphrase, and they're going to have to confirm it. Then when they click OK, they're going to be prompted to save the hidden file. Why don't we call it extracted_secret message? And I'll click Save. There it is in the background. So if I open up the extracted secret message file, it reveals the original secret message embedded in the JPEG file.